you all enjoyed yesterday also as much as I did. This is the last day of our Colloquium, which for me has been a wonderful meeting of minds. And I don't have much to say by way of introductions to today's workshop, because I did most of the framing yesterday, and we want to make the most of our remaining time. And I'm not going to try and summarise everything that said yesterday, sifting the true from false and synthesising a single philosophical system, because that's Rob Koons' job at the end of the day. 10 minutes, and that's 10. But for those of you who have just joined us, one of you weren't here yesterday, just to say we are continuing to talk about the nature and reality and significance of middle-sized things. As I observed yesterday, there's been a tendency in philosophy to distinguish fundamental from non-fundamental reality, to identify the former with either microphysical things or the cosmos as a whole. Middle-sized things such as plants and animals might be arrangements of microscopic things or fragments of the cosmic whole, but they're not fundamental, they're not part of the furniture. And that goes all the way back to ancient philosophy and rival visions of Democritus and Parmenides, and many different views were expressed in the room yesterday. Today we turn from philosophy of physics and philosophy of mind to metaphysics in the field of science and religion. I think there are some people in the room today who are going to ask us to question some of the basic assumptions that went unchallenged yesterday, such as the distinction between fundamental and non-fundamental, whether or not we need a philosophical system, and whether or not we should be naturalists about certain middle-sized things like humans and animals. Timothy O'Connor will be chairing this first session, so over to you.
During the talks, I'll be seated over here just so I can see the slides. But so our first two speakers, you might think, are providing toolkits. It's kind of helpful after we've been doing a lot of metaphysics. They're kind of looking at some formal notions that underlie a lot of the discussions of reduction, emergence, etc., raising questions, showing you options or ways of thinking about things. So our first speaker is Professor Vera Hoffmann-Kolss, who's Professor of Philosophy at the University of Bern. And she does metaphysics with a kind of philosophy of science slant, and philosophy of mind as well. She's the author of the book, The Metaphysics of Extrinsic Properties.
Okay, thank you so much. Okay, so thank you so much. Thanks to all organizers, Jonathan and William, for organizing this great conference, and also thanks for inviting me to speak here. So the title of my talk is Higher Level Causation, Causal Models and the Proportionality Constraint. So I am going to focus on the question of at what level causal relations are, or at what level causal explanations should be given. And my background theory, as Tim already pointed out, is slightly different from what we heard yesterday, because I'm going to use the toolkit of probabilistic causal models. So here's the outline. I'm first going to look at arguments for higher level causation. So why should we be interested in higher level causation in the first place? And then I'm going to very briefly introduce the causal modeling framework. So I'm basically just going to present the fundamental idea underlying this framework, which is that causation is difference making. And I'm also going to focus on one specific condition that is usually imposed on the models in this framework, which is the so-called causal sufficiency condition. And that's a crucial condition that you need for this framework to work. And then I'm going to focus on the notion of proportionality, which is roughly the idea that if you're considering a certain higher level effect, the cause of that effect, or the causal explanation of that effect, depending on where you want to apply that notion, has to be at the same level as the effect. So it has to be proportional to the effect in the sense of being at the same level. And then I'm going to look at a fairly specific problem for the causal modeling framework, which is that if you combine causal sufficiency plus proportionality, there is a tension, there is a problem. And in the last two parts of the talk, I'll sketch a solution for that problem. Okay, so here's some higher level causal claims, or causal claims involving middle-sized objects or causal relations between middle-sized events. So the hot weather in the summer of 2023 caused water shortages in many European countries. Jimmy's missing the tube caused him to miss the train. Joanne's cheerfulness caused Jimmy to be cheerful. Jimmy's not watering his mother's plants caused his mother to be angry. And contact with a person infected with COVID-19 can cause you to become infected with COVID-19 as well. So, and obviously, you could easily continue that list. So, both everyday contexts and explanations in the special sciences, and special sciences, sciences such as biology, psychology, and also sciences considered higher levels such as economic, the social sciences, strongly suggest that there are causal relations between properties of middle-sized things or between middle-sized events. And by the way, this is also assumed when we argue that, at least in most cases, causation is a necessary condition for moral responsibility. So the idea that we can only be held responsible for outcomes that we've caused. So the idea is that usually the outcomes of our actions are at the level of middle-sized things, and also the people performing those actions are middle-sized objects. So therefore, if there is such a thing as moral responsibility, that seems to presuppose that there is causation at an intermediate level. So this suggests that there is higher level causation, and recent interventionist and causal modeling frameworks are usually considered particularly well suited for describing such higher level causal relations. So here's the very rough and sketchy idea underlying interventionism in causal models. So the idea is that causal relations can be described in terms of a causal model, and a causal model, formally speaking, is a set of variables and a set of directed edges between those variables. And so the idea is that the variables represent the relata of the causal relation, and the directed edges represent the causal relations. And then those models are supposed to satisfy a number of formal constraints. I'm not going to discuss them here, but I'm happy to say something about that in the discussion. But so the basic idea is that if you look at two variables, x and y, that occur in a causal model, and then x is causally relevant to y if and only if there is a possible intervention on x, or on the value of x, that changes the value or the probability distribution of y, while the values of all other variables contained in M, but not on the causal path between x and y, are held fixed at some value. And so there's the idea that x is a cause of y if x is a difference maker for y, or a difference maker for the probability distribution of y, and this other condition, so that the values of all other variables contained in the model have to be kept fixed, is supposed to exclude confounding factors. And now, one of the key challenges for this framework is that it's just a formal framework. And so a formal framework could be used to describe anything. And so the question arises of why are we allowed to interpret the formal relations that occur in that framework causally? And many people working on these issues agree that at least minimally the formal framework has to satisfy a number of additional conditions, because otherwise what you get is just equations or probability distributions, and of course we've all grown up with the platitude that mere probabilities won't give you causation. So we need at least some additional conditions. And one of those additional conditions is the causal sufficiency condition, and which says that a causal model is causally sufficient if and only if, for any two variables in that model, all variables that are both a direct cause of x and a direct cause of y are also contained in the model. So basically the recipe is add all the direct common causes. So why is that important? Here's a standard example. So suppose your model contains three variables. S represents the occurrence of the storm in a particular region at a particular time. P represents atmospheric pressure differences, and B represents barometer readings, or the reading of a particular barometer in that region. Then you, prima facie, you might think, okay, so there's a good correlation between B and S, because that is precisely why we use barometer readings in order to predict storms. However, that causal relation, however, that probabilistic relation is not a causal relation. So, and the intuition is that you can't manipulate your barometer in order to bring about a storm or vice versa. So if there's a storm, that doesn't directly causally affect the reading of that barometer. So what you shouldn't do is draw a causal arrow between B and S. However, if you add P to the causal structure, you see immediately that there is a common cause underlying that correlation. So if P is added to the causal graph, and if the value of P is held fixed, then the putative causal relation between B and S disappears. And so technically or probabilistically we say that P screens B off from S. So what you get here is that causal sufficiency is one of the conditions used to ensure that mere correlations are not misclassified as causal. In fact, you need other conditions as well, but I'm going to focus on this condition here. And as I already pointed out, ensuring this is one of the key challenges for probabilistic causal models. Okay, so where does higher level causation come in now? So most of you, or all of you, will have heard of Sophie the pigeon. So this is an example that was given by Javier in 1992, and which has been quoted multiple times. So here's the basic story. There's this pigeon, Sophie. She's been trained to peck at red objects as opposed to, say, green objects. However, she does not discriminate between particular shades of red. So the idea is that there's basically a 1-1 relationship between X and Y. So Sophie pecks if and only if she sees she's presented with a red object. And however, there are several possibilities to describe that situation. So you could either simply use the variable X, so which just represents whether that object is red or non-red, but you could also use a more fine-grained variable which represents the particular shades of color that the object might have. And the idea, or Javier's idea, is that citing X, so the coarse-grained variable, rather than the fine-grained variable as the cause of Y is more appropriate because X star is too specific. And this is in line with the difference-making idea underlying the framework of causal models. So the particular shade of red of the object is no difference maker to Sophie's behavior. As long as the object is red, it doesn't make a difference whether it's scarlet or some other shade of red. Now, let's extend this little model a bit and add another more fine-grained effect variable. So you could also consider a variable which measures the wavelength of the light emitted from the surface of the object. And yeah, so you could say, okay, that's to put this into a causal story, you could say, okay, that is the output of a measuring device. And then that's a different effect variable. And the idea is that in that case, citing x star rather than x as the cause of that is more appropriate because x is not specific enough. So here, in fact, what value x star takes makes a difference for the value of z, and that's why we should consider x star rather than x. And that's the basic idea underlying proportionality. So roughly the level of grain of the cause variable should match the level of grain of the effect variable. And so if there are higher level causal effects, and let's assume there are higher level causal effects, then we need a criterion for when to assume that there are also higher level causes. And the idea is that proportionality is prima facie plausible because it provides precisely such a criterion. And that is the reason why people who are in favor of higher level causation often supplement their theory of causation with something along the lines of such a proportionality principle. However, and this is what I'm going to argue now, is proportionality seems to be incompatible with causal sufficiency. Now maybe, okay, so incompatible is a pretty strong word. At least there's a tension between proportionality and causal sufficiency. And here's why. So this is the previous model again. And now typically causal models contain not just 2 or 3 variables, but are more complex and contain more variables. So let's consider what happens if we create a model that includes all 4 variables. Then obviously there will be a correlation between y and z. And what we've just learned from causal sufficiency is that this correlation is not a causal relation, so we have to look for common causes. And now in fact there are 2 candidate common causes. One is the variable x, so you might think that you have to, by causal sufficiency, what you have to do is you have to insert x into your model. But if you take proportionality seriously, this immediately creates a problem, because what we've just learned from the previous section of the talk is that the relationship between x and z violates proportionality. So that causal relation is good, that one isn't. Okay, now let's consider the other option, and then you could already guess what happens. So the relation between x star and y violates proportionality. So if you're supposed to add common causes that are intended to explain the correlation between y and z, then proportionality gives you contradictory or yields a contradictory judgments about which variable to include. Now you might say, okay, so therefore y and z should not be included in the same causal model. So then if there are 2 separate models, 2 separate sets of variables, proportionality is not violated. However, if you impose such a strong requirement or such a strong adequacy condition on causal models, it means that models can only contain variables that are all on the same level. And this excludes far too many models. And in particular, this includes many models that are actually given and discussed both in the sciences and in philosophical discourse. So there's a dilemma here. Either proportionality is violated, or variables at different levels cannot be included in the same causal model. At least not if what you're getting is such a structure. And so, more generally, complex causal structures that include variables describing phenomena at different levels will usually contain causal relations that violate the proportionality constraint. Not always, but once you know how these examples work, it should be fairly obvious that you will often find structures of that type. And now, one could solve this problem by considering only one cause, one effect relations. So you might say, okay, all I'm interested in is the relation between x and y, and I'm not interested in the larger model. Or by considering only models that contain only variables that are at the same level. Then that would rule out that type of problem. However, I think this would be way too restrictive, because the central purpose of causal models is precisely to describe complex causal structures, and also causal structures that span several levels. So that's one of the central aims of that theory. So what we need is a general criterion for applying proportionality to complex causal structures. Now, one simple option could be to say that whenever proportionality leads to conflicting judgments about which cause variable to choose, then you should choose the the lower level one. Okay, so just impose that additional rule on causal models and say, okay, use proportionality whenever possible, but if there's a contradiction arising from your proportionality criterion, then simply pick the lower level variable. And actually some people, so particularly people who have reductionist inclinations, might be totally happy with that option. The problem is that it might not leave much room for higher level causation, because if you're willing to consider complex causal structures, you can almost always find a lower level side effect. So your cause at some point will have some lower level side effect, and then by proportionality all the causes need to be lower level as well if you apply that criteria. And as I said, some people might be happy with that, but if we are looking for higher level causal relations, that might not be the best option. Okay, so about the opposite option, whenever proportionality leads to conflicting judgments about which cause variables to choose, choose the higher level one. And now this, I think, leads to an even more serious problem. And this is a problem that has been known in the causal modeling literature for a while. So here's an example that's discussed by Spurdy, Lima, and Shines, and they attribute it to Davis. In fact, it's called the bulky switch example. A TV set has a bulky switch, and so it's unreliable and usually turns the TV set on, but not always. So, when the TV set is on, both sound and picture are off. When the TV set is off, both sound and picture are off. Now, there's obviously a strong correlation between sound and picture. So actually the example is such that there's a 1-1 correspondence between sound and picture. But that correlation cannot be explained or screened off by the position of the switch. And the explanation that people usually give for this is that the position of the switch is too coarse-grained to explain or to screen off what's going on inside the TV set. Now, let's consider a slightly more complex model. So, suppose there are two candidate cause variables. So one is the binary variable, which just represents whether the switch is on or the switch is off. And P is the underlying, more fine-grained variable, which represents the exact physical state of the TV set. And then there are two variables that represent sound and picture, and another higher level variable which represents whether Jimmy sees that the switch is on or whether he sees that the switch is off. Now, once again, the question is what our model should look like. So one candidate model is this one. So there are the three effect variables. Then you pick the lower level variable P and consider it to be your cause variable. Now P explains the correlation between P's SO and PI, so sound and picture, but of course the relation between P and J violates proportionality. So if there's an additional higher level variable in the model, proportionality will be violated. On the other hand, so we're still considering option 2, and option 2 said that whenever there's a case of conflict, use the higher level variable. Okay, so what happens if we use the higher level variable? Then proportionality is violated. Okay, we knew that already. But, and that is the crucial point, S does not explain the correlation between sound and picture, because we are picking the higher level variable. And therefore, because one of the crucial challenges for causal models was not to conflate correlation with causation, that is a really bad result. So simply choosing the higher level cause in such structures is not an option. Okay, and now this could be bad news for the causal modeling people, because they designed their models to describe higher level causal relations. And so what you get eventually is that if you're considering models having this structure, and if you consider complex models, it's pretty likely that at some point a structure like this will come up. Then you always have to pick the lower level variables. So here's a sketch of a solution, how people might deal with this, but this is still sketchy, and I'm happy to discuss it. So how can or should we use proportionality in complex causal structures? Well, so keep causal sufficiency, so make sure causal structures are causally sufficient by adding direct common causes of the variables already included in the structure. So that's just the ordinary causal sufficiency condition. Then, when selecting cause variables, apply proportionality whenever possible. And whenever possible means whenever there's no conflict in terms of proportionality. And if applying proportionality leads to conflicting judgments, distinguish between two cases. If a lower level common cause variable can explain a correlation that cannot be explained by the corresponding higher level variable, always choose the lower level variable. So basically that's just a theoretical description of the case we've just been considering. And otherwise, so if the higher level variable can explain all the correlations explained by the corresponding lower level variable, choose the higher level variable. Okay, so what's the upshot of this for the metaphysics of causation? I've pointed out that causal models provide a very useful tool for describing causal relations involving middle-sized objects or middle-sized events. And one limitation of this approach, and I'm happy to discuss this as well, is that the formalism of causal models as such cannot decide on what level causation really is, metaphysically speaking, because it's just a formalism. But I think, and that's the reason why I think it's interesting to consider this tool in the context of the debate on higher level things or middle-sized things is that if we take for granted that there are higher level effects that should be given a causal explanation, then causal models plus proportionality considerations can at least help choose the right level of causation or causal explanation. So here are the references. Thank you.
All right, while Jonathan sets up the slides for our next speaker, I'll introduce that speaker. It's Aaron Cotnoir, who is a senior lecturer in philosophy at the University of St. Andrews. Aaron works in metaphysics and philosophical logic, does a lot of formal issues, kind of brings logical tools to bear on metaphysics. He's the co-author of a book, Mereology, The Logic of Part and Whole. And he also has worked in philosophy of religion and philosophical theology. So once the slides are ready to go, take it away.
Great, thanks very much. Thanks for being here, and thanks for the invitation to come and speak. So I'm a sort of metaphysician in the analytic tradition who's resisted the siren song of Aristotelianism. Actually, interesting fact about the myth of the sirens. Historians have sort of like discovered that on the sort of rocks of Scylla, when the Argonauts were sort of in the boat traveling towards them, they discovered the source of the siren song, and it was actually William Simpson and isomorphism. His voice is very soothing. I don't know. It's like
this is what you wanted, or not?
Yeah, this is the one. Yeah.
That for reasons that only the person who designed this could explain. What you're looking at here is one monitor, like there is another. So the mouse can wait.
So I'll look that
You'll
way.
have to look that way.
Okay,
Sorry.
great, yeah.
That would be great. PowerPoint works, but PDFs don't.
It's not advancing.
As a slide,
Yeah.
but it's.
Oh, I just find my. Sorry to delete your There we go. Well, that's the movie.
You just tap underneath it.
Or tap this.
Full screen?
Tap this.
There we go. Great, thanks.
A clicker if that would help.
No, this is perfect. Yeah. Excellent. Okay, so I sort of have resisted Aristotelianism, although I'm tempted by many of the things that Aristotelians want to say. And this is kind of, when I started thinking about issues to do with naturalness, I have sort of reasons for wanting to think about that to do with Mereology. But because of Lewis's influence, David Lewis's influence in metaphysics, I wanted to sort of start with the sort of most influential treatment of the topic, and I sort of got into the weeds and realized that I didn't really understand what naturalness was supposed to be on that picture. And so I want to sort of go through some of the process, my process of thinking through what the options are and aren't, and then suggest some options for people moving forward if you sort of like this way of thinking. Okay, so I'll introduce the topic and discuss some problems, and then I'll have some takeaways for you. Great. So the background is abundant ontologies versus sparse ontologies. So abundant ontologies have permissive existence criteria and are often tied to quantification or reference and true theories, that kind of thing. So an abundant ontology will accept quite a lot of things. Sparse ontologies will be more restrictive in that their existence criteria will be strict, sometimes tied to objective similarity or causal powers, that kind of thing. So abundant theorists sometimes attempt to single out an elite class of their entities to play the role of the sparse entities for sparse theorists. So that's the basic distinction. And so if you like sort of very full ontologies, but you still want to reserve entities that play certain roles, then this is naturalness is a kind of strategy that you might want to use. So Lewis outlines this program for doing this with respect to properties. So he believes that there are loads and loads of properties, and he thinks that there's certain roles that properties should play, which are sparse roles, and he wants to sort of identify the natural ones to play those roles. So he presupposes a primitive distinction between the perfectly natural properties and other more or less natural ones. Natural properties are supposed to be intrinsic, simple, and non-gerrymandered. And there are three main roles for naturalness. So the natural properties are meant to be similar or underlie similarity. So natural entities underlie or explain objective similarities in the world. They underlie causal powers, so natural entities have real causal powers. And minimality, so natural entities serve as a minimal ontological or ideological base for which we can sort of write things down and explain other stuff. Sider takes this notion of naturalness and extends it to all categories, not just properties, and he calls it structure. Other folks have taken this notion and done some other work with it. But Lewis thinks of fundamentality as perfect naturalness. So for an entity to be fundamental or property to be fundamental is for it to be perfectly natural. So this quote, "How things are," is fully given by the fundamental, perfectly natural properties and relations, and that those things instantiate. So my aim was for some of these arguments to apply to grounding. I will probably be able to talk about this. There's so many grounding theorists that it's, I think, very difficult to sort of pin things down. But I'll say a little bit about what sorts of arguments I think might extend to grounding theory. But I'm going to use Lewis as a foil and suggest some takeaways later. So Lewis is, he treats naturalness as a gradable notion, and gradable expressions accept some degree modifiers and appear in comparatives and equatives. Basically, a gradable expression is just has a sort of scalar semantics, where you use a scale of degrees to sort of measure which properties can be ordered by relative naturalness. So it's a degree theoretic notion is the important point. And the minimality constraint entails that the scale would have to be bounded by some maximal degree of perfect naturalness. Good. So that's the basic idea. So I want to ask a couple questions about how we should understand this, because the sort of degree theoretic version of the view, together with perfect naturalness, is sometimes a bit confusing, and I want to know a little bit more about the constraints on that scale. So the first question I wanted to figure out was whether we ought to think of perfect naturalness, or this relative notion of naturalness, as more fundamental. Do we start with perfect naturalness and then explain the naturalness scale on the basis of sort of distance from perfect naturalness, or does it go the other way? Do we start with relative naturalness and get perfect naturalness by saying nothing is below it in the naturalness scale? That's what fundamentality means. Lewis opts for the absolute notion. So he says, look, we've got perfect naturalness, and we define relative naturalness in terms of it. And perfect naturalness, surprise, surprise, it's physics. Physics discovers which things and classes are the most elite of all. Others are elite also, though to a lesser degree. The less elite are so because they are connected to the most elite by chains of definability. So here's a criterion. This is a criterion from Lewis in many places. He says, phi is more natural than psi, just in case some predicate expressing phi can be defined in terms of predicates expressing perfectly natural properties more simply than can any predicate expressing psi. Okay, what does that mean? What it means is basically you've got a bunch of definitions, and you say one property is more natural than another just if the definition of the one is simpler than the definition of the other. There's a slight complication because there's lots of different predicates that can express lots of different ways of defining a single property, so there's a complication involved in that, but that's the basic idea. Simplicity of definition, right? Definitional complexity. And what is definitional complexity? Well, it's just a function of the length of definition. if you just count up the disjunctions and conjunctions that are in that's in the definition, then you can figure out how natural a property is. That's the idea. Okay, so I'm going to suggest that this characterization of naturalness is already leads to a bunch of problems. I'll give you a bunch, and then I'll suggest that naturalist theorists should do a few things. One, they should treat relative naturalness as the primary notion, not perfect naturalness. Two, they should reject any identification of perfect naturalness with fundamentality. And three, they should abandon this simplicity criterion of like length of definition. Okay, really what I'm going to do is I'm going to give you some options, and I'll just tell you what my preferred option is, but those are my preferred options, so just to sort of give away the game a little bit already. Okay, so the first problem is the problem of definitional precision. Definitional complexity is a linguistic notion. So it's going to build artifacts of our language into the naturalist scale. So that's the first thing. So some examples of how this could happen. Definitions can only ever be as complex as the syntax for our language allows. And there's no reason to expect that the structure of properties mirror the structure of our language in general. I mean, definitions are built up iteratively from the perfectly natural properties using Boolean operations like conjunction and disjunction. And so, because of that, definitional complexity can never be dense. That means that the naturalness scale can never be dense. And you might wonder why that would be the case. So, like, if you're thinking about naturalness in terms of the world, it might be that for between any two properties, you know, there's another property in between them in the naturalist scale. It seems like a possible option. It's ruled out by the simplicity criterion. Another example, in a countable language, predicates can't be infinitely complex, which means there can't be an infinite chain of naturalness dependency. And that seems like a weird artifact. You can move to an infinitary language, but then it's still going to be like, limited by the size of the size of the language, like the chains of definition are still going to be limited in that way. So you're just building in artifacts of your language into the naturalist scale. Yeah. Even if you think that there are uncountably many abundant properties, as Lewis does, the naturalist scale won't be able to discriminate between the vast majority of them just because you can't ever get infinite chains of definability. Okay, so we'll move up. That's the first thing. That's the problem of definitional precision. Now I want to talk a little bit about another set of problems, more to do with naturalist scales and how to measure naturalness according to some scale. So I'll rely a little bit on what's called the representational theory of measurement. You know, there's a kind of permissivist view on measurement theory, especially in semantics, where the idea is something like you can measure a concept. Some concepts basically have application conditions that are in accordance with the scale, even if there isn't sort of some real world corresponding measurement, like you can't operationalize it. So I'm sort of going to look at the naturalist concept and think about what scales what might be appropriate to it. So if we're measuring a property P and we start with a domain and a binary relation, which is the set of all pairs from that domain, we say x is greater than or equal to y with respect to P, so with respect to naturalness. You basically presume that you have a reflexive intransitive relation, but not antisymmetric, and the scalar semantics can be given by the existence of a homomorphism, so a structure-preserving map from the qualitative structures, the relational structure, into some specific numerical structure. So you got some scale of degrees, and you got this relational structure of relative naturalness, and you say if this scale of degrees, if there's a map from the one to the other that preserves the structure, then you've got an appropriate scale, an admissible measurement scale. An admissible measure function is what we can call it. So there's different types of scales. This is a very old idea. It's been complicated quite a bit in the representational theory of measurement, but the three main types of scales are the ordinal scale, the interval scale, and the ratio scale. Ordinal scales are basic order comparisons. So any homomorphism at all that preserves the order is going to be an admissible measure function. Interval scales are are slightly more complicated. So if you have an interval scale, then then basically you can shift that scale by some fixed value beta and multiply the measure by some other value alpha to get an admissible scale. So temperature is an example of an interval scale. If you look at Fahrenheit versus Celsius, there's a transformation of Fahrenheit to Celsius where you multiply by some fixed value and then add 32. It's like 5/9 or something, 9/5, depending on which way you go. So interval scales, so temperature is like that. Then there's a ratio scale. Ratio scales preserve ratios, and so it's basically like an interval scale, but you don't have this shifting 0 point, basically. All right, that should be familiar to some of you. It's a sort of old idea about measuring, and I just want to sort of have a little think about what naturalness might be on these scales. What would be an appropriate naturalness measure? So let X and this ordering relation be an ordering of properties by relative unnaturalness. So I'll use unnaturalness instead of naturalness because I want 0 to be perfect naturalness. Okay, so flip your brain and 0 is perfect naturalness. As we go up, we get, in the scale, we get less and less natural.
So if it's an ordering, is it anti-symmetric also?
No. Yeah, sorry, quasi-order. Yeah. So if we measure by ordinal scales, then we just get this result that any homomorphism into any set of degrees is going to be an appropriate measure function. So there's lots of ways of measuring naturalness on the ordinal scale. Lewis himself thought that relative naturalness might be somewhat indeterminate, but not that indeterminate. He wanted relative naturalness to do more than just ordinal comparisons. He wanted to say more than just whether phi is more natural than psi, but also how much more natural. So comparisons like the difference in naturalness between phi and psi is much greater than the difference in naturalness between chi and epsilon. Those comparisons, or that's eta. Those comparisons are meant to be meaningful, and they're not on an ordinal scale. And so this motivates looking into interval or ratio scales. So some gradables permit ratio comparisons, like Ian is half as tall as Abel, London is 10 times as far as Edinburgh, whereas others don't. So the air quality in Juneau is 10 times better than in New York. That only makes sense on some specific way of measuring air quality, right? It's twice as hot inside than it is outside. It doesn't make sense unless you presuppose a specific scale, because twice as hot doesn't transfer across scales. It's not an objective thing that you can measure. Think about like Michelin stars for restaurants. If a restaurant gets 1 star and another restaurant gets 2 stars, that doesn't mean that the second restaurant is twice as good as the first one. It's just not how that scale works. Okay, yeah, that's the example. But here's the issue. So because of definitional complexity, the simplicity criterion, phi's definition is half as complex as psi's. That's perfectly sensible. And so any scale that sort of meets the simplicity criterion is going to preserve ratios. And that means on the simplicity criterion, we have a ratio scale, just automatically. But here's the ratio problem. Ratio scales include way too much structure, making predictions that conflict with the other naturalness rules. Why? Well, in order to see why, we need to complicate our structure just a slight bit by adding a concatenation operator. So many semantic domains have a Boolean structure. We can complicate these scalar structures to represent this using join or disjunction. Just focusing on properties, we'll think about it as disjunction between properties. So when you concatenate, whenever you have 2 properties that are non-overlapping, in Lewis's framework, 2 properties don't overlap when they don't have any fundamental properties in their. They don't share any fundamental properties in their definition. So if you look at their definition, the same fundamental properties don't appear in both. So they're basically non-overlapping entities of the same semantic type, then the concatenation operator is the join operation on the domain. What does that mean? It just means disjunction. So that you have this fact that ratio scales satisfy additivity. So this is part of what it is to be a ratio scale. You've got this additivity principle. What does it say? It says that the measure of A join B is just the measure of A plus the measure of B. Translating to the theory of properties, you get that the unnaturalness score of phi or psi must always be equal to the unnaturalness score of phi plus the unnaturalness score of psi. This is a prediction of the ratio scale. It tells you that this has to hold true. But that seems wrong. Here's a bunch of examples. Suppose that shades of color are equally natural, so some specific shades of color. So if we have X is scarlet or X is turquoise, that disjunction ought to be less natural than the disjunction X is scarlet or X is crimson. Why? Well, the second disjunction, X is scarlet or X is crimson, underlies a bunch of some qualitative similarities, right? It's crimson and scarlet are pretty similar to one another. Whereas the other one, scarlet and turquoise, underlies some pretty drastic differences. The things that satisfy that predicate are quite disjointed. They're separated in color space. So it should be that the second one, scarlet or crimson, is more natural than scarlet or turquoise, but by the ratio scale, by additivity, these have to be the same if each individual shade of color has the same naturalness score. Okay, so that's just one example. Here's another example. If you're familiar with Goodman's new riddle of induction, Gru, Bleen are like highly gerrymandered predicates that are precisely designed to be the case that when you disjoin them, it's logically equivalent to the disjunction of blue and green. And so, because these are necessarily equivalent, those disjunctions are basically the same property, but the disjunction of Gru and Bleen had better be less natural than the disjunction of blue and green. And so that violates additivity. Anything that has that will be additive. Another example, if you think of determinants, a determinable property as a disjunction of its determinants, you might think it's perfectly possible for a determinable property to be more natural than the sum of all its determinants. That might be a thing you would want to hold. In fact, some people have held it. Justice Wilson holds this view. And that's not possible because it conflicts with additivity. So I think ratio scales have got to go. So we should be looking at interval scales for naturalness, according to Lewis. And that's fine because we wanted it to interpret claims like the difference in naturalness between psi and phi and psi is much greater than the difference in naturalness between chi and whatever that Greek letter is.
Psi, with an X.
The need for interval scales, we need an interval scale for that, where comparisons between the size of the intervals are stable, and that gives us another problem. So this is what I'll call the zero problem, and it's the final. It'll be the sort of the final nail in the coffin, I think. For me, anyway, I'm thinking about Lewis's theory. If you take any interval scale and you have an absolute zero, it's actually not an interval scale, it's a ratio scale. And because that's because ratio comparisons, so interval scales preserve intervals between properties, like across different ways of measuring. But if you have an absolute zero, and you combine that with the interval from 0 to phi and the interval from 0 to psi, those intervals will be preserved. And so for any pair of properties you can define, you know what the ratios will be between them. And that means that if perfect naturalness is fixed across measurement scales, then we have an absolute zero for unnaturalness values, which means there's no possibility for it to be an interval scale. All right. So those are the problems. It makes me think I don't really understand what Lewis is on about with respect to relative naturalness. And so here are the takeaways. Simplicity can't serve as an analysis of relative naturalness, I think, because of the problems of definitional precision. I think we should think of relative naturalness as the primary notion and fundamentality either defined from it or defined in other terms. Relative naturalness isn't a ratio scale because of the problems with additivity, and relative naturalness can make integral comparisons only if there's no such thing as perfect naturalness. I also have some big questions about the minimality constraint. So is this tie between naturalness and fundamentality and the minimal ontological base? One quick worry. Aren't you trying to pull a metaphysical rabbit out of a semantical hat? Yes. And you ought to be suspicious of arguments like this. I think the argument hits the target, at least for those who endorse a semantic approach to naturalness and fundamentality. Like Lewis and Sider are paradigm cases of this. They're defining naturalness in terms of language. I think this actually applies to some of the grounding literature as well. There's quite a lot of grounding literature that's driven by semantic intuitions about grounding the truth of a disjunction in its disjuncts, or grounding the truth of an existential in its instances. And so I think some arguments like this can hit the target there as well. There are some recent attempts to clearly separate metaphysical grounding from logical and semantic grounding, and so arguments like this wouldn't apply in those cases. And there might be versions of more metaphysical, less semantic versions of naturalness which might not, where these arguments can be avoided. Okay, so what are some options for people who are sympathetic to naturalness, but accept these arguments? The first option I will call no fun, and that's because there's no such thing as perfect naturalness or the fundamental level on this way of thinking about things. Middle-sized objects are in the same boat as everything else. Everything's just more or less relatively natural, and there's no fundamental level. Second option is what I'll call relatively perfect. So the idea here is that perfect naturalness or fundamentality is scale dependent. Depends on how you're measuring. For some applications, you might treat middle-sized objects as fundamental. Maybe you're doing, some kind of special science. Maybe for other applications, when you're measuring naturalness, fundamental particles will be natural. But the kind of question is there some scale of measurement on which persons or ordinary objects are fundamental? That's one possible way of thinking about this picture. You could just say, well, so much the worse for measuring naturalness on anything stronger than an ordinal scale. So you could say there might be a difference between quarks and quail in terms of the naturalness and between the common cold and the communities, but there's no distance between these that can be compared across naturalness measurements. Ratio descendi, I thought I'd throw in a legal term for Jonathan, but really the idea is just to decide on ratios and just defend against them, defend against the objections to ratio comparisons and additivity. So one way of doing that, you'd have to reject the simplicity requirement from Lewis, and you need to motivate an alternate interpretation of concatenation that's not disjunction. That might be an option. And then the final option is the divide and conquer strategy, and this is the one I like. You distinguish naturalness from fundamentality, and you motivate different scalar approaches for each. And you can say on this way of thinking about things that the middle size might be natural, even if not fundamental. So thinking about divorcing these notions. I'll end in about a couple minutes. I just want to say a little bit more about my preferred approach. So I think that one single relation subsumes all of the three requirements of similarity, causality, and minimality. This is a big question. So Jonathan Schaffer has a paper where he basically makes this point and says, we can drop the minimality constraint. We can say, natural properties underlie objective similarities, they ground causal powers, but they needn't form a sort of minimal ontological base, and we needn't identify these fundamental properties with them, properties of physics. And he opts in favor of what he calls a scientific conception of naturalness, where natural properties or entities can be drawn from all levels of complexity and any sort of scientific If the property is needed for any type of science, then that property will be natural. There's a question about whether the scientific naturalness, conception of naturalness, is compatible with a degree theoretic approach, or if it's just an all or nothing thing. See, does science need it or not? If science does, then it's natural. If it doesn't, not natural, and that's it. It's just sort of a threshold type of thing. No degree theoretic. But I think there could be versions of the view where degrees are possible. But on this way of thinking about things, grounding and dependence questions may or may not have determinate answers, depending on the subject matter. Fundamentality wouldn't be the sole route to metaphysically elite status. So that's one option. Another option, and I think it's kind of closely related to the scientific option, you might think that similarity and causality can be explained. The approach I like is that there can be multiple more or less natural ways of subdividing some space or structure. So if you think of qualitative space as some structure, and we can kind of carve up qualitative space in various ways, there might be good ways of carving it up and bad ways of carving it up, more or less natural ones. And the natural divisions would, in my view, correspond to more united portions of that space. That would be a sort of way of kind of measuring naturalness, is how united are the portions that you end up with according to some way of carving up that space. This approach has been taken to some types of properties. There's this book, Conceptual Spaces, by Gardenfors, where he sort of he says that natural regions of conceptual space are convex. Other folks have proposed topological ones. And I think this approach is pretty flexible in general. You could do it with powers. So if you have a network of powers, you can kind of carve up that network in multiple different ways and sort of have a measurement of how natural that way of carving up the network of powers is based on how interconnected subregions are. So this is the kind of work that I'm interested in doing. But in order to do that work, we need sort of a general questions about how we should think about unity. What makes for unity of some way of carving up some space, qualitative space or otherwise. And I think those are deep, important questions that I'd like to tackle. Yeah, thanks.
All right, so I'll make a few remarks to try to tee up our conversation, maybe help set some things in a kind of context for people that are a little bit unfamiliar with some of these two different programs that Vera and Aaron have been describing. So start off with Vera's talk. Start off with the word causation, which we freely used yesterday when we were talking about fundamental causal powers. The term causation is a term of ordinary language, right? And it's, of course, widely deployed in various sciences. And plausibly, it's intended to pick out a kind of counterfactual dependency between event types that are sensitive to how we describe those types, right? So the red scarlet versus scarlet example with Sophie the pigeon, you can sensitize Sophie to redness, but not particular shades of redness. My point is, this way, this ordinary and science building on common sense descriptions, this way of talking is not obviously beholden to any particular metaphysical understanding of causal power, for example. That's a kind of term of art within metaphysics, at least the way it gets used in metaphysics. It's also a term that shows up in ordinary language. Where causal power in metaphysics is sometimes thought of as a metaphysically basic worldly relation. It's out there. Things, just like things stand in spatio-temporal relations to each other, things stand in this fundamental make-happen relation, right, over time between events in the world. Powerful things that have power, powerful particulars, maybe things like electrons and their effects. And some of what we readily say about causation in ordinary life and in science is at odds with this kind of metaphysical picture. For example, as is often discussed, and Vera referenced this kind of example, we quite readily are willing to say, my not watering my plant caused it to die. But now, think about if you believe in causal power as a kind of metaphysical make-happening relation, an absence doesn't have power. The not, my not doing something, that's not a worldly, powerful structure in the world. Not watering is not a worldly entity, right? And so that should tip us off right off the, wait a minute, so what the metaphysicians are after is not exactly, it doesn't perfectly coincide with our ordinary ways of talking about causation. Now, so if you do accept a kind of causal power metaphysical framework, like showed up often yesterday, this kind of Aristotelian account, then you should say, we theorize there's a kind of relation, and it might be helpful to even sort of terminologically separate that from the ordinary term causation, which came first, right? Ted Sider talks about this, I think he's right, a philosopher, call it metaphysical causation, M causation, right? That's a theorized relation out there in the world, and O causation is just our ordinary way of talking that gets systematized in the various sciences. M causation may be subject to certain constraints that O causation is not. For example, you might think there's no systematic overdetermination happening when sorry, too much coffee this morning. There's no systematic overdetermination happening in terms of M causation, right? Because M causation is a primitive making happen relation. You don't want multiple entities, being independent but sufficient for making happen the very same thing. That just seems like a weird metaphysical picture, and it gives rise to problems. And so this theorized M causation relation has a kind of loose relation to myriad levels of O causal dependencies in the world that you get tracked in special sciences as well as more basic natural sciences. So the idea is M causal relation. Why believe in M causation, right? It's optional, right? All of metaphysics is always optional. It's always disputed, right? But you might believe in it because you'd say M causation is needed to account for why do all these different O causal relationships that we talk about at different levels of granularity, why do they obtain? Why are there counterfactual dependencies between things like watering plants or not and plants dying or thriving, right? The idea is, well, it's not just brute, there just happen to be patterns over time that obtain very regularly, very reliably, consistently, and there's nothing that explains it. It's just a brute fact that there are consistent patterns of events over time, right? M causation is supposed to ground those patterns and account for why, right? There's something out there, the world ultimately is built of entities that persist over time and have M causal power, and it's ultimately because they're doing their things, right? Account in some way for all these kind of dependencies that we can track at different levels of granularity and sensitivity in the world. So plausibly then, M causation is a kind of sparse relationship, right? Where that is, there's a privileged set of M causal entities, and whereas O causal relationships, the way we talk about causation is very abundant. There's lots of them. What's the point? Even if, so here's the point I'm driving towards. Even if, as I do, even if you accept M causation and think of it that it only obtains, as I don't, at the microscale, but even if you do, even if you're a real reductionist about M causation, you say it's the job of final physics, fundamental physics, to identify the M causal entities, the things that ultimately are what's driving the world forward and make true the various higher level dependencies that we can talk about. Even if you believe that, you have no reason to reject causal modeling of the kind that Vera was describing that freely allows for causation at all scales, right? Because even if you're a reductionist, you should say there are very stable counterfactual dependencies that we care about, things like smoking and cancer and so on, right? These are very important to us, even if all M causation is really going on at the lower level. So that was just a kind of remark, because sometimes people might think, oh, I don't believe in that, I don't believe in higher level causation. No, you might not believe in higher level M causation, but there clearly are counterfactual high level dependencies the way we're talking about. You're just not picking out a fundamental metaphysical relationship at the high level of description. That was a thought, kind of an ecumenical comment on that. Just to help the scientists, this is metaphysicians. We talk about all this stuff in lots of different ways. So similarly, Aaron now tipped you off to another big recent program in metaphysics that was pioneered by the late, great David Lewis, philosopher who died, I think, the year 2000. And this is a kind of program that's in search of the one true unified account of the world and its constituent entities, properties, and relations. Who's engaged in this program? I think sometimes the people who engage in this program are not sufficiently self-reflective about the set of commitments they tend to share, and they don't explicitly call attention to this. So this program may look less attractive to people who maybe don't share some of those metaphysical commitments. So typically these are abundant theorists. They believe in, look, there's lots and lots of ways you can describe the world, right? Lots of true ways. You can say a lot of true things about the world, some of which are not very helpful or deeply explanatory, right? Just point out various miscellaneous things or even group things in very unnatural ways. As long as you define your terms, right? Like he referenced the term groove, you can artificially define terms like that that are just not natural ways of describing the world. No science would think to invoke predicates like that. They're not helpful, but they could be true, right? Once you define your terms. So they'll say there's all these different true ways of potentially of talking about the world, but nevertheless, these are people who are, you might say, scientific realists. They think there are a privileged class of entities for explanatory and classificatory purposes. And these folks, furthermore, tend to be reductionists, and so look to it, like Lewis explicitly did, look to a final fundamental physics to identify the privileged entities. Okay, so that's one thing they tend to have in common, right? That they say you can talk about the world in all kinds of ways, right? But there's a privileged way of talking about the world, right? That somehow carves the beast of nature at its joints, as Plato said, right? That gets to a privileged kind of structured way of talking, and they also tend to be. So that's one commitment they tend to have. They also tend to be neo-Humeans. I'm going to invoke a term here, following David Hume, as opposed to neo-Aristotelians, who we saw yesterday being invoked. That is, they don't believe in M causation. They tend not to believe in it, right? There is no kind of oomphy, make happen, worldly relation out there in the world. There's just patterns, right? It just happens that the world admits of remarkable, deep patterns over time, right? So that science is possible. You can describe those pattern processes, but there's nothing that accounts for the fact. It's just a brute set of facts. The world is an astonishingly brute place on a neo-Humean picture. It has remarkable, deep, powerful patterns that run through it, right? Perhaps exceptionless patterns, right? But nothing accounts for the fact that there are those patterns. There's no M relation driving the world to continue to conform to those patterns. It just falls out that way. Might not have. There are ever so many possible ways the world might have been that don't involve that kind of regularity, or they involve different kinds of regularity, etc. It just happens. There's no deep metaphysical explanation. So that tends to be a commitment. And many of them are nominalists, in a way I'm about to describe, or at least nominalist friendly. That is, they'll say, look, we have terms of language, predicates, but our predicates like red or rectangular, right, or charge or mass or spin, right, these kind of either terms, predicates of science or just predicates of ordinary description, but they don't pick out entities. There's no, like, this rectangularity of this tabletop. It's not an entity, right? You got the table, that's an object, right? And then some people will say, not only is there the table, but there are entities that are constituents of the table, not ordinary parts, other objects like the particles that make up the table, but entities like properties, property constituents of the table, its shape, its color, its size, and so on, right? That would be to think that there's either immanent to the thing, right, or as so that's one way of thinking about properties as real entities that are picked out by predicates. Another way, they're universals, right? Like Plato, right? There's rectangularity, which is true of this table, but it's also true of other rectangular objects. It doesn't literally reside in the table. It's a kind of abstract universal, right? That stands in a primitive instantiation relation to particular objects, but it's not there in the table. All right. Those are two anti-nominalist positions, right? But the nominalist is someone who says it's just words, and they're true. It's true that this table is rectangular, but there's no entity that makes that statement true. It just is true. It's a truth without a truth maker. There's no property entity there. Okay, so why? So I said that people who engage in this project, the naturalness and grounding and fundamentality folks, right? And they give kind of complicated abstract theories about the nature of naturalness and degrees of naturalness and all this. And Aaron, I think quite rightly, is raising a lot, conceptual problems for exactly how people are thinking about this. But I said they tend to be neo-Humeans. They don't believe in M causation, and they at least want the project to be consistent with nominalism about properties, right? Even whether or not they are nominalists. Why is that significant to understanding what's going on? Well, if you don't believe in M causation and you're a nominalist, then the world isn't going to supply for you the privileged entities, right? You believe in privileged entities. Remember, we've got lots of ways of talking about the world, right? But you think science is getting at a privileged way, and especially the more fundamental sciences are getting closer and closer to a privileged way of talking about the world that somehow is special, right? There's no M. You can't just say, well, whatever corresponds to the M relations, that's the privileged way. You don't believe in M relations, and you say, well, whatever corresponds to the most basic kinds of property entities in the world. You don't believe in property entities in the world, right? Okay, so now it's just you gotta account for naturalness and privilege in terms of types of the relationships of different kinds of descriptions to each other. And so then that gives rise to this program. You're going to say, well, there's just this primitive feature of certain descriptions, naturalness, right? And it's treated as a theoretical primitive. It's a bit of it's a primitive concept, right? But it doesn't correspond to something in the world. It doesn't pick out some entity in the world. And so and Aaron. So the only other thing I'll say about this is that was just context setting. Just kind of understand
discussion within a minute, or else we'll.
Okay, very good. Aaron made the basic suggestion. Why don't we divorce naturalness from fundamentality? I agree. If you go in for this kind of project and you say, all right, setting aside fundamental physics, which maybe is the most privileged way of talking about it, you got chemistry and you got something like systems biology. They're both very natural ways of describing it. They're very robust patterns of counterfactual dependency. These are two different sciences, but of course chemistry is more fundamental than systems biology, but to think that automatically makes chemistry more natural, it's just not obvious. It seems like that's a commitment that, especially if it causes problems, trying to theorize that, why not just junk it? I agree with Aaron on that. I'll just make this, I'll throw this out for the theologians among us. Another typical commitments of laborers in this particular metaphysical vineyard that I don't think is paid attention to enough is they tend to be atheists. And the reason I call attention to that is God's relationship to the world, if God stands in a creation relation to the world, it doesn't neatly fit in the grounding fundamentality framework as it has been theorized. I'll just throw that out and maybe you'll want to pick up on that in discussion. But I'm done.
And I'm going to go get things ready for the next session, so I'm going to have John as the timekeeper and the one guest. I think we'll be going to coffee with a 10-minute delay, which means we'll only have 20 minutes for coffee, but we'll be back on schedule.
All right, so what time does this?
It's 10 past. We need to go next session.
Very good. All right, so one, and I'm going to try to get in some people who perhaps have not been in the discussion. Everyone, I think, is. We'll go 1, 2. Try to remember your order. 3, 4, since I don't recall you being part of the conversation previously. Then 5, then 6, then 7. We might get you in a little bit earlier, but go ahead. All right, please start us off.
Thank you, both of you. And if it's okay, Aaron, I'll direct a question to you about Evan has a paper on naturalness and parthood. And there's a sort of mystery in which parthood doesn't fit in this characterization either. I wondered if you have any comments on that.
Yeah, so I read that paper. If I recall, that paper is basically about whether the parthood relation itself is natural. It's Maya Eden, philosopher out of I think UMass. I think she's basically asking questions about whether the parthood relation itself is natural. So I didn't talk about it because I was focusing on monadic properties and sort of Lewisian picture.
So you could phrase it even in terms of the having of proper parts.
Yeah.
Still wouldn't fit into this picture at all.
Yeah, no, it wouldn't. I mean, maybe. Actually, I'm just trying to see how it could fit in the Lewisian picture.
It's a curious feature, I think.
What would the definition be, in terms of length of definition, in terms of fundamental properties?
My own hunch
Maybe it
is
fundamental.
related to Timothy's mention at the end, is that how to define theoretical terms in the 1970 paper defines all this naturalness predicate stuff in terms of a mereologically structured
Right.
part relation, and that's what gives you the framework for fundamentality.
Yeah.
So the attempt to try and talk about parthood in terms of fundamentality is a dialectic mistake from the get-go. And I think there's a sort of interesting beyond Ramsey humility point that he comes back to in the post-human of the, he kind of gives up that second order existential generalization stuff. I just wonder, we can talk more about it, but I've often had this kind of question, where does parthood fit?
Yeah, identity is similar, and
Yeah.
it seems like these are special relations that are theoretically well understood. We just use them for the basis of metaphysical theorizing, but don't themselves fall into this sort of picture of like what of how we identify the fundamental natural properties in the world, because they're not. I mean, the ramification point is sort of like about roles, whereas like parthood itself isn't playing any sort of. It's playing a theoretical role in the meta theory, maybe. But
You can't ramify it out.
Right. Yeah.
That's
For those who are not in the know, these are referencing early David Lewis. Texas is like the Gospel of Mark. It's like the whole program. So,
To be continued.
Who is
Thank you.
number 2? Hi. Okay.
Got a couple of questions for Aaron. Thank you. That was a fantastic talk. I wanted to clarify the difference between the mere ordinality and the no fun options, because I didn't quite understand that. That's question one. The other question is, I wonder if you can expand a bit on how your attack on Lewisian understanding of degrees of naturalness translates to grounding theorists. Yeah, but this is
Great. Thanks. So the no fun option was meant to be compatible with an integral scale. So remember the argument was something like if you have an integral scale, then if you have a fundamental level that's scale preserved across all scales, you get a problem. It's not an integral scale, it's ratio. So the no fun option was meant to be like we can do these integral comparisons, but we just don't have a fundamental level, or at least not. So that was the idea behind that one. The mere ordinalities point was just we preserve a fundamental level. We can preserve a fundamental level. It's just the bottom of this mere ordinal scale where distances between intervals aren't preserved. And then the grounding stuff. Yeah, this is something I'm working on. So I think there's some. I thought it was going to be a sort of very straightforward thing, and then I realized that it's way more complicated. And there's no real theory of grounding that's sort of like the go-to, and there's some minimal constraints that you can sort of like lots of people put into a theory of grounding, but yeah, it's much more difficult than I thought. Something that was a little more straightforward is a sort of application of naturalist theories to mereology. This is something that hasn't been done previously, but like if you take a kind of classical mereology where you have an abundant theory of composition and you wanted to select up natural holes, you could apply a kind of scale of, and that actually is pretty straightforward. The joint operation there, the concatenation is just mereological composition, and so that's something I've been working on a little bit with one of my PhD students. But the grounding thing, I got put off because that literature was just too complicated for me to try to get my head around at this point anyway.
Thank you.
What's next?
Right. Thank you for the talk. It's very clearly structured, so I appreciate that. And I have a question for Vera. I don't think I quite understood your points on proportionality. So you gave two examples, I think. The first one is Sophia the Pigeon, in which the higher level quality X is redness in general, and then the X dash is specific wavelength of redness. And then the other example, the TV one, is the switch and the physical state. But it seems to me that there seems to be a sort of discrepancy between these two examples, because in the first one, the specific kind of redness is a subset of the general redness, whereas in the second, I think you have to presume that the physical state is a subset of the higher level state, or whatever you call it. So do you think there is such a presupposition behind it, or am I misunderstanding?
Okay, good. Thank you very much for that question. So it's very good. So the point is that metaphysically speaking, those two examples don't seem to be alike, because you might say that in the case of redness, you just changed the level of description, whereas in the TV set example, you're talking about metaphysical levels and things like that. And I totally agree with that. The point is just that Yablo actually uses the pigeon example in order to draw an analogy to the metaphysical case. And so I would like to understand it along those lines, but I totally agree that metaphysically speaking, the two are different things. From a formal perspective, so from the perspective of causal models, or from the perspective of superhedonist relations, they are the same. So in both cases, so in the case of the bulky switch example, the position of the switch supervenes on the microphysical properties, and also most people think of the determinable-determinant relation in such a way that the determinants, the determinables supervene on the determinants. So that's the analogy. But thank you.
Oh, okay. Thank you.
All right.
Also a question for Vera. Thank you for the talk. I was wondering if you would in the perspective of, engendering causal models, would you rule out arrows that correspond to kind of logical supervenience relations? Because the reason why I ask this is, it seems to me that one possible way to solve the tension could be you add both the higher level and the lower level one, you do the proportional thing, and then you add an arrow between the two, which just corresponds to the supervenience relation.
Yeah. So thank you very much. So this is a very good question, and actually there's a huge debate underlying my answer to that question. So initially, people working on causal models, so the people who started working on that about 20 years ago, thought that that shouldn't be possible. So that the variables occurring in a causal model should satisfy a distinctness criterion, and distinctness mean ruling out logical supervenience relation, or functional or direct functional relations, and things like that. But then some philosophers came along and started to throw that formalism onto, for instance, the classical causal exclusion problem, and also on mechanistic explanations in the neuroscience or the life sciences, and realized that that restriction, the variables would have to be distinct in that sense, should be loosened in certain cases. And I think that is a viable option. You have to adapt the formalism in order to do that, and currently people are working on how to do that. One of the problems with respect to this particular example is that even if you do that, it might solve the problem from a formal perspective, but you won't gain much information by doing this. So what you eventually get is you could just add a multiplicity of courses representing the same thing at various levels of description, but that won't make your model better. So that's, so that might be a problem with that solution.
I want to interpolate our scientists here, make sure we...
Okay,
Yeah.
thanks for both speakers. The particular question I'll ask is Aaron's, although my comment to Vera is that I feel it was sort of covered by the question. I had that feeling about, if X star is a subset of X, then am I being given a false dichotomy? But I think you and your colleagues understand all that, and it's fine. So I won't invite you to say more about it, because I think it was covered. But that is what I wondered during the talk. But if I come to Aaron, can I just ask, is it possible for you to tell me, according to David Lewis or anyone else, following his work, which is more natural? And I'll give you an example. So classical electromagnetism or quantum electrodynamics. You don't need to be an expert in either, but you do need to have some idea of what they are.
Yeah, you got me. I mean, I really wouldn't have any clue whether they would have opinions on that. I mean, I think the answer is just it is a mystery, because the answer is find the sort of expression that expresses. I mean, you basically just need. I mean, those are whole chunks of science where you're looking at whether the properties that feature in them are more natural or not. So you need to sort of isolate some of the sort of core properties that appear in each of those sciences, and then ask comparative questions about those properties. And then the way that you would tell for Lewis anyway is just identify all the fundamental ones and then look at chains of definability. So it relies on this idea that of reduction. You need some kind of definition of the properties that appear in one in terms of the fundamental level. And so it's super programmatic, and in this paper that was referenced, Ramsey and Humility, there's a strong suggestion that we have no idea what the properties are at the fundamental level, and so actual relative naturalness comparisons are epistemically opaque to us because we just haven't achieved the reductions necessary to make those judgments.
So.
Yeah, thanks. Okay.
So I don't think that they would
I
give.
feel like I haven't got an
answers.
answer, but no, you know.
I don't think they would be able to give you
Yeah.
one.
Yeah, just a quick meta comment on that. You know, so the characteristic difference between metaphysicians and scientists. Metaphysicians are kind of assuming a posture like where we have a complete story about all of reality, and then we're interested in how things stand. But as a scientist, it's like, well, here we are. We've got our theories. Nobody thinks we're done yet, and so the metaphysician is kind of presuming a standpoint of.
Okay, I'll just add one more observation on this whole thing. So, behind my question is, we should be aware that we generally think it's correct to say classical electromagnetism, you know, can be in some sense derived from or, you know, obtained in as a particular class of quantum electrodynamics. You know, we sort of see it that way around. But nevertheless, the mathematical tools, the very language you're speaking when you try to do the quantum thing, are much more subtle. They're very hard to put into words. So in that sense, they're less natural. So I wonder whether Lewis's approach somehow does grapple with the world in the right way. It's not obvious to me that it does. Anyway, there we are. That's enough on.
Yeah, do that reduction.
George has a finger here.
Something I want to say which relates to this. You use the phrase reduction to fundamental physics. So the question is, what is fundamental physics? And the answer is physicists do not know what fundamental physics is. So, in fact, we don't have its string theory, M theory, we don't even have a grand unified theory. So, in fact, physicists reduce it to, let's say, quantum electrodynamics, which physicists know is not the fundamental level. So, as a matter of practice, are accepting emergence.
Okay, we got finger, quick finger. Yeah.
Very quick thing. If I remember rightly, Lewis did not like quantum theory, but it doesn't fit into his system very well, so it can't really be right. So
Yeah, that's another right.
Also, I mean, Lewisians still say that the one is relatively more fundamental than the other. We don't add much to this, right? So when you want to say the properties of quantum electrodynamics were more natural in that sense.
But I thought the suggestion was that the sort of like the language in which each theory is couched are different enough so that these comparisons can be made, at least if you accept the simplicity criterion of. I'm not sure.
That's about what I was saying.
All right, were you next, or was that just a finger?
A new thing.
Oh, new thing. Okay, so I think.
Okay, right. Okay, so I thought two great talks. So thanks very much. I had a question for Vera actually. So I think it's really important, this question of proportionality and granularity. It's often not sort of discussed in quite this way. So I thought that was very helpful. So the question I had was this: bring up the question of pluralism. I mean, I like your solution that you can kind of do these things to choose the highest or the lowest. But I wonder whether there's also a kind of a message here that so some causal models are quite good at dealing with bivalent variables. Other causal models are quite good at dealing with quantitative variables. Often we get into problems when we mix them. So there's a kind of seems to me that there's also a kind of this might nudge us towards a kind of like pluralist view, and that we should be keen to sort of always be sensitive to choosing the types of models which are appropriate to the sort of particular causal circumstances. I wonder how you felt about that.
Yeah. Okay. So thank you very much. So this is very interesting. So one of the features of those causal models is that basically the variables you're putting into them could just represent anything. So they could represent real-world properties, but they could also, so you could think of a model as a completely formal structure that's just representing mathematical relations, for instance. And so one of the crucial messages you can take out of this with respect to the question of higher level causation is that everything depends on your initial set of variables. And so one of the things that I actually needed in order to get my argument going was to assume that the effect variables are higher level variables. And then, only then, does this problem come about. And so some people might think that everything's just model relative, so you pick your initial set of variables and then you can apply the formalism and see what happens. I think that there are at least certain limitations to that, because there's been a debate about what the, well, so if there are several levels of description for the same thing, how you should choose the preferred explanation. And so one of the additional constraints that people usually apply here is a constraint of stability and specificity. So, for instance, you should try to pick causal relations that are stable in the sense of holding across a variety of circumstances, and they should also be specific. Specificity is closely related to proportionality considerations in the sense that the manipulations of the cause variable should be directly and specifically associated with changes in the effect variable. And if your model can do that, it will be better on that scale than a model who cannot do that. But I totally agree that there's, well, a certain pluralistic conception underlying this whole approach.
All right, we're 2 minutes past time, and I think I was being given a light signal to wrap it up. So sorry for those who weren't able to get your question, but let's conclude this.
Right, we have 20 minutes for coffee now, and I think Ruth is going to take us over and that is into the common room. So we'll be back in here at 5:30.
No, if you like.
and his letters. There's letters in here also, and pamphlets, some between him and Newman, and him and Keble, and others, and the really important ones, all the juicy bits are down in the archive. But when he died, he'd been professor in the University of Hebrew at Christ Church for 50 years, which is like remarkable in any day and age, but the 19th century, when many people didn't live 50 years, that's quite remarkable. And when he died, his friends bought his books here, and some of which are upstairs. At the back of the library, he sold the large volumes when we had the drinks the other day. Those were also from his collection, and they formed the first bits of the library that's expanded to quite a large collection. And just as an illustration of certain kinds of things that only middle-sized hypotheses do, I wanted to present to you with Dr. Pusey's death mask in silver. If you like death masks, or first or second order relics, Napoleon's death mask is in the Hoffmann-Kolss here, and it's one of 5, and it's very not well guarded. This evening, I'm going to go venturing through Oxford. Who would like to join me, and you can have a share of the booty when we sell it to an oligarch of some kind. Now, that having been said, I'll turn this over to Robert Koons, who will chair the next session.
I'm just going to be very brief in my introduction, just for the sake of time. And so we've got another pair of really interesting papers on ontology and myriology, I guess, more generally. So one by John Pemberton, who's at Durham University, who's going to talk about middle-sized things, and then Chris Oldfield on myriology and some of the history of myriology. Where are you based now, Chris?
Trinity College Cambridge.
Trinity College Cambridge.
Excellent, Rob. Thanks very much. Organisers, thanks very much. It's been a great conference. Okay, so in the ontology which I'm working on at the moment, I take middle-sized things as my ontological starting point, right? And I take it that this contrasts with the sorts of approaches we talked about yesterday, where we take a quantum domain as our starting point, and then we try and crystallise out of that middle-sized object. So in the approach there, I'm going to develop an account of the classical domain, and then as step 2, I'm going to work out how to connect that to the quantum domain. Right? So it's not ignoring the quantum domain, it's just taking a different approach. Why would I want to do that? Well, all accounts, starting with the quantum domain, as we were hearing yesterday, are controversial and challenging. It's not an easy thing to do. As we also heard, all evidence sits within the classical domain, so it just doesn't seem to make any sense not to include that at some point in your ontology. And so at least I think this approach is going to complement the sort of approaches which Alyssa, for instance, was talking about yesterday. So I set out the full account, or at least the full account so far, in my monograph, Acting Arrangement Ontology Introduced. But today, I don't have time to go through that, so I'm just going to sketch the main points, in regard in particular to middle-sized things. Right? So here's my main claim about middle-sized things. All middle-sized things we find in the world are the acting together, the surviving acting together of their parts. Right? So that's going to be my main contention. I'm going to do 3 things then. Firstly, I'm going to sort of show some empirical examples which are going to motivate why we would think that. Secondly, I'm going to outline the type of ontology which is required to either write that account of sort of acting together. And thirdly, I'm going to briefly mention some implications. Right? Okay, so here are some composite things. I take it a chair, an oxygen molecule, a motorbike. And the chair, for instance, you take some pieces of wood which are about the right shape, and you slot them together. And perhaps you glue them, and perhaps you bolt them. And then this congruence of shapes leads to the pushing, the pulling, and perhaps the bolting and the gluing. Hold all this together. So there's a surviving through time of this chair with the acting, this attracting, repelling, pushing, pulling, bolting, adhering. So it survives through time in a very pragmatic, prosaic sort of way. I'm going to call this a surviving acting together. When we come to the water molecule, we have electrostatic forces which cause the oxygen and hydrogen atoms to pull together, and that too survives through time in its context, the acting of those molecules in that way. And again, with the motorbike, we have this bolting together pieces. Right? So in all cases, we have these surviving acting together. Now, it's a crucial to kind of my account of this ontology is we need to recognise the close relationship between processes and things. Processes and things are intimately connected. It is action, and I argue that processes too are the surviving acting togethers of their parts. Right. So in this picture of a firing neuron, we have the action potential arriving, a potential difference across the wall of the neuron. As it arrives, it opens sodium selective gates further down, causing a flood of sodium ions to move into the neuron. That creates a potential difference further down. And we have this cascade at lightning speed with this potential difference travelling along the neuron, at the far end opening vesicles which release neurotransmitter particles into the cleft, which then causes further neurons to fire. So what I want to draw attention to is we have this arrangement of parts, we have a description of what the parts are doing, we have these arrows telling you how the change proceeds, and this sort of picture, I claim, is ubiquitous throughout the sciences, through all the sciences, the spatial layout of parts with a description of what they do. It's consistent with this new mechanist account, which has become perhaps dominant within the philosophy of science, the account to which Cartwright and I, in our joint work, subscribe now. And as I say, it's the processes are not just biological, but in engineering, in physics, in geology, in meteorology, and across all the sciences we find these sorts of processes. So there are borderline cases too between things and processes. So a star is a diffuse nebula, then a main-stage star, red giant planetary nebula, white dwarf. This is clearly some sort of a process, but we take stars to be things, right? At any stage, we take them to be things. So in the convection cells, that are rally convection cells, boiling water, we have these cells which are again sort of have characteristics, process characteristics of things. John Dupre, who did Exeter's group on processes, argues that organisms should be understood as processes too, but most of us, or many of us, also tend to think that horses are things, right? Not processes. So what we have, I argue, is this spectrum of surviving acting togethers. Things tend to be characterized by a stable juxtaposition of their parts, or at least many of their key parts. Processes tend to be characterized by transitioning through stages. And I want to argue that there is really no point of clear division on this spectrum which would allow us to sort of split this into two. That really what we find in the world then is a universe of surviving acting togethers, the processes and things which we find these interesting features of the world at an immediate level, and these are split into these groups of things and processes which are really folk divisions within this class of actings together we find in the world. Okay. So it might seem at first step, well, processes seem very different from things. So here's a picture just to sort of motivate the kind of the commonality. When we characterize processes, we often think about how they are through time. So we think of swinging of the pendulum, right, or we think of the firing of the neuron, and we characterize how it is over time. But when we look at, so that's in the horizontal direction, but when we look on the vertical axis at each stage in the process, we find some things arranged in certain ways which are acting together. All those things are perfectly physical, right? And they share that commonality of having an arrangement of parts acting together, being physical at each stage, right? So the process is characterized by both the changing through time and how it is at each point in time. So there is this, in a sense, this common physicality to both processes and things in this sense. So it's the acting together of parts. What are the parts? The parts in this ontology must be further actings together. Okay, this clearly expects an immediate sort of regress. So this must bottom out in some way. And I suppose that there are elementary actors at the bottom of this thing, which are basic entities. They have no parts themselves. They can act, and they sit in the classical. That's the non-quantum domain. Okay. So these Elementary actors then are going to be the point of contact with the quantum domain, I suppose, that when we look at the lowest level, what is going on there. So this is, what these are is going to be kind of the key sort of investigation, I guess, for the second stage, right? Firstly, we'll map out the macro classical domain, then we'll map it onto the quantum domain. But pro tem, the possibilities would seem to be, well, we take the particles of the standard theory treated as classical somehow, okay. And I mean, that then gives us this immediate intuitive sort of feel for, you know, well, obviously all the things that we find in the world are just the acting together of somehow the micro parts in some sort of complex arrangements. But that might not be satisfactory. Maybe we should better use low-level chemical structures like atoms or certain molecules. And I don't rule out the possibility, right, that in fact what emerges out of the sort of quantum domain, what crystallizes as being a classical thing, might actually be at a much higher level, might be at the level of organisms, for instance. Anyway, for my talk today, I'm really supposing, for the most part, that it's likely to be at a fairly low level, so it's going to be at the level of kind of... surviving, acting together, what sort of ontology are we going to need in order to support such structures, such beings? First up, there's going to have to be acting in our ontology, right? Okay. So I'm going to stress that this ontology has to be quite different from other contemporary ontologies, the Mosaic and the Humean ontologies. So acting, I suppose, is attracting, repelling, heating, dissolving, pushing, cutting, building, teaching, building, and teaching. The Aristotelian type actings through time. Acting occurs through time. It doesn't make any sense on this view to talk about acting as a simple point in time, and it brings about changing through time. Okay. So we bring together a hot object and a cold object with their various powers. They're in suitable contact for some period of time. You have heating and being heated. You have the changing, which is becoming hotter over time. This is, of course, the Aristotelian picture of Aristotelian powers, right? Agent-patient powers. I'm just unashamedly taking Aristotle's account here and introducing it into a kind of contemporary context, if you like, a contemporary thing. We have mutuality, I think, often of these things. So agent-patients are less important than talking about the changing the configuration as a whole, because generally for Aristotle too, as well as for us, the agent causes change in the patient, and the reverse is true as well. So I want to contrast this with the picture that's normally present in the orthodox contemporary case, where we have basically powers in a manifest and an activation state. So we may have some mutual manifestation partners that come together at some point in time, or we may have a power which is in suitable stimulus conditions at some point in time. And then boom, we have the manifestation, and later we have the activation, we have the manifestation state. So there is this jump through time. The manifestation state has to be after the activation state. It can't be at the same time. And of course, if time is continuous, then as Russell points out, there are no successors in continuous time. So there must be a gap between these two states. So as Russell points out in his 1913 diatribe against causal relations, this is deeply problematic, that we have this leap forward of causal influence, this leap forward of the manifestation through some period of time. But this is not a problem for the Aristotelian type approaches of acting powers. Right? So there's a big distinction, I think, between the powers view, which is implicit in action, and the powers view, which is implicit in the contemporary ontologies. So acting involves bringing about changing, so we must have changing too within our ontology. We must have changing, not changing. Okay, and just to simplify, let's talk about the paradigmatic form of changing, which is instantaneous velocity. And again, we don't have, and the way we don't have acting in contemporary ontologies, we don't have changing in contemporary ontologies, because contemporary ontologies are almost universally wedded to the notion, the Attica notion. So let me just rehearse that for those not kind of working on this stuff immediately. Here's what Russell says. Motion consists mainly in the occupation, different places, different time. The arrow is here, it's here, it's here, as Russell puts it. We must entirely reject the notion of a state of motion. There is no transition from place to place. No such thing as velocity, except in the sense of a real number which is the limit of a certain set of quotients. There is no velocity in the ontology. Velocity is eliminated, and that's a triumph of parsimony. Okay. So, why does Russell entirely reject the notion of state of motion? Well, Russell and other neo-Humeans are wedded to the mosaic picture, which Tim mentioned, that the world is, let's give the quote, this is Lewis's famous quote on the subject, all there is to the world is a vast mosaic of local matters of facts. It's one thing and then another. We have a geometry, a system of spatial relations, spatial temporal distance between points, and at those points we have qualities, just properties, sets of properties at each point, which we need nothing more than a point at which to be associated. So we have points in time, points in space. For short, we have an arrangement of qualities, and that's all, a mosaic of points, right? So if you have entities which exist at a single point in time, they simply cannot have a velocity. There can be no change. They're just where they are. The velocity makes no sense. So we have no velocity at the fundamental level, but just to say, I mean, we do have velocities in Russell's system. What we have are these quotients. We can take an object to be a dense infinity of these tiles over some period of time, and what we look at is its average velocity over a short period of time leading up to the point which we're interested in. So we take this distance difference and divide it by the time difference, so we get an average velocity, and then we take the limit as delta time moves to zero. So the issue, why is this not a velocity? Why is this limit not a velocity? Why these are average velocities? It's because these are distances between tiles. The tiles are separate objects at the fundamental level, right? So you have a velocity of the derivative object, which is the thing, the common sense thing, but you have no motion at the fundamental level. At the fundamental level, nothing moves, or at any level. And as Russell says, the limit velocity is merely the limit of a certain set of quotients. This set of quotients, right, over time. So we have no changing within the mosaic. So what we need to have changing, we need to have velocity, we need to have objects which exist through time. Okay? They exist through time in a way which they are not built from point-in-time particles, but they are fundamental at the fundamental level. They exist through time. I'm going to say, I'm going to call this lasting, and surprisingly I find no term in the literature for what I've called lasting, which is why I introduced this new term. Okay? And it's surprising because it seems to me to be a kind of fundamentally important kind of issue associated with ontology. So I argue that this is Aristotle's view, and Aristotelians almost that I've met always agree with me. It's required for Aristotle's teleology, and it's required for his acting, that his objects must exist through time. They couldn't exist through single points in time. It's a view which is hiding in plain sight, but it hasn't been, as far as I can decipher, widely discussed in the contemporary literature. So one of the things I try to do is bring this into the discussions. The world then is lasting, it's not built from point-in-time entities, it's built from lasting things. Okay, so we have, in order to have surviving acting together with our ontology, we have to have a profoundly different ontology from this contemporary view. We have to have acting, changing and lasting. They are intimately related as a triumvirate. In contrast with the Mosaic ontology, see, Aristotle offers an example of this ontology, and my aim is to develop a kind of a generic contemporary view, extracting these ideas from Aristotle and just using these ideas in a sense distilled away from the Aristotelian background. So we need surviving acting togethers. We also need surviving in this ontology. So here's my claim that surviving is the criterion of physical existence. of the objects in this world. It's a physical criterion. So there is no way we can look elsewhere in terms of logical mathematics or in terms of vocabulary, not derived immediately from this experience of physical objects, for looking for what the term survival is going to mean. We must derive our account of surviving from an empirical investigation of the things and processes we find in the world. Right? And this then notion of surviving that we derive from thinking about acting together, surviving acting together, it must be inform our understanding of existence. So existence is not bivalent in this sense, because when we bring things together in order to start acting together, there is no single point at which they come into being. They come into being through processes of bringing parts together. So we have a coming to be as well as being and not being. So we have this ontological indeterminism. There's an ontological indeterminism as well about exactly which parts are part of the process. What's important is we have the pragmatic surviving through time of the acting together, and exactly which parts are part of that can become a secondary issue. And we should welcome, right, an ontology which recognises that things, processes have this level of indeterminism, because my contention is that artifacts, stones, pieces of wood that we find in the world just are indeterministic with respect to their boundaries, and they can come into existence through processes of coming to be. Right. So that's a part of my argument. I see it as positive. Then, thirdly, finally, of this sort of triangle of ideas, we need surviving acting togethers to have their entities together. We need them to have arrangements of their parts. So we saw that things have arrangements of their parts which are characteristically stable. Processes have arrangements of parts at each stage, but transition through different arrangements through different stages. They both have arrangements of parts. So here's a thought, right? That even God, if he is to bring a plurality of objects into the world contemporaneously, classical objects into the world, must dictate the arrangement of those objects. He must determine the arrangement of those objects. You cannot have plurality of objects in the world without their spatial arrangement, physical objects in the world without their spatial arrangement being determined. And that must continue to exist in the way evolving as it does through time, throughout the existence of those objects. So arrangements in this sense, I argue, is ontologically serious. It's central to, I argue, a central feature of the holism of the classical domain, classical non-quantum. And it fits, again, with this new mechanistic count, including my own work. So, in general, of course, if you just have some random plurality of objects, then the arrangement of these things has little significance, right? It just doesn't really matter. But when one has a surviving acting together, then one has something I argue exists. It exists by surviving, right? That's the criteria. And because that exists, then the arrangement of the parts of these surviving acting together has a derivative existence, right? Which we should, I argue, take seriously. Which one of the reasons we should take it seriously is that very arrangement of the parts is what underwrites the surviving of the acting together through time. Okay, so there's a sort of interdependence there. This acting together this arrangement also licenses novel powers. So we have this arrangement, this surviving acting together arrangement, and what we find when we bring the parts together in these arrangements is we often get novel powers of the whole which are not had by the parts. So if we take the paradigmatic case of a motorbike, we bring the parts of the motorbike together, organise them in the right sort of way, get them acting together in the right sort of way. We have something which has this remarkable power to accelerate the rider. Okay, but when we look at the individual parts, or even the parts considered as a plurality, they don't have the power to accelerate the rider. So we have novel powers which come into existence as a result of this arrangement. Genuinely novel powers, which are not powers of the parts of where they come from, Well, they're underwritten by the arrangement. Right? It's bringing that arrangement into being, which leads to these new novel powers. So the power of these acting together, this ability to accelerate the rider, is just the coordinated power of parts in this arrangement. So if it relies on the powers of parts, it relies on the arrangement. And both, I say, are argued to take ontologically seriously. So the whole, I say, has resultant novelty. Resultant, I argue, not emergent, because there is nothing here which, resultant, I think, as a term apart from which emergentists, which contrasts with emergent, there is nothing here which isn't completely prosaic. There's nothing surprising. There's nothing funny happening about putting the parts of a motorbike together and getting a new power, right? It's just resultant. It's just entirely explicable. But it is ontologically irreducible. Yes, we can explain it. Yes, in a sense, it's epistemically reducible to the powers of the parts of the arrangement. It's not ontologically reducible. Why? Because the arrangement is a characteristic of the whole. It's not a characteristic of the parts, nor of the plurality or set of parts. It is it's a characteristic of the whole. So the power is not ontologically reducible. So the arrangement then has some of the characteristics of an Aristotelian form, some but not all of the characteristics of an Aristotelian form. It underwrites the continued existence of the surviving acting together. It underwrites powers of the surviving acting together. But recall its difference is that what it underwrites, the ontological beings have physical existence, but they don't have unqualified uses. So in that sense, they differ from the substantial forms. But what's nice about them is that they're simple and transparent. Right? So unlike forms, which can be somewhat obscure, at least, the surviving acting together, the arrangement is entirely physically transparent. There's nothing here which is complex or different. So here is the summary of the ontology which I think we need to underwrite these surviving acting together. This is why I call it acting arrangement ontology, right? Because these are, in my view, the twin keystones of the ontology of the world in which we live. It also needs surviving in order to get things, surviving as a criterion of existence. It underwrites these acting together. How long do I have? 12 or 4, I don't know, 7 or 8 minutes?
We started 4 minutes
Okay,
late.
6. I've got 4 slides.
You're fine.
So I'll go through them. So I've talked about what we need for the ontology, to want to write these surviving acting together. Now I want to make some brief comments just about this sort of ontology. So first up, I want to compare it with 2 other ontologies which involve things coming into being through the arrangement of the parts. So Empedocles and Aristotle. And just to mention that Mark Sentis's book, Aristotle's Ontology of Change, which was out a couple of years ago, chapter 5 has a really nice discussion of this. So Empedocles thinks that when you arrange parts, that things, ordinary everyday things, do come into being. But he thinks that these things that we find in the world are just mixtures of parts, right? So that there are no new natures come into being. We don't get any new powers. Basically, the only real powers then in the world are the basic powers, the natures, the 4 elements, and then he thinks love and strife is the other one. And so there's mixtures on Empedocles' book. And Aristotle, of course, discusses that in his work, and he rejects that idea, and he says, no, basically, when we make these arrangements in the right type of way, we bring into effectively substantial forms, then we do get genuinely new powers. We get new things in the world. And indeed, the powers of the parts that we bring into these arrangements are kind of co-opted into the whole. So the exact description of what's going on here is somewhat controversial amongst Aristotelians, but effectively the powers of the parts become co-opted. In a sense, there are no actual parts of wholes there are only potential parts of wholes on Aristotle's view, and the wholes exist as fundamental beings in the world, right? So, okay. So on this ontology which I've outlined, there are no, I agree with Aristotle that new power and powers and new power bearers come into being when we make these arrangements. So on this I agree with Aristotle. Why do I say that? Well, recall that I think surviving is the criterion of existence, and when we bring parts together in a way in which they survive through time by acting together, then they exist on the account that I'm advancing. So they do exist. But I disagree with Aristotle that the parts which came into that arrangement cease to be, or cease to exist as actual entities in the world. I think they continue to be actual entities in the world. So we have beings at both levels, we have both a whole, and we have the parts and the powers of those continue to obtain. The powers of the acting together, the powers of the whole then, simply are the coordinating powers of the parts acting together in that arrangement. Okay, so both, so to describe the powers of the whole, you describe the power of the whole, which is the parts acting together, and that's surviving and acting together, or you can describe it as the power of the parts acting together. They're simply different descriptions of the same thing. In the work, my monograph, I make the case that this provides a really transparent solution to the causal exclusion problem. How you can have powers of the whole and powers of the part, which you can have. I just note too that this leaves open nicely the question of what level we should ascribe ontological priority to, whether we should ascribe priority to the whole or priority to the part. So we can decide that now on empirical grounds, theistic preference grounds, or other criteria. So I've set out sort of and described how this acting arrangement ontology delivers support for this view of things, but in the monograph I develop a much fuller ontology. I show how it underlies also properties, possibilities, natural kind, causal relations, knowledge, regularities, laws, and language of truth. Okay, so I argue these features are underwritten in a transparent and explicable way within this changing, lasting acting ontology with arrangements in a way which just isn't true of the mosaic ontology. So my main argument of the monograph is that this is a much more compelling and straightforward account of the ontology, the physical ontology of our world, that fits with science. It's much more parsimonious than these mosaic ontologies, and it solves many of the underlying conundrums which it has. Finally, I just want to make a note on human powers. Okay, so my claim is this, that we can take organisms and humans too to be fiercely complex, surviving acting together. So we wish, regard these as physical arrangements which could have these powers. So human powers are underwritten by these fiercely complex arrangements of the parts. They are distinctively human powers, which are distinct from many powers of the parts, because they are powers of the parts in that arrangement. The arrangements are distinctively human. Right? So it shares a view that there are, but that I argue is consistent with empirical evidence. Okay. But of course, many people will not feel comfortable with that, and I'm agnostic as to other solutions. So one could say, well, one possibility is one we touched on before, that humans may be elementary classical things, so that they might emerge out of the quantum wave function. There may be human beings which are the things which are crystallized as classical objects, highly complex beings, so elementary beings, unqualified unities. But another possibility is that there are also substantial forms, right, which some of the surviving acting together ascribe substantial forms which which underwrite the unqualified unity of those acting together. Right? I mean, perhaps these are licensed by God, if one wished that. Perhaps in other ways it underwrites a particular unqualified unity. So I want to suggest, so this is my final site of this ontology, provides a compelling account of the ontology of our classical world, the non-quantum world, and it also provides a canvas which could be developed by theists or others, which provides kind of a compelling ontology which fits with our experience. Thank you.
So how long?
Yeah, yeah, right.
We're at 14.
People want a break? Deep breath. Hope you've had your stimulant of choice. My name's Chris, and it's just an honour to be in this room. So thank you for everyone who's made this possible. I'm deeply, deeply grateful for the opportunity to share with you. Oh, you've got the magic. Thanks, John. I suppose what I want to say is amen to that, John. And I guess I want to say that there's a word that you might be looking for with lasting, which Van Inwagen would call enduring. But maybe we can discuss that.
Yeah.
Johnson's distinction of the occurrent continuing distinction is really, really important in the 1930s. So I'd like to pick that up.
Yeah, okay.
So this is, in the spirit of being ironic, I want to make the case that there's a way of reading Peter Van Inwagen's work that has been missed in the last 40 years or so. And I'm trying to address that under this title, Hylomorphism and the Inverse Special Composition Question. So, in honour of the late great Dan Dennett, thank God for his life, who recently died. If anyone knows how I can get one of these hats, Hume's hat, I want one. But this is Dan, and he had this lovely line in a conversation on consciousness: philosophy is what you do when you don't yet know the right questions to ask. I think, thanks for that, Dan. But here's the problem. David Wallace said, again, the great David Wallace, said the thing is, in philosophy, most of the work and most of the controversy lies precisely in stating and understanding the questions. And so apparent consensus on how to frame a problem is often a sign of hidden assumptions and communication failure. I think he's absolutely right in the case of quantum mechanics. I think he's absolutely right in the case of the special composition question. Here's where I want to go. There were two, this is the sort of summary, right? There were two special composition questions, note the plural, in Peter Van Inwagen's way of thinking. The first asks roughly, when are objects parts? Where objects here are parts of continuance, which may actually compose a material object that can endure through time. Parts of a pregnant whole organism that can endure the processes of pregnancy, perhaps. But the second is the inverse special composition question, which asks, when are objects wholes? Very roughly, and forgive, philosophy is a bit like the secular equivalent of speaking in tongues. You take things that everybody can understand, translate them into words that not even angels can understand. keeps you in a job. It doesn't do anyone any favours. But if you learn to read it, basically this is what the special composition question is asking for a way of filling out the schema. For some y, the x is composed y if and only if something's true of the x's. And the inverse is asking, for some x's, the x is composed something. Oh, sorry. For some x's, the x is composed y for any y, if and only if something is true of y. Very roughly, here's the problem. People have taken Van Inwagen's answer to the special composition question, which he proposed to answer correctly, right? That when the activity of the x's constitutes a life force, there's only one of the x's, composition occurs. They've assumed that it entails an answer to the inverse special composition question. Roughly, composition occurs when y is a living organism. Right? Or maybe y is, if it's not living, it's really little. Right? Something really small. You know, like a quark, as if everyone knows what a quark is. So here's where we're going. And I want to illustrate the difference between these two special composition questions by showing you two images of a parrot. The first one is from the Lego box set, Lego Creator 3-in-1 Exotic Parrot. Think of what have you got to do to the parts to make it compose something. Have you just got to arrange it? Have you just got to build it up? Or here's Charlie McCall, who got a job at Legoland. Think of, is it something about Charlie? Right, which tells us when composition occurs. Does that make sense? So the first question, the SCQ, is talking about the part. The second is talking about the whole. We'll come back to Charlie. So first point, there's two special composition questions. Second point, in my reading of a vast body of secondary literature that has developed over the past 35 years, only basically very few philosophers have even mentioned this inverse special composition question. And the only philosopher, and in my reading the first and only other philosopher who even considered the significance of this SCQ-ISCQ distinction was the late Catherine Hawley, who sadly died just while I was writing up my thesis on the logic of the special composition question, before I was able to discuss this with her. And I just gutted about that. The second, just to give you a sense of how few people have talked about it, apart from there's 2 PhD theses that have been written on it, but other than that in print, the next person to mention this in the philosophical literature, as far as I know, was Ned Marcosian in a footnote to his own discussion of a much more complex question about simples. We'll come back to that in a footnote. Aaron Cotnoir and Achille Varzir, I've read your, skimmed it, your wonderful, wonderful work, Aaron. I noticed there is one mention of it in a footnote to your discussion of decomposition, which is in singular terms, and there's a footnote on that which mentions the footnote in Marcosian, and there's a comment that's absolutely right in that book, as you'd expect. The third was Alexander Bird in Cambridge, who mentions it again, or rather, he mentions Hawley's insightful discussion again in a footnote. And as far as I know, that's all, folks. So it really is surprising this has been missed for 40 years. And I want to dedicate my present work in honour and gratitude and memory of the late great Catherine Hawley for her life and work in this inside and outside the ontology room. So this order matters that Hawley got there first and Marcosian got there second, right? Because, as we're going to see, Hawley repeatedly credits Marcosian for drawing her attention to this inverse question. Okay, we'll come back to that. Problem is, Hawley uses a less formal mode of presentation, which generated a profound sense of confusion about what this question was. And she associates it with two much more complex questions. First is Ned Marcosian's question about simples. Sounds simple, it's very complex. It's about the nature of a member of a subset of a class of simple physical objects which may not exist. Confused? He calls it the simple question. My goodness me. The second question that she associates it with is a very complex question that Simon Saunders raised in his discussion of Quine's question, are with a physical object. And Saunders addresses the question, are quantum particles objects? And Saunders has an answer according to which fermions are and bosons aren't. Don't want to get stuck in the weeds. Here's the point. Marcosian suggests that Saunders was effectively asking the inverse special composition question. I don't think it was, actually. The effect of that is that Hawley effectively generated some rhetorical equivalencies with speculative microphysics, which generated the scientific literature to think that Van Inwagen was all about speculative a priori microphysics. And just to tell you my own story, I cut my teeth in philosophy with James Ladyman, amazing philosopher, who basically taught me to think that Van Inwagen was doing this speculative microphysicalist a priori stuff. And I just wrote him off. Mea culpa. Okay, so I'm going to show why this matters and might be of interest to you folks. First, for the development of a thing called hylomorphism. Second, for the very, very, very complex idea of a middle-sized object being identified as a composite one. I may say this draws together two of my own projects on the logic of the special composition questions and my profound interest in isms. So what's the stake in isms? And here's another ism. I'm going to squint at it. All right, so here we go. I'm going to try and do things. I don't want to get stuck in the weeds. I'm going to try and do some ground clearing, okay? So I'm going to go through 4 stages. First, clear out the difference between Mariology, semantics, and ontology. So here's Ted Sider in his ironically and revealingly titled essay, Ontological Realism, starts with a tongue-in-cheek paraphrase of the question. He says, in 1987, Peter van Inwagen asked a good question, brackets, asking the right question is often the hardest part. He's absolutely right. We're going to get lost in this discussion if we don't learn to distinguish some Mariological questions from semantical questions, from ontological questions, and maybe psychological questions. Here's what I mean by Mariological question. By the way, Mariology sounds like Mariology, so you Catholics in the room. I'm not talking about the Blessed Virgin Mary. That's come up more than once. Mariology comes from the Greek word meros, meaning part. Okay, so it's the logos of part relations, the account parts. There's some Polish logicians in the 1920s and 30s who were interested in organisms, by the way, but we can talk about that well on the polls. Here's a Mariological claim. Some things compose something, or some things are parts of something. That's a Mariological claim. Here's an ontological claim. Some things exist, some things don't actually exist. Here's a semantical claim. Some terms actually refer to something. Maybe some things actually mean something. So here's some examples. You might say, like David Lewis, that some things, e.g. tables, donkeys, classes, and gods, compose something. The Mariological sum of all those things. You might think that some things, tables, donkeys, classes, and gods, exist. They actually exist. You might think that some things don't compose something. You might think that some things don't actually exist. But to whatever the merits, you mustn't confuse the Mariological claim that some things don't compose something with the ontological claim that some things do or don't exist. Here's some examples. You might begin to see that there are many ways to live in denial, right? So you might be live in Mariological denial and deny that some things compose something. Or you might live in ontological denial and think that some things don't exist. Or you might live in semantical denial and say that some terms don't refer to something. Maybe they refer to many things. Or you might be in psychological denial, that some statements like his table is an old packing case just doesn't mean anything. I just want to separate out the issues. Van Inwagen insists that he is a metaphysician and not a madman. The only thing he's interested in is the Mariological claim in his book Material Beings. That may sound surprising, but let me just suggest that if you think that one of the most careful and exact analytic philosophers of the post-Quinian era wrote a seminal book of metaphysics whose implication was that some things don't exist, you're reading him wrong. My position, he says, is that when people say things in the ordinary business of life by uttering sentences like there are tables, there are stars, there are chairs, they very often say things that are literally true. There really are such things as tables and chairs and lions and bears. Whether they compose something is another question. You might know that in his recent work on existence, he's made a distinction between internal and two contexts of utterance. And he has this line that many philosophers think that I'm writing revisionary metaphysics. That's a mistake. I actually regard the book as a metaphysical implication of every of the things we all believe. I can't defend that here. I'm going to try and defend that. So confusion about these different ways of living in denial has generated confusion about a thing called nihilism in the literature. So here's Ted Sider. According to these Mariological nihilists, tables, chairs, computers, molecules, people, and other composite objects simply don't exist. All that exist are simples, they say, entities without further proper parts, subatomic particles, presumably, which are arranged in various ways and so on. Van Inwagen also dispensed with tables and chairs. No, he didn't. But he departed from the nihilist by admitting people and other living things into his ontology. Brackets. Why he spared the living, few could tell. I think Sider's parenthetical remarks are related. In fact, they're revealing. We've been asking the wrong question. We'll come back to that. Well, here's James and Jonas Wakener in their work on ordinary objects in Bill Brewer's wonderful collection. Recently, many philosophers working in Mariology have embraced Mariological nihilism. Now, here's the confusion, which is the view that it's metaphysically necessary that no composite object exists. Prima facie, they say, nihilism entails that apart from a few tentative present or future scientific concepts, no human concept or expression could successfully refer. Whatever the merits of that claim, just note the modal ontological claim about an existence of a class, the membership of a class of composite objects, and the semantical claim about whether the terms refer, they're confusing the issues. In his 2013 essay against partnerhood, Ted Sider says that he's going to defend this crazy view. What Peter van Inwagen calls nihilism, composite entities don't exist. Footnote. It's all in the footnotes, folks. For stylistic reasons, I speak of existence, but as a good Quinian, he says. I intend this to be recast in terms of quantification. Now, whatever a good Quinian is, I dare say Peter van Inwagen and David Lewis were very, very naughty Quinians. Because they invoke categorical realism about proper parts, metaphysical realism about part-whole relations, and logical pluralism about quantification. Bad Quinians. However, here's a precise statement of nihilism in Peter van Inwagen's book. For some y, the x is composed y, if and only if there's only one of the x's. Basically what that means is proper parthood never occurs. Okay, now, Alyssa, thank you so much. I want to credit Alyssa Ney for first drawing my attention to this point. In her book Metaphysics, she points out not only the use that Peter van Inwagen made of first order plural quantification, but the necessity of the apparatus for objectively plural quantification. Thank you. It's necessary to introduce a new kind of logical apparatus to even to formulate the questions. Here's van Inwagen's explanation. For some x's, read for some values of the x's, and for any values of the x's, those operators do not bind or in any way interact with a singular term. By the same token, for some x and for any x, do not bind or interact with the plural variable term. The x's is not a context within which a singular variable occurs. Now, why does this matter? Here's why it matters. To answer the special composition question, you need a single, first-order, free plural variable term to be free in that sentence. No other variable can be free in that sentence. The sentence has got to have no mereological terms, and it's got to satisfy that schema. Subject to existential generalization, first-order, plural logic. What this means is that there are two special composition questions, because there are two variables in the formula, some x's compose y, which means the general composition question can be thought as general with respect to both of these questions. Many people in secondary literature distinguish the special and general composition question like this. The special composition question asks when composition occurs. The general question asks what composition is. However useful that is, it's never going to distinguish from the other way of asking when composition occurs, okay? So he says one way of asking it is the special composition question. Roughly, when are objects parts? There's also this other question, which objects are composite or when are objects wholes? To answer the special composition question, he says, is to find a suitable replacement for some y, the x is composed y, a sentence containing a free plural variable. The opposite would be to find a suitable replacement for some x's, the x is properly composed y, right, that only appeals to the y. Without the qualification properly, y is y would be a suitable replacement. Now this has been lost in translation into second order singular terms. Case in point, Ted Sider. Everybody has told me that I'm playing with words, and that you can translate all of this into second order and higher order language of sets, and when a set has a fusion. A class S has a fusion if and only if ... is how to ask the question. That would be an answer to Peter van Inwagen's special composition question. Footnote. Actually, the special composition question is slightly different because it asks when fusion takes place at a time. With all due respect to the author of Four-Dimensionalism, there are three special composition questions in van Inwagen's book. None of them ask when fusion occurs. The clue's in the name. It asks when the composition of a material object occurs. Here's Sider again in his 1993 essay on van Inwagen and the possibility of God. Here is a philosophical question. What conditions must obtain for those objects to compose something? In his recent book, Material Beings, Peter van Inwagen addresses this question, which he calls the special composition question. His answer is, for any material object X, i.e. any second order class of objects X, the members of the X, right, the X is composed of given only. And he accepts a simpler thesis that follows from that, which is every material object is either, i.e. every Y is either a living thing or a biological atom. Footnote. I don't know why he thinks this, but I think this because There are many ways to ask these questions. Here's the name of the game. You're trying to make a first order principle of composition of that form. It might be easier if you're not used to plural logic just to think in terms of first order logic. Think of standard logic rather, of a part-whole relation that can be defined in terms of composition. For some y, x is a part of y in case something's true of x, so x is caught up into a life. Compare that with what Marcosian has recently called a question about partnerhood. He has a lovely line. He says, I think Mariological sanity, because this whole debate is insane, isn't it? Mariological sanity can be restored by asking another question which has not been discussed in the literature on the Mariology of physical objects, whatever they are. I think this is simpler than SCQ and it's much more basic. Here's the question I have in mind, and he calls this one question. Under what circumstances is one object a proper part of another object? Actually, what Marcosian really wants to know is a bit more complex. I wish Marcosian well on the road to Mariological sanity. I think there are many ways to get there. But this is not simpler or more basic than SCQ, it's much more complex. I won't go into the details of it. Okay, so we've distinguished Mariological claims from semantical and ontological claims. We've seen that the Mariological questions that Van Imwagen was asking are in fact 3 dozen, but 3 basic ones. The point is the inverse question has been neglected. Catherine actually drew attention to its neglect in 5 papers. And what you find is she only uses informal presentations, and you get complete confusion about what the question's even about. So first we have, it's a question about parthood. The second is, it's not about parthood, but the property an object instantiates when it has proper parts. So is it about parthood or proper parthood? Or the property a thing has when it has proper parts? These are categorically different kinds of things. They're having a proper parts and they're having a proper ties when you have proper parts. They're different, subtly different. Here's a discussion of Saunders. She's suggesting that it's really about the applicability of a Leibnizian principle of individuation, which Leibniz applied to substances, to differences in the quantum statistics of elementary particles of different types. And she suggests that Saunders is using the principle of the identity of indiscernibles to address the inverse special composition question. That's an interpretation. I think that was a mistake. Or here's Hawley again saying, I'm just talking about a subgroup. Now you get this repeated reference to Ned Marcosian, and even a false sense of equivalence, that the question that she was asking was the neglected question, which is equivalent to the simple question about the condition under which an object is neurologically simple. Now these credits to Ned Marcosian are very curious, folks, because in his essay, Simples, Marcosian explicitly says, no one I know has ever discussed this question. And he's read Van Imwagen. I hope this paper will generate more discussion of the simple question which has been neglected. Hawley, I think, picks up this neglect of the simple question, assumes it's the same as Van Imwagen's question, and she addresses that. I think that was a mistake. Okay. So, basically in 40 years no one's discussed it. The only person who did, bless her, I think she wasn't quite as formal as she might have been, and it was a bit confused. So finally, who cares? Well, Van Imwagen, for his part, thinks he's pretty close to Aristotle's metaphysics. But it's very difficult to translate Aristotle's metaphysics into the idiom of 20th century analytical philosophy. And one risks anachronism if one tries. First, there is no need to begin or end, if you're going to ask the special composition question, with any presumption of materialism about parts, or atomism about objects, or reductionism about properties. Van Imwagen's explicit statements on this matter are worth comparing with what's often attributed. So we shall not presuppose that if the X is composed of a material object, any of the X's is a material object. We shall not propose that any material object has Non-composite parts, we just won't assume that. And the thesis that the properties of organisms are not wholly determined by the properties of their parts. That's sometimes called holism. Whether holism is correct, I don't know. None of the questions I'm trying to settle made me decide on holism. Compare that with what has been attributed to Van Inwagen. We're told by Ladyman, Ross and Spurritt that Van Inwagen assumes for the purposes of his argument the truth of atomism. Okay? Understood as the view that all material things ultimately decompose. Van Inwagen does not use the word material thing once, except in the preface to that book. We're told that Van Inwagen has a Democritean image of a world mereologically composed of simple atoms. Now the irony is profound, that as Bas van Fraassen pointed out to me, it was precisely the image of a world composed of simple atoms that Van Inwagen was root and branch calling into question. Alan Ferner, in his wonderful book on David Wiggins, says Van Inwagen claims his position as Aristotelian and Quinian, but being Quinian, he's reductionist about biology, and being reductionist about biology, reducing biological life to physical-chemical reactions, he cannot also be Aristotelian. Now, whatever the merits of being Quinian in matters of some ontology, we should distinguish that from his being Aristotelian in his metaphysics. Here's Van Inwagen's view. My proposed answer is consistent with the existence of simples, maybe elements, the bottom-out parts of continuums. Does it require them? There's two ways to think about that. Aristotle might have thought that organisms have no proper parts, that they're entirely composed of absolutely continuous stuff. This doesn't entail that there are no simples, but just that living organisms are simples. He sometimes suggests that you can think of a simple having a life of its own. You might think of the life of a simple, or the life of a cell, or the life of an organism, or the life of an ecosystem. What's a life? He sometimes says that the Greeks use the word suke in the way he means life. Maybe we should be talking about pansukeism. We might say that all physical objects are living organisms. Some of them, the simples, have degenerate lives. If we adopted that convention, and the convention that every organism is caught up in its own life, then you could have these answers. The sum y x is composed y if the activity of the x's constitutes a life. That's the answer he proposes to defend. You could also have an answer to the general composition question. You could also have an answer to the general part of the question, x is a part of y if it's caught up in the life of y. What's this all got to do with hylomorphism? I'm coming into land. The term hylomorphism is a neologism of the 19th century. There are no English, French, or German cognates of the noun hylomorphism, hylomorphisme, hylomorphismus before 1818. This is a Google Ngram, by the way. It's great fun if you want to search your name. Philip would probably be off the charts. But here's the point. The German word hylomorphism is a little bump around 1860. We'll see why. It rises and falls. The Germans aren't yet into hylomorphism, apparently. How about the English-speaking books? Again, a little bump after 1880. We're going to see why. And then it's all the rage in contemporary philosophy. It's an ancient thing, isn't it, hylomorphism? Here's a letter from Friedrich Schleiermacher to Friedrich Jacobi in 1818. It was translated by a woman called Frederica Rowan into English in 1858. She omitted a parenthesis in her 1860 translation. Views are unavoidable in regard to the interpretation of the religious feeling. Whether hylomorphismus is not equally indispensable in regard to natural science, I cannot undertake to determine because I'm not sufficiently acquainted with the subject. So he's contrasting hylomorphismus with anthropomorphismus and idiomorphismus. Parenthesis. I would not like to have hylomorphismus taken atomistically, but rather how it's implicated in lebendigste Physik, forgive my German, the most living physics. Now I am not an expert in lebendigste Physik. I've done a little bit of quantum physics, but I don't know what living physics was. And I don't think Schleiermacher did either. In the English language, the first use of the term hylomorphism is in a 1888 study of religion by an Oxford Unitarian by the name of James Martineau. It's the first entry in the Oxford English Dictionary that begins in 1901, and it has this definition. which I suspect that Messrs. Simpson and Koons would not agree with. The doctrine that primordial matter is the first cause of the universe. Now, whatever the sense of that doctrine, it has a bit about the Houlet part, but nothing about the Morphe part, right? But hylomorphism's all the rage these days. A cursory glance at the titles gives a sense of the trend. We've had it applied to the incarnation. It solves the mind-body problem. We've got a theory of artifacts. We've got a biologically informed a hylomorphic solution to the grounding problem, whatever that is, and a cosmic power hylomorphism. Now, forgive my flippancy. This is really, really interesting stuff, right? But what is hylomorphism that we should be mindful of it? In his essay Hylomorphism, Mark Johnston, not Johnson, suggested this as a canonical definition. A statement of the genuine parts and principle of unity of an item has the following canonical form. At a given level of composition, what it is for some y to exist or be is for some x's to be specified in the relation of R. Ring any bells? The idea that each complex item will have some canonical statement that's true of it might fairly be called hylomorphism. Now, in my reading, hylomorphism requires no less than an answer to SCQ and no less than an answer to the inverse special composition question 2. Well, here's Evney. He offers a definition. All it takes to be a hylomorphist is to believe that some things, whatever things are, stand in the relation of being the matter of to other things. And this relation is irreflexive and asymmetric. Now, with all due respect, the author of Parts of Classes would be a hylomorphist on that conception. How about in his 2020 essay in the Stanford Encyclopedia of Philosophy, Chris Shields, in the section on hylomorphism, defines it as this: ordinary objects, whatever they are composites of matter and form. Forgive me for overrun. In his book, The Activity of Being, Arya Cosman explains what makes such descriptions so misleading. They've missed a regress argument in Aristotle's Metaphysics, book Zeta, that's 7, that matter and form cannot be elements. Right? Because otherwise, if they're both parts of something, well, what binds the matter and the form together? I wonder if Catherine Kislicki has changed her mind on this, actually. I don't actually know what she thinks, but here's what she wrote in her most recent 23 book. I believe the hylomorphic conception of matter is this: the matter of a concrete particular object, according to the hylomorphic conception, is nothing other than the material parts which compose it. In 1987, Peter Simons hadn't begun to do plural logic, and he hadn't engaged the logic of vagueness. But he asked a very good question at the end of his book. What is it about an integrated whole in virtue of which it hangs together in a way that some arbitrary sums do not? It seems that so the explanation must refer to some kind of relation between the parts of an integrated whole. Right? Ring any bells? We should give this a more formal characterization. Husserl, in his logical investigations, father of Mariology, by the way, treats many Aristotelian problems without mentioning the philosopher by name. He essays there a definition of a pregnant whole. You might know the pregnancy debate at the moment, as one all of whose parts are connected by relational foundation. Seems like a kind of ontological dependence. And Simons, who by no means is a theist, says, now there is this idea in traditional theology that everything is ontologically dependent on God. Not because God exists necessarily, but because of the activity of God. Peter van Inwagen asked a very good question. Asking the right question is often the hardest part. There might be more questions to ask. For example, when is it said or thought or supposed to be true that composition occurs? Or why is it true? Or when must it be true? But thanks for listening. Sorry for
You're not right. That's right. All right, so let's make some comments, and these are two.
No, you're pulling your book. This is going to pop.
I know. Sorry about that. Did I mess it up?
No.
Sorry. William organized this and had me give 3 papers this week, 2 little comments and a summary at the end. And now the end is swimming. So I'll try to say something briefly about these 2 very rich papers, but lots going on in them. For John, it reminds me of an Oxford Don, Reverend Spooner, I believe he was, who gave a lecture, gave a sermon, and people in the audience were just scratching their heads, said, what the heck is he saying? He sat down, stood up again at the pulpit and said, oh, whenever I said St. Paul, I meant Aristotle. So roughly, if you take John's talk, and whenever he said physical, replace it with natural or something, and then I would totally agree, right? So it brings out an interesting difference here between folks within this broad hylomorphic camp, right? Which is how do we flesh out some of the details of the schema? And John keeps saying that he's open to and agnostic about these important questions that I'm interested in, so I want to try to draw him in like the siren, a little closer to the rocks, and to take some of these things more seriously. So in particular, right, the really interesting question is, I think, are there composite substances, right? Are there, as you mentioned, Ian, substantial forms that give a kind of real unity, a more fundamental unity to the composite thing, over and above this kind of thing you find in a motorcycle and other kinds of systems that you describe. And this does seem to be related to the notion of powers, I think. So when John talks about novel powers, I think he means something like weakly emergent powers in Tim's sense, right? And so I assume that if we have something that's a substance, a composite substance, right, that it will then have strongly emergent powers. And that somehow the fact that it has a greater degree of unity, a kind of metaphysical per se unity, as we say among Thomists, qualifies it somehow to be the bearer of a kind of fundamental power, metaphysically fundamental power, which then the interesting question is, how does that relate to the powers of the parts, right? This is a bit of theme that's come up in actually both talks, right? And my thought is something along these lines, that when a thing is caught up in the life of the substance, so to speak, actually, this is a cost of my view, my fairly extreme view, is that it's annihilated and a new thing of a similar kind is created, which by its very essence belongs to the whole. There's a kind of what we call reverse mereological essentialism. That is, all the parts of my body, all the way down to the quarks, are essentially parts of me, right? Because, although they have very similar powers to quarks and electrons out in the wild, they're not exactly the same kind of powers because their powers are not teleologically subordinated to me as a living organism. They're playing some kind of role within the chemistry of some part of the cell, which is part of the body, and so on. And so at an ontological level, that makes a real difference. Now, it's not something that biochemists are going to be interested in. They're not going to care whether it's numerically the same electron as was adjusted in the water. But we ontologists may think that's important, especially when we're thinking about whether there are indeed these fundamental powers at the composite level, whether we can think about the relationship here as one of a kind of ontological subordination of the parts to the purposes of the whole, such that the whole is now able to use those parts in order to accomplish purposes that are irreducibly holistic purposes in some sense. So that's the account. And I think the other thing that might be relevant here is that I don't remember John mentioning the word essence or even nature much in the talk. And I think that this is something Aristotle is going to insist on, is that the distribution of causal powers and potentialities are determined by natures or essences of things. I think John's going to need it, even on his hyper-physicalist version, right? Because once you get down to the very simple things, the elementary actors, their powers are not going to be transparent in the way that you described powers of the motorcycle. So they're going to have to come from somewhere else, and they're going to have to come from an essence of the electron or something like that. So the question then is, are there essences at the level of composite things, right, that could be then responsible for fundamental powers at those levels? This touches actually on Chris's point that hylomorphism is obviously said in many ways. It's sort of a family resemblance notion. I wrote a paper in 2014 where I distinguished between faint-hearted and staunch. Everybody knows that one. So one paper that made an impact. And I feel like it was an important. I think I was making an interesting point there, which is that there are concentric circles here, right, of folks, depending on how much of the Aristotelian package, as we understand it, once taken on board. So just a couple minor things about John's point. The point about active powers, I want to get into that. So my interpretation of Aristotle is that he has both what John calls acting powers that take place over time, and also instantaneous powers. You might call them active powers that manifest instantaneously. And I guess I would follow the argument that said that there's a there's a problem here with the continuity of time. It's not clear why an agent couldn't act at time t and manifest at time t as well in the patient. So the very change the agents bring about occurs at the same moment of time. There's a kind of logical or causal priority. I don't see why there has to be a temporal priority in order for that to make sense. And I think Aristotle allows for that in his ontology, as well as the kind of case where agent and patient are working together over some period of time. So I just wanted to raise that. Okay. I think that's most all I want to say about John. So, and let me switch over to Chris. So unfortunately, I didn't get a hold of Chris's paper because I couldn't access the Dropbox folder properly until last night. And as you know from the talk, it's a pretty rich paper. So let me just say, let me give a stab at the inverse compositional question. I have to admit, I've never run across it before. I missed it, but I never again too. So I'm in the vast majority of people who just were oblivious to this question. I think it is an interesting question, right? So when is something composite, right? When does it have proper parts? I guess can I say that roughly? So as I thought about this last night, I was thinking, I think from an Aristotelian point of view, it's more natural to define when a thing is simple, when it lacks proper parts, right? Because you want the definition to be positive, and as I tried to figure out definition of being composite, I kept coming with negative things. I said, well, let's try the other way around. This actually reminds me of a section in Thomas. I think it's in the Commentary on Metaphysics, where he also says, simplicity is the fundamental notion here, right? And then composite means not simple. So it's derived from the notion of simplicity. So I would go here's a couple shots at the question. So then you can tell me, Chris, if I'm still misunderstanding the question or need to get more sophisticated with my formal presentation of it. But one possibility would be to just give kind of a list. So something is simple in this sense, if and only if it's God in first, God, or an elementary particle. Here I'd actually list, photon, quark, and so on, right? Or an instant of time, or a point in space, or the empty set, or a singleton. Something like that, right? And then, of course, the worry, I think, would be, well, wait, I really want this to apply in any possible world, and God could have created worlds where there are lots of different kinds of natural kinds of simple things, not including, quarks and so on. So here's another shot at it. The slightly more robust. So it's something simple if and only if let's see, I guess this is going to be, no, actually this one's going to have to go back the other direction, so that's kind of interesting. So I ended up with a definition of what it would be to be properly composite, just in case X occupies a region that isn't a point, or persists through a period of time that isn't an instant. Right? So the claim would be anything that occupies a non-point-like region of space, or persists through a non-point-like space of time would have to be composite in some sense. And that raises me to actually the last point, which I think also came up in both talks, which is whether Aristotle himself and whether good Aristotelians today should think that substances have proper parts at all. Right? So one option, and I think Anna Marmordoro has defended this, and Alex Proust has defended it as well, is exactly the idea that a substance has no actual proper parts. So I'm simple. So I don't really have a left hand. I'm left-handed over here, so to speak. Right? There's no entity that actually performs that role. So I've thought that that's not really the right way to go for an Aristotelian. I'd rather suppose that I do actually have proper parts, and that the dependency then. So then there's the burden of explaining exactly what the dependency is going to be, what kind of ontological dependency is going to be between the proper part and the whole substance. And I would do that again in terms of essences. Only the substances have true essences that are self-contained. The essences of the parts are always somehow derived, and that relates again to the notion of powers. All the metaphysically fundamental powers of this stuff are at my level, and they're all the powers of the parts are then derived, I think. Okay, I'll put there and open up some questions. Responses that you wanted to get.
We should do 15 minutes of questions between starting lunch, 10-minute delay, and we'll make up the time at lunch.
Okay, sounds good. So 15 minutes?
Well, shall I just briefly respond, Robert, to the last thing you said?
Yeah.
So my worry about the list approach is that makes answering the inverse special composition extremely hard, because you basically need to complete your ontology and monadic focus.
Yeah.
And good luck. Second point is, if you take the Aristotelian idea that Van Imoghen's open to, that you don't actually have proper parts, well, that's mereological nihilism, right? And the fact that you can ask the inverse special composition question consistent with mereological nihilism suggests that you would just need to complete your ontology to even do it. And that's a hard problem, but there is an easier problem, which is you can ask the first question. But you don't have
I'm not sure if I quite follow that. So suppose I'm a mereological nihilist. Right? I still have an inverse compositional question to answer. Okay, because I just have to describe what. I mean, there'll be no composite things then.
Well,
right?
Every object will be part of something itself, and everything will be a whole, namely the whole that is itself.
Right.
It just won't be a proper part of anything else.
Right.
And so you just can have, it's consistent with mereological nihilism that there are tables and chairs and laughter beds and all these things are just simple.
Yes, right. Okay, but why not just say, so something's positive and only if it's self-identical?
That would do, if mereological nihilism was true, which I'm very tempted.
Right.
I just, the space of possibilities here is vast, but thank you for the comments.
So thanks, Rob, for those comments. I mean, they're very helpful, and I'll think them through. So the one thing I just said, instantaneous change.
Mm-hmm.
I actually would be interested to discuss that more, but I don't read Aristotle's for instantaneous change.
Mm-hmm.
Where he does believe that there are instantaneous transitions. So, for instance, when a house comes into is built, right, you have the building of the house, you have building materials, you have the process of building. Right? And then, because for Aristotle the house can't sort of half exist, it must come into existence at a single point in time.
Mm-hmm.
Right? So at the end of this kind of like process of changing, then one has an instant at which it comes into being. But that's not instantaneous change, that's a transition. Aristotle uses a different term for it. Right? It kind of just crosses a boundary. So it's like something moving through time and then it crosses a boundary.
So underlying any such transition, there's always a continuous process of change.
Yeah, that's my reading. So, and you can't have change at a point in time because if you had a
what about initiating activity? Let's say. So I'm not contemplating number two, and then I'm contemplating number two, right? That seems like it could be instantaneous.
Well, so I guess what I want to resist is the idea that you can have a point at which your powers are there and about ready to manifest, so the powers to manifest. And then the manifestation can be there at the same point in time. And that seems just to me problematic because it seems to me that you have two potentially incompatible states which coexist. Something is ready to manifest and has manifested, and so it was kind of and generally the manifested state will have properties which are incompatible with the pre-manifestation state. That's because it's a change, right? So it threatens the incompatibility of the existing of coexisting states. I don't read Aristotle as supporting that.
Then suppose you have an agent and a patient,
Yeah.
right? So at time t, the agent exercises a certain power. That doesn't require any change in the agent in general, on Aristotle, but it does. So agent-patient powers. I read for Aristotle, you have to have the agent-patient in suitable contact, and that has to occur over some period of time. I see.
So I don't think he could have. I just don't think there's a possibility of them being just in contact for a single point in time. Right?
I see.
I mean that's my reading.
Okay.
Anyway, you talk about small, but anyway, I mean, so there's a whole series of other very interesting points.
Yeah. By the way, I totally agree with you about the rejecting the ad stuff, and I think it's really crucial to avoid Zeno paradoxes and other kind of super task paradoxes as well.
I'm not sure if I'm jumping a queue. Is that
No,
right?
you're first.
So third talk's obviously much really thought-provoking. My question is mostly for John. I've got two. One's more of an observation, which I'll quickly make. When I heard the diatribe from Russell about causation and mosaic ontology, I've met that idea before. I'm not shocked. But does anyone then immediately write another diatribe, adopting velocity as their fundamental idea, and then position it just becomes the integral of velocity. For every sentence in one diatribe, you can work out a matching one. Is that just commonly known? Is that a reaction which a lot of people have already expressed?
I think I don't come across contemporary arguments in favour of velocity, of reality of velocity.
Yeah. Okay.
So I think I can't find them more recently.
Yeah, it's not logically obvious why you pick one over the other, and I would just both, but there we are.
Sure.
Okay, thanks for that. But let perhaps a more interesting question is that it seems natural that the composite would be composed of parts. Well, obviously, what else could the words mean?
Yeah.
But then you get to the idea of an elementary actor which has no parts.
Yeah.
Again, surely that must be what you would say would be elementary. And the observation is simply that it's not so easy to point to an elementary actor. In what we know of the world,
Sure, yeah.
You get down to things like electrons. Do they have parts? Well, yes and no. What even are they? It's an excitation of a field. Does a field have parts? For sure it does. Well, I would argue. So it's amazing how this thought that there must be an elementary thing which does not have parts, which seems so obvious, is itself really not so certain.
I absolutely agree. So thanks for that question. So
Would you really be consistent with gunk, for instance?
Okay.
Gunk, that'd be a consistent possibility.
I don't think I could go with
So gunk is the idea that there's no simplest at all, just smaller and smaller and smaller ad infinitum.
But
At the bottom.
Yeah. But I think the answer to the question is so this is the difficulty that we all have of connecting the quantum domain to the classical domain. Right? So what I've been talking about is the classical domain, trying to make progress, right, in the ontology of the classical domain, which seems to me, so I think I'm saying some stuff which has not been widely said, right? So yes, it's certainly true that I leave open this important question of what are the elementary actors and how do we kind of connect to the quantum domain. So that's a hard question for, indeed, that's one of the kind of ideas. But perhaps to sort of give some optimism there, we could choose that at a variety of levels, and perhaps a sort of a pragmatic kind of level, we could take atoms or certain molecules to be the ones which we're going to choose for the base of the classical ontology. But, so yeah, it's a task which needs to be performed to tie up.
I just have a very brief. Yeah. There's a thing called mereological pluralism. We don't need to think part is univocal. So you can have part of a field, and part of an event, and part of a curve, and part of an object, and part of a body, and part of a part of a process. And maybe some of these are more fundamental than other types, but to have you could have the manifest stuff constituted by the activity of the more fundamental stuff.
That's good. Vera?
Thank you. I also have a question for John, and it may be partly related to the previous exchange. So one way to think about those fundamental ontologies is to ask what you would have to throw into the world in order to create everything. And, well, basically my question is what your answer to that question would be. So, Lewis has a clear answer to that question, and I was just wondering what you would say.
Okay, so one would need to throw into the world all the elementary actors, basically. And you'd need to have space and time for, you need to have space for them to exist in. Right? So once you've got all the elementary actors in space, then you have them.
The elementary actors
Well, that's the
composed, and are they composed of something? Because when you drew this triangle consisting of acting, changing, and lasting, I was just wondering whether there were three features at play here, or whether one of them would be reducible to the other ones.
I don't think those three features are irreducible. So the elementary actors you want to choose as having no parts. That's the same difficult question as how you connect to the quantum domain, and that is sort of something one needs to do once. I need to do at some stage, but it's
right here in the picture.
Yes, thank you both for brilliant talks. I have two questions for you both. Two for John, which is, can you distinguish lasting from surviving from enduring or perduring? That's one. The second is what makes a SAT arrangement unified? I mean, this is quite analogous to what unifies a substantial form. I mean, can I have a gerrymandered SAT arrangement, for instance? There's two questions for you, Chris.
Sorry. Two is already a lot.
Okay. So lasting and surviving are intimately related, right? Because I mean, they're kind of, in the scheme of things, they're very, very, sort of similar terms. But enduring. So, and Chris mentioned this. Right? So basically, I mean, there may be possibly people who use enduring in the same way as I use lasting. Perhaps I'll read the material beings and see whether it is one of them. But the reason I can't use enduring is because enduring is used in lots of ways, and it's used by, for instance, the mosaicists. Right? They think that there are enduring things. For them, what is enduring is not what I would is definitely not lasting, right? Because all of their stuff is built from point-in-time entities. So
they were talking about perjury.
So but they would reject it. But in that debate, what one finds is a whole series of different people that use it in ways which would be consistent with having point-in-time entities, right? So I've got so anyway, so there's more to be said on that. I've written a paper which is Aristotle's alternative to enduring. Enduring came out in about 2 or 3 years ago. It's on my website. So it's and the alternative is lasting, right? So that's so the point about whether you could have gerrymandered objects is gerrymandered objects would simply not have. It's simply not the case that they act together in a way that survives through time. So if you choose the Eiffel Tower and my left foot and an angel, then they just don't act together in a way which survives through time. So there's a principal case for these, just so they don't have the same, they don't satisfy the criterion for existence which I set out, which is they're acting together, must survive through time.
I think Alyssa, you had your hand up.
Oh, yeah, well, it was just a similar, I mean, it was the same thing, Chris.
Okay.
But I just wanted to mention, I mean, like in Sally Haslinger's papers, like early papers defending endurantism, it's just, she's saying things that are just very, very similar to what you're saying and placing them like totally explicitly in an Aristotelian context.
Yeah. Number 2, good suggestion. Ours?
Yeah, this is a comment on John, a question, broader in the sense. It seems to be assumed that anything that's not Hume, Lewis, Radical, Russell is a return to Aristotle. Everything you said would have been agreed to by Descartes, Locke, probably Scottish common sense philosophy of the 18th century, Broad, Moore, much of it by Armstrong, not quite on Powers. So it's not the case that these things are returned to Aristotle, they're a rejection of a certain kind of radical empiricism, which most modern philosophers have not been. Some are, and it's in tradition, but it's not.
Well, there were a few philosophers I didn't include in my talk. just had the excuse for time, didn't really permit me to include all of those guys. But I think the point is, I'm not attempting to return to Aristotle. I'm not an Aristotelian.
Right.
All I've done is taken a very selected piece of Aristotle, his account of change. I've tried to introduce that into the contemporary debate. So if presentationally I discussed Aristotle and I discussed the contemporary view, it was really on account of time. And
your part was really directed to me. I think his bar was directed to me, but you were just a proxy for me, I think, in the case. Yeah, we're running out. I want to get Robbie and Aaron in here real quick. Good.
Thank you. I enjoyed both of your talks very much. A question for you, John. Acting together, can you distinguish that from Catherine Koslicki's teamwork requiring capacities that create a restricted composition?
Yeah. I mean, Koslicki tries to use relations, right? And she thinks when things are in the right relation, there's a kind of an atom which unifies. She's had
there's a what? I'm sorry, can you hear you?
Koslicki thinks there's a kind of an atom which unifies the arrangement so she's had various versions of it, with 2 or 3 books. But it essentially relies upon relations. Okay, so that's very different. Because Leakey doesn't have acting, as far as I know. I don't hear her talking about that. She doesn't have surviving as a criterion, and she doesn't talk about the arrangement. Right? So 3 elements which I talk about, which I claim, kind of are central to my account of the surviving acting together, I don't think because Leakey. Because Leakey is, I think, views herself as a kind of a neo-Aristotelian. So I know various people who just don't think that because Leakey is really an Aristotelian, because Aristotle's notion of hydromorphism requires a kind of an operation upon the parts to transform them into wholes, whereas so just having relations which hold or atoms which attempt to unify is not really an Aristotelian.
I might have time for one more quick question.
Yes, for Chris. So I spent ages since I've read Material Beings, but it seems like there's a fairly, if the reading that you're suggesting is right, there's like all kinds of interesting philosophical questions that immediately follow that aren't addressed in that book, and I'm curious as to like, he could have done himself some more favors by talking about stuff that immediately follows, like if the table exists but is uncomposed, and the drawer exists and is uncomposed and not part of the table because the table's uncomposed. I mean, that thing weighs like, I don't know, a kilo, and the table weighs maybe, I don't know how much, say 20 kilos. But the table isn't, the drawer isn't part of the table, and so like taking them together, do they weigh 21 kilos or not? And what's the relationship between all of this? And it's super puzzling. Like, why wasn't any of that discussed? I mean, I haven't read the chapter on artifacts recently, so I can't remember exactly what he says, but I thought he said that maybe this is just a misreading, but I thought he said they didn't exist. Yeah.
So let me just say what Van Inwerken would say, which is what he did say in that book.
Right, okay.
The fewer questions a philosopher is attempting to answer at once, the better. He tried to answer one. Now, there are more puzzles. He addresses quite a few of them in that book. But I'll just to address but doesn't he say, because he does say things that sound very much. One is the meta-semantic importance of the ontology room. So when he says things inside, right, that will mean, and in that book, he is using conventions where he says there are, he's saying, I'm talking subject to first order objectual plural quantification, right? So if you go out in the street and say, hey, Peter, do you want to go and get the tables and chairs and we'll walk up the mountain? Sure, oh, which mountain? That mountain. Oh, yeah, nice. He's a metaphysician on that matter. So there are other questions, of course. And let's talk about those.
Yeah, wrap it up there. So thanks for
there is a sandwich lunch waiting for us in the hood room upstairs, which I think William can lead us to along the corridor and then up the stairs.
I mean, especially if there's
get started. So for those who I had a chance to meet most everyone, my name is Father Thomas Davenport. It's a great joy to be here, and so I'm moderating this session. So I'm going to just briefly introduce both speakers and then give them ample time to share their thoughts with us. So first we have Professor Mark Harris, who is the Andreas Idrius, Professor of Science and Religion here at Oxford, who has a background in condensed matter physics, but now works in theology and the interaction between theology and physical sciences, and is working on a critical study on the theological reception of quantum mechanics. And afterwards, he'll be speaking to us about Arthur Peacock and his emergent theology and implications connected to condensed matter physics. Afterwards, we'll have Father Javier Sánchez, who's a senior faculty researcher at the University of Navarra, and his research includes philosophy of mind, philosophy of physics, and complex systems, and he directs the Science, Religion, and Faith group there at the University of Navarra. And he'll be speaking to us about, where'd it go? Oh, sorry. Thought I had it. Oh, there it is. No, that's not it. Here we are. Causal physical constraints, and epistemic defense of higher order causality. So, give it, Dr. Harris.
Thank you very much. So I always feel extremely self-conscious when speaking to an audience of largely philosophers, because I think my thoughts are always so very vague and loosely connected in comparison, and you'll see this in this talk. But I took the opportunity of this conference to explore some things that have been bothering me for a really long time. I'm talking decades, actually, which is about as a physicist with interests in theology, why is it that my particular discipline within physics is consistently overlooked in the science and religion field, whereas other branches of physics, and I'm thinking of cosmology, quantum physics, particle physics, get plenty of attention from theologians, but there's no interest that I can discern in my particular area of condensed matter physics, despite the fact that it's probably the biggest single physics discipline worldwide, at least in terms of numbers of researchers, and it does deal with middle-sized things. So, I think that's a pretty winning formula, personally, but my colleagues don't seem to think so. But, well, condensed matter physics is not unusual in this regard. Actually, if you look at the literature in science and religion, you'll find that most of the scientific landscape is totally ignored, including swathes of sciences that deal with middle-sized things. Now, so, questions of origins are clearly important to science and religion scholars, fundamentals, life and mind, but not everything else. So, I suppose I'm using this talk as a way of trying to explore, well, why might that be the case, and what might we do in order to construct a kind of theology of condensed matter physics that might actually draw some attention. I suspect that the reason why condensed matter physics doesn't draw a great deal of attention from theologians is to do with a kind of perceived lack of fundamentality of the area. And it's true that we do, as condensed matter physicists, have a bit of an image problem there compared with, well, particularly particle physics. We're told that our area is derivative, non-fundamental, applied science, and so on and so on. But preparing this talk has given me the opportunity to sort of think about some of the pushbacks, I suppose, and how they might be applied, thought through theologically. So, but I had to use Arthur Peacock to do so. But that's a good thing, actually, because it turns out that it's the 100th anniversary of his birth, and he is one of, if not the most illustrious directors of the Ian Ramsey Centre. So we're celebrating him anyway. So I was very glad to think in a bit more detail about particularly his interest in emergence and how condensed matter physics might help to kind of sharpen this up a little bit, particularly thinking through divine action, of which he is a very distinctive voice in. So let me just give you a little bit of detail about Arthur. There he is. He died in 2006, quite some time ago now, of course. So he's definitely in focus at the moment, and we certainly want to celebrate him and champion his achievements. One of the most important things to say about him is that he is one of the three big founding figures in science and religion, along with Ian Barber and John Colkinghorn. So I'm sure you've heard of these three figures. They've done more than anyone else to define what you might call the classical field of science and religion, and I don't mean in contrast to the quantum field, the classical kind of domain of the area. So things like methodology, critical realism, however you understand that, doctrine of creation and concepts of God, and of course divine action, are the kind of the core meat and drink of what we do, thanks to these three, and others as well, of course. And I shouldn't forget that George has contributed to this area too in his own way. Okay, career, there's some things from his CV, but I particularly want to highlight this book, Theology for a Scientific Age, which was published in 2 parts, which contains some of his Gifford lectures, and it's the closest thing he wrote to a systematic theology. So it's a really useful piece of work, and it's saturated with talk of complexity and emergence. So it's really good for thinking through condensed matter physics, I think. And I'm particularly interested in the way that, in this book, Peacock views the relationship between all of the sciences, and the way he analogizes this with the human person. But first of all, I think it's quite interesting to see how he views theology. So he has a very high view of the truth value of science in conversation with theology. So theology must take urgent account of the sciences. And here's a quotation from one of his pamphlets in the Farmington series. Those of Christian and theist persuasion who take no account of the scientific picture of the world are forfeiting the future viability of their beliefs. They are digging themselves into a deeper and deeper hole, and as they go down, they'll be able to talk more and more to themselves, less and less to other thinking people. For, in God's good time, truth must prevail. That is a strong statement. I'm sure you would agree with me. He's not against theological tradition per se, but when theology tends to kind of cling on to, in the face of perhaps evidence, cling on to pre-scientific images, then it's science which owns the truth. Seems to be the gist of what Arthur was saying. So theology must be ready to revise its language and ideas, like scientific models, in other words, we should be ready to revise them and reject them. Theology is provisional, like science, should learn from the scientific method. That seems to be the gist of how Arthur thought about theology. Quite a distinctive view, I should say, in the science and religion world, because probably most of us are more, I don't know, a little bit more traditionally minded. You may think differently when you've heard me talk a bit more, but Arthur, I think, is probably on the sort of, fairly progressive end of things. But, his point is, and he develops it elsewhere as well, that God is a proposition to be tested by experience, human experience. So theologians should test their models of God in the same way that scientists appraise scientific models by assessing fit with data, their internal coherence and fruitfulness. This is how he explains it. So, for instance, in order to make sense of evolutionary biology, he makes a very strong emphasis on divine immanence, the Creator's very close presence with the creatures. And in fact, he goes as far as to say, if you want to see God's action in the world, look at what the evolutionary biologists are doing. That is divine action. Science reveals God's work establishes science. So he's a very, very high view, if you like, theological view of the sciences. It's also important to Peacock that the arena of God's work, creation, is layered. And this is what he calls his hierarchies of complexity. It's a reasonably familiar idea. A few people have mentioned the kind of idea already. I mean, it's very hard to talk about reductionism and emergence without using the idea of sort of spatial up-down layers and so on, levels. Peacock, though, has his own take on it. So each level in the hierarchy is a whole that must be dealt with on its own terms, but relates to the others in emergent terms. And this is what he says from his Theology for Scientific Age. We have no basis for any favoured attribution of reality to the different levels in the hierarchy of complexity. Knowledge of each level, or perhaps better, along each vector of inquiry, he uses scare quotes a lot, has to be regarded as a kind of slice through the totality of reality. So each level effectively is almost self-contained. Each level is a slice through the totality of the cosmos. So clearly his levels aren't going to work spatially, with kind of fundamental particles down here and then atoms and so on building up. It's not like that at all. Instead, his layers are structured in terms of the way you might want to kind of carve up the human person conceptually. And I will sort of try and explain this. So he has 4 layers, and he sees the human being as a macrocosm of the cosmos. So at the bottom is the physical basis, and this isn't just physics, it's chemistry, geology, all the way out to cosmology. So that's layer 1. Layer 2, human beings as living organisms, largely the life sciences, but also neuroscience. Level 3, human behaviour, so psychology, cognitive science, and so on. Level 4, human culture, and this also includes the sciences as cultural phenomena. And interestingly, he has a philosophy question mark here, but also the humanities. And I've simplified massively. Here's the complete scheme, and you probably can't read that, I'm afraid. Sorry about that. It's pretty complicated. Philosophy is up there with a question mark. You ask, well, where is theology on there? It isn't anywhere. Now, isn't that interesting? I suspect it's because actually the whole thing is theology to Arthur. Unfortunately, he's dead, so I can't ask him. But I suspect that that's what's going on here. Now, we might ask, okay, because he sees all of this to be the arena of divine action. There's no bit that's more favoured than any other. No particular mechanism through which God does stuff. So, where is the point of contact of the supernatural with the natural? Might we talk about a causal joint as colleagues of Arthur's, such as John Polkinghorne, would have done? Well, he resists this kind of thinking. There's no one level in his thinking that is particularly preferred by God in order to act in the world. One way of thinking about it is perhaps that God works on all levels simultaneously, synchronically, and he certainly has a strong emphasis on top-down action, strong emergence, but he doesn't actually think of this as an action like at the top of the layers percolating down, sort of all things at once. And he uses a proliferation of terms. They're quite peculiar when you come across them, but he's trying to avoid saying things like universe or cosmos, because that's, I suppose, the language of cosmology, perhaps. He's trying not to favour any one particular scientific description over another. He uses terms like, I think this is on my next slide, system as a whole, the world as a whole, total world system, system of systems. This is how God sees the world. And in fact, he sees this system as a whole as a constraint which influences every layer. And I'm going to quote what I think is probably his most important passage on this kind of idea about how does God work in all of this. So please bear with me, I'll need to read this through carefully. And it's typically Peacockian in terms of really quite dense and intricate language. And scare quotes as well. In the light of these features of the natural world, he's been talking about emergence and complexity, might we not properly regard the world as a whole as a total system so that its general state can be a top-down causative factor in or constraint upon what goes on at the myriad levels that comprise it? I suggest that these new perceptions of the way in which causality actually operates in our hierarchically complex world provides a new resource for thinking about how God could interact with that world. For it points to a way in which we could think of divine action making a difference in the world, yet not in any way contrary to those regularities and laws operative within the observed universe, which are explicated by the sciences applicable to the level of complexity and organisation in question. So he is not an interventionist. He doesn't believe in interventionist divine action. God effectively works through the sciences and the humanities as well. He goes on to say, I'm afraid it goes over the page, it also provides an appropriate and helpful model of how natural events, including the unpredictable ones and the outcome of freely willed human decisions, could work their way up through the hierarchy of systems and contribute to the state of the whole. That sounds like a kind of reductionist seeing sort of things percolating upwards from the fundamental particles, doesn't it? But remember, he doesn't see the levels as working like that. It therefore helps us to model more convincingly that interaction, dialogue even, between human decisions and actions on the one hand and divine intentions and purposes on the other. It's in such a context But the significance of prayer, worship, and the sacraments are rooted. Attempts to hold together the notions of God's transcendence over the world, his ultimate otherness, with that of his immanent presence in, with, and under the world, often find it helpful to deploy models of the world as being, in some sense, in God, but of God being more than the world, and so as the circumambient reality in which the world persists and exists, panentheism. Okay, so this is one of his famous convictions. He's a panentheist. I think one of the questions that many of us have always had, well, how is your panentheism different to my theism? But this is a different conversation. Nevertheless, he maintains that he is a panentheist. The world is in God, every level of reality is in God, every natural process, whether it's working up or down, the hierarchy of layers exists in God. God exists a constraint on the whole, contains it, because it's all in God. Or, as he says elsewhere, in a very pithy summary of this, God is the ultimate boundary condition of all that is. And a related term that he often uses is to speak of God as the whole part constraint on all causal processes in the world. It's not as though we could look at one cause in the world and say, yeah, that one's definitely divine, that one isn't. But they all are, because God exercises a constraint on all of the parts. They're all integrated into a unitive whole. And he explains this by using the analogy of the human mind making a decision and acting in a top-down manner on the body. Now, he's not a dualist. He's thinking as a kind of physicalist in terms of philosophy of mind. So, this is the age-old model, I suppose, of God working on the world as rather like brain or mind or soul working on the body. But he's a little bit, he's not, like I said, he's not a dualist. Given his interest in seeing the whole world as a series of interlocking systems, I thought I could describe or suggest some different analogies rather than just, mind-to-body connection. So I think that the way he describes things, one possible analogy is that God's action on the world is like plate tectonics is to an individual volcanic eruption, or God is like the evolutionary tree to the life of a single organism. Or God is like the statistical mechanics description of a gas, where the behaviour of an individual gas molecule appears random, but statistically there are macroscopic quantities that can be measured. Now, there are critical questions that can be and has been raised about Peacock's scheme of divine action. Does he successfully avoid pantheism in this scheme, for instance, something that's often asked? And is his model preferable to the kind of standard issue reductionist model that often gets cited, which is quantum mechanical, non-interventionist objective divine action of Bob Russell? Well, those aren't questions I'm going to go into, but I think that his model does at least take emergence and complexity seriously, and, the thing I particularly value, he takes the diversity of the modern scientific landscape very seriously as well. He's saying it's not all just quantum mechanics, or it's not all just cosmology, or something like that. The parts are all integrated, including all the scientific parts and all the scientific disciplines. They're all integrated into the being of God. And so with that kind of celebration of what he did, I want to move on to some very loose and random thoughts about condensed matter physics. Oh, too far. Okay, so first of all, what is condensed matter physics? I am often asked this question, surprisingly. It seems to be obvious what particle physics and cosmology is, but people just don't seem to know what condensed matter is. And I guess it's because, well, actually the clue is not in the name. So, for sure, we look at things that have condensed. They're not gases or plasmas. We look at liquids and crystals. But what we're really interested in are what this condensation means for the physics. Because what we find is that now the constituent particles of these condensed things are highly dependent on each other and on the whole. We find completely new properties, structures and dynamics emerging. And for that reason, condensed matter physics is often referred to as many-bodied physics. Again, clue is probably not quite in the name, but hopefully you get the gist. Now, you're probably also aware that this field does have a pretty heavy-duty kind of technological side as well. And we've probably all got in our pockets something one pocket, something that relies on condensed matter physics for working. There are countless devices in our modern world that benefited from the research that goes on in condensed matter. And of course it shares a lot in common with chemistry, mineralogy, biophysics, material science, engineering, etc., etc., etc. And it values interdisciplinarity highly. All of these sciences have very clear interest in middle-sized things. As such, condensed matter physics addresses really everyday kind of questions, the sort of things you might have asked as a child. Why is iron magnetic? What is magnetism? And why is stainless steel, why is this knife and fork not magnetic if it's made of the same stuff? Why does graphite conduct electricity? Diamond doesn't. It's all carbon, surely. What's glass? Is it a solid or just a liquid that's sort of stopped flowing for some reason? Those are the sorts of questions we try to answer. There are endless novelties in condensed matter physics, and many of them are apparent at our middle-sized level. But a question also arises about the status of our science compared with other areas of physics. Is it just all about random collection of middle-sized problems, not really joined up by any principles, or does it have some actual fundamental principles? Well, a dispute there's a long-running dispute between quite a number of high-profile particle physicists and high-profile condensed matter physicists about this. We're often told that our field is, for instance, well, really just dirty physics or squalid state physics. Oh, brilliant. I made me very nervous there. So I was given a 5-minute warning. Oh my word. Yeah. Okay. So where was I?
Dirty physics.
Yeah, dirty physics. That is, in fact, Wolfgang Pauli called condensed matter. Well, it was the kind of emergent version of condensed matter called the dirty physics. It's sometimes also called squalid state physics as well, and solid state physics. So, is what we do actually fundamental? It's a question that constantly is asked of our field. Now, as you expect, those of us who work in condensed matter physics generally tend to think, yes, we do fundamental research, but we have to justify it to ourselves as well. Most of us are emergentists in one shape or form. If you ask us, are you a strong or a weak emergentist, I'll probably say, I don't know. But I like to use the language of emergence. It does make a lot of sense for what I do. I'll say a little bit more as we go along. But I guess that our conviction is that even if it turns out that one day particle physicists might be able to calculate all of the properties of condensed matter from subatomic principles, the human race would be deeply impoverished if they could do that. That's our conviction. Because quite simply, condensed matter physics provides some beautifully intuitive explanations by working at higher levels, closer to our own middle-sized reality, and that they provide real understanding. And I wonder whether this argument about fundamentality, at least from my perspective, actually is a sort of an aesthetic thing about which kind of explanations do I prefer. You may want to debate that with me, philosophers, but that's how it feels to me. And I'm going to give you our best known example. Superfluidity and superconductivity. George has already mentioned this a couple of times. Particularly the BCS, Bardeen-Cooper-Schrieffer model of superconductivity. This is a macroscopic quantum effect. You see the effects on this scale, our scale. So it's caused by electrons pairing up as they surf waves in the lattice and then flowing with zero resistance. And I think that provides a beautifully intuitive picture of what's going on. And I would say that it's inconceivable that a gigantic calculation from the bottom level up, from the quarks and the gluons, could achieve the same kind of heuristic success that provides. So all that such a bottom-up calculation would give us, even if it were possible, which it isn't at the moment at least, is what really amounts to some kind of phenomenological description of, well, what we see. It wouldn't give us, I maintain, an intuitive understanding of the process that we could grasp in human middle-sized ways. So I think what I'm trying to say here is an explanation like this, and there are many others in my field, give us, I mean, this one in particular, this is one of the most celebrated heuristic insights in 20th century physics, which was applied way beyond condensed matter. It's such a beautiful model. So, the microphysics might one day be able to describe all of this, but would it help us to understand it? I'm not sure. I don't think so, personally. It's almost as though emergent explanations like this have a kind of an aesthetic element which we particularly, as condensed matter people anyway, value. Well, it's taken quite a while for the field of condensed matter physics to develop any degree of self-confidence about this. Again, this guy has been mentioned a few times, Phil Anderson. He's really I suppose if anyone is, he is the most important architect of condensed matter physics in the 20th century. He's probably the one who did more than anyone else to define and explain the shape of our disciplines. And his thought on this largely took place in debate with some of the leading particle physicists of the time who were saying, your field is not fundamental. And particularly in his famous paper, More is Different, he sets out the reasons why what we do is fundamental. And here is the famous quotation that appears towards the start of his paper. He explains that, okay, so you might be able to reduce everything down to subatomic particles. Try constructing it back up again. That's a different matter. And he says, the main fallacy in this kind of thinking, reductionism, is that the reductionist hypothesis does not by any means imply a constructionist one. The ability to reduce everything to simple fundamental laws does not imply the ability to start with those laws and reconstruct the universe. In fact, the more the elementary particle physicists tell us about the nature of the fundamental laws, the less relevance they seem to have to the very real problems of the rest of science, much less to those of society. Instead, at each level of complexity, entirely new properties appear, and the understanding of the new behaviours requires research, which I think is as fundamental in its nature as any other. Okay, is as fundamental as any other. And he goes on, and the kind of what I think is the kind of genius point here is he realises that he has to develop some kind of fundamental principles for the field to bind it together and give it some kind of reason why he thinks it's so significant in relation to other areas of physics. And he comes up with two fundamental principles. The first is broken symmetry. We've mentioned that one already. The second being what he variously refers to this as adiabatic continuity or model building or renormalization, related to what we often refer to these days as coarse graining. Now, these are certainly methodological principles, but you might want to ask, do these have any kind of ontological clout? Really good question. Anderson seems to be a little bit unsure on this question himself, so I think the two is certainly methodology. Number one, though, he uses this in so many different examples of broken symmetry in nature, in all kinds of sciences you can imagine, that he seems to have a conviction that it really is reflecting a basic property of nature, that symmetry just breaks again and again and again, and we see new properties in every science you can imagine. And I might run out of time, but I'll give you a great quote of his, where he tries to explain broken symmetry. I really like this one because, of course, it goes back to the history of philosophy. Matter at sufficiently high temperatures is in the gaseous state, and at even higher temperatures, the molecules dissociate and the atoms ionize. But cold matter is a different case, as Dr. Johnson forcefully demonstrated in his famous response to Bishop Berkeley. When you kick a stone, no doubt remains in your mind that it possesses a property that we call rigidity, which we recognize as the very epitome of broken translational invariance. Not only does it occupy a fixed position in space, but translational symmetry is broken everywhere within it, in that the individual atoms all occupy fixed positions. So, even to recognize basic middle-sized things like stones is actually to start speaking of broken symmetries. And there are many more than just the existence of stones. They are very subtle. They are everywhere. He's significant in the history of emergentism, therefore, in finding a kind of a concrete physical principle, if you like, for talking about emergence. And he, over the years of his writing, he ramps this up to the extent that he calls it the God principle. So I'll just quickly read this. The world in which we actually live is the consequence primarily, or only, not of some incredibly simple but hidden God equation, or God particle, you can see who he has in mind here, but of the God principle of emergence at every level. Now, I really am about to run out of time, so I'm going to get to the very last slide and say, what on earth does all this mean theologically? Well, this is where I have only really just started to think, and probably not with any clarity. What I want to do, I suppose, with this thought is think more about the way that Anderson views science, very differently from Peacock, incidentally, with his layers. Anderson's view is like a web, where research programs are connected in these very intricate ways, which support each other, interrogate each other, and learn from each other. I think that's a really interesting model for the unity of science, and it particularly has theological implications for how you might build a theology of nature and theology of the sciences as science. So I want to certainly look through that. Arthur Peacock's conviction that divine action underpins all the sciences and humanities is also very interesting, particularly when you start to apply it back to Anderson's way of thinking, and then apply Anderson back to Peacock and say, well, Peacock, how were your different levels related? Well, surely we must be speaking of broken symmetry between them all here. So I think there's quite a lot of cross-fertilisation between these two thinkers that I can do, which I'm hoping to do if I write a paper on this. You may convince me I shouldn't very shortly. And the final thing is something that has bubbled up from time to time in our conversation about diachronic and synchronic emergence, which Peacock was not clear on, Anderson is much sharper on. So I'll stop there. Thank you.
Do you want to see your presentation as well, or is it enough to click?
Yeah, if you can put this here.
That's really correct 5 in the morning. Not a premature 5 in the morning.
So thanks a lot for having me here and for this terrific conference. So this work has been done in collaboration with Miguel García Valdecasas, who's a Spanish philosopher, now he's in Berkeley. And so we're interested in somehow philosophy of biology and constraints, as you will see in a moment. So a disclaimer, I've been highly recommended by William to say something about theology, since this is a session on theology. I think I'm going to say very, very little things about theology, but I think that there will be some room for it, and maybe in the Q&A we can discuss some things, and also, thanks to the presentation of Mark, I think that there will be room for that. So let me start with constraints. I will give a definition of constraints. Let's say that they are entities, things, processes that reduce the variability of a system. Now, this is a typical example, so it usually appears quite often in the examples of biology. It's Bénard cells that form when a liquid is overheated, when we have some temperature gradient in a liquid, and then we have a phase transition from conduction to convection, and we obtain these hexagonal, polygonal in general structures that show that there's less availability of degrees of freedom for the molecules because they have to follow these particular paths. And this is very typical of dissipative systems, or this happens in far from equilibrium systems in reality. So constraints are very much used in the philosophy of biology. For instance, in activism, I don't know whether you've heard about activism, it's philosophy of biology that tries to understand the emergence of and the behavior of living systems, and they usually speak about constraints as driving or guiding the microphysics that is behind the behavior of the living system. So we have to think about enzymes that are configuring the reactions that take place within the organism, and they usually enhance the time that is required for the chemical reaction to take place, otherwise the chemical reaction would take like the age of the universe or whatever to take place. So there's this combination with constraints somehow guiding or organizing or driving the physical or the chemical reactions, and then of course the microphysics that is always below at the bottom level. Now in philosophy of science, so we have in the last years we have this view of Max Planck, who has mainly focused on the explanatory role of constraints, and he focuses on constraints in mathematics, and he claims that there are explanations in science that are not causal. And one of these examples are constraints in mathematics. So when we have a constraint in mathematics to solve some mathematical problem or some, we want to access some mathematical new dimension, usually we claim that there is some constraint because there is a necessity relation that explains why some configuration is realized and other different configuration doesn't happen, or it's not possible because of some necessity relation. And the question is, Lang says that this kind of explanation, these mathematical constraints, of course, wouldn't be causal because there is no information about the causal history of what's going on there. Just to give you an example, if you remember the difference that Einstein made between principled and dynamical theories, think about the constancy of the speed of light. So the speed of light is constant in the universe, and it does mean that the geometry of the space-time required for having that constraint is Minkowski space, and that tells you that the possible transformation between inertial frames are Lorentz transformation. So it gives you a constraint of what's possible and what is not possible, but nobody would say that C is causal in the specific dynamics that's taking place in I don't know, in a star or in some experiment. So C would be, the speed of light would be an example of an explanation that is not causal, or constraint that is not causal. And well, we could think that if this is the case, and if constraints as mathematical constraints in general doesn't have causal power, then we would have a problem with, these middle-sized things that are composed at least partly by constraints, because if we embrace the idiotic principle, was mentioned yesterday by Daniel over there, so it seems that these things doesn't exist because the idiotic principle says that being has to do with having causal power. Okay, so that's the question. Does middle size exist if they are just explanations, but non-causal explanations? Of course, in the history of science, at least in the 20th century, there's been controversy regarding the relevance of the notion of causality for science. Of course, in the scientific field, we have Ernst Mach, who said that physics is reluctant or resistant to causal motions, and Bertrand Russell, in a more philosophical view, he claims that with differential equations, we do not need to refer to causality. So the notion of cause and effect somehow are irrelevant for the explanations offered by differential equations. So I would call this view full eliminativism, in the sense that it eliminates the notion of cause and effect from science, from scientific explanations. A less radical stance would be what I would call, I will try to debunk this view of higher level causal eliminativism, HLCE. And I will read this definition just to be very specific about what we understand by this HLCE. So when do we have HLCE? When the causal relationship between two events, P and Q, can be fully explained by or accounted for microphysical interactions and the inherent properties of microphysical entities involved in those interactions. So I think it's quite similar to what you may have in mind regarding reductionism or fundamentalism or whatever. So there are various comments I would like to make here. The first one is that there seems to be a fear when HLCE defenders speak about this, is that if we invoke causal principles at different scales in the universe, in nature, so there could be some interference with the microphysical interactions, and so the causal closure of physics could be jeopardized because we could run the risk of overdetermination. So it seems that even not necessarily, but HLCE defenders seem to be inclined to lean towards the idea that physical constraints usually happen at mesoscopic levels or middle-sized levels are not causal because of this reason, because of this view of what is causality only can occur at a very basic level. Now, of course, all this discussion also depends on the view about causality that you may have. There's been a pluralistic view of causality in many important authors in the 20th century. I only mentioned here some of them. And, well, I guess that most of them, I will speak more about them in a while, but most of them wouldn't admit this problem with the causal closure of physics, or would say that we must understand causality in a broader perspective, so we don't need to identify causality with physical interaction or efficient causality or whatever. But let me put the problem that I want to address can be expressed through this dilemma, at least if we admit the causal closure of physics and the HLCE, the higher level causal eliminabilism. So the dilemma could be presented in this way. So if, oh sorry, I need some help. The problem is that if constraints are physical or part of a physical system somehow, so it seems that the causality of constraints should be no different, shouldn't be different from the causality of microphysical interactions. So that's physical causality. But on the other hand, if constraints are non-physical, so there's mathematical alike, or the way that mathematical constraints explain things, they cannot be causal. So what can we do with this? It seems that the HLC at least presents us with this dilemma. Now, in the recent literature, we can find different attempts to find a way out of this problem. The most recent one, at least as far as I know, is given by Siegel and Kraber. They come from the mechanistic philosophy or point of view, and they make this interesting distinction between phenomenological explanation, between etiological and constitutive explanations. Okay, so they admit that we may have at middle-sized level, we could have some etiological explanations, but these etiological explanations need not be constitutive. So they need not refer to the underlying physical mechanism that, for the phenomenon that one wishes to explain. Typical example would be the equation for the ideal gas. Pressure times volume equals number of mass, moles, whatever it is, constant R, and temperature. So one could say that, okay, this is pressure and temperature could be considered causal. Yes, in an etiological sense, it's an etiological explanation, but they are not fundamental because they are not constitutive. So they need, so if we follow the history of all the causal interactions, we could see that when, for instance, if you reduce the volume, then there is more room for the clash between particles, and then that's why temperature increases. So we could select with the past life cone of the phenomenon, we could select some part of the causal explanation and say that, okay, we call this pressure, we call this temperature, whatever, but this is etiological but not constitutive. In a sense, this etiological explanation but not constitutive is derivative. Okay, so there's a deeper explanation for this etiological explanation that it's quite often used in science, condensed matter or many other branches of physics or science. So this is a possible way out. Another possible way out would be being more, how to call it, libertine regarding constraints. And Lauren Ross recently also came up with the view that, well, maybe we have many different types of constraints in nature. She speaks about law-based or empirical laws, some types of constraints, of course mathematical constraints, but we also have causal constraints. Some of them are causal, and she described these features for the causal constraints. She says they are limiting in the sense that constraints make this distinction between system and environment. It's one of the most difficult notions for me, in my opinion, of how we individuate the system, why we do that. So constraints help us to limit what is the system, what's the environment. They are external because usually they are put by the environment. They are not built by the system itself, although this is controversial in the case of living systems. Living systems seems to create their own constraints and boundaries. She says that they are relatively fixed in the sense that so they last more than the dynamics that is going on in the system. I would, in scientific terms, I would say that we are here applying the adiabatic approximation. So we think that the time of change for constraints is much longer than the typical time for interactions at the lower level, at the microphysical level. And very importantly, she says that they are not triggering in the sense that they are not efficient. So they do not work in the sense of exchange of energy, but only as limiting the possibilities for the trajectories, for the dynamical possibilities of the bottom physics that's working, doing the work or doing the efficient causation. And of course, we could say that they are causal because we could manipulate them in some sense. The problem with this explanation, in my opinion, is that it's only a description of possibilities, but somehow it begs the question because it describes, but it doesn't explain why some of these are really causal. So why other constraints, law-based or mathematical constraints, could not fulfill these features, or perhaps whether they really exist in nature or not, whether this classification is meaningful or not. So we need to go deeper in order to defend the causal role of constraints. The third way out in the literature that I would like to comment on is given by Jemima Ben-Haan. I think she's an expert in quantum mechanics, foundation of quantum mechanics. And so I think this diagram explains quite well what she thinks. So she maintains two different types of causality of constraints in the upper level and causality of the physical system, the lower level, the microphysical causality. But so somehow I remember what you told us about the proportionality. So this is inspired somehow in the criterion of proportionality. So constraint C2 is caused by constraint C1, and in the lower level we have this causality. And how the question, we cannot cross over these levels, because from P1 to C1 we have supervenience, and also from P2 and the different instantiation of every constraint is always supervenience. Constraints are supervenience. The upper level is supervenience on the lower level. But there is no causality here. The problem with this, in my view, is that, of course, we do not discuss causality in supervenience. As far as I know, this is unknown to me, how supervening can be understood in terms of causality. It's not discussed. And another question that one could present here is whether actually C1, a constraint C1, is fundamentally different from its different instantiations, P1, P1 prime, P1, 2 prime. So in what sense this constraint is really different from its physical instantiation? So I would like, in the rest of my talk, I would like to follow a different path, and I would like to focus on different understanding of causation, at least for what I'm going to defend, and it's the idea of selection. So selection could give us a hint on what sort of causation is also playing a role in the universe, in nature. I would like to start with this very simple definition of selection, and imagine a set, so I could select some subset in this set. So we could say that selection, very formally, is a pair where I have the domain of definition, so the initial set, and then I have some rule, some S process that make a choice for the different elements of the set. Then we could choose the right elements, or we could choose the elements that have some peak, or we could choose the elements that have less than 4 sides in their form. So let me comment on this question of selection. If you see in the definition I've just given, so it's not a mapping. It's not a mapping because omega is not well defined. We don't have a set of all sets of the universe. So it depends very much on the initial set, and of course it depends on the rule of selection. So there is no general rule of selection in the universe for a set. Incidentally, mathematics, to construct mathematics, we need, as far as I know, to include the axiom of selection. Otherwise, mathematics gets into trouble with strange results and consequences. So it seems that selection is something that, well, let me put it in this way. So there are many different possibilities of selection, but at least we could consider 2 different types of selection. The first one, I would call it ontological, in the sense that it's something that occurs in nature, and it is this selection of microphysical states. For instance, if you think about the Bernard cells, there's selection of the microphysical states when we have this transition from conduction to convection regime. So not all microphysical possibilities are available because of this phase transition, so there seems to be a selection of microphysical states. But there is also a different process of selection that I would call epistemic, this S2 rule, and it has to do what we as scientists do in models. So we see that we have differential equations. Usually differential equations have many solutions, and we need to introduce boundary conditions, initial conditions, or whatever value for the parameters that give us the right solution. So I would say that there is a link in nature and in scientific activity between these 2 types of selection, a link between the S1 and S2. So I would say that our choice of boundary conditions depend on this occurrence of S1 processes in nature. So I would say that this S2 rule depends ontologically on this selection in nature of microphysical processes. And on the other hand, it is true that this S1, the knowledge of this S1 processes depends, in our equations we can recover it because we may choose these specific boundary conditions. We have this S2 epistemic priority. So I remember, I think yesterday someone mentioned the question of epistemic priority doesn't mean ontological priority, and it is true, but there's a subtle connection between these 2 processes of selection. So one of them ontological, the other one epistemic, and well, they somehow reinforce each other, at least in scientific activity. So let me tell you a paradigmatic example of all what I'm saying is thermodynamics. I like this picture, probably most well-known law of thermodynamics, the second law, that the entropy of an isolated system is not decreasing. I think we can apply that to the universe. And this is a beautiful picture by Roger Penrose in The Road to Reality. This would be the phase space for the universe. And so it's partitioned with the macrostates. Macrostates are defined because, well, it's a good point, how I define macrostates. I'll go to that in a moment. The question is entropy or the second law just a matter of statistics? Now the question is, if it is just a matter of statistics, it would seem that the most likely possibility is that so every state of the universe is represented by a point here, that we would be always in the biggest macrostate, so the macrostate of equilibrium. But that is not the case. Actually, we are in a situation of intermediate entropy, and one could say, okay, well, once time evolves and dynamical laws apply, so it's more likely that we go from a state of low entropy to a state of bigger entropy, just for statistics, so it's more likely to end up in some of these big macrostates. The question is, Penrose explains that if it were just a case of statistics, since fundamental laws of physics have this time symmetry, well, in the past we should come from another place of very, very bigger entropy than the state in which we are now. But this is not the case. So if the second law applies, as we know that it applies for the time being, so the only possibility is that actually we are coming, so the Big Bang or the initial state of the universe is a state with an extremely tiny low entropy. And there is a famous estimate by Penrose with taking into account the entropy of black holes and so on and so forth, and how little is this entropy is like 1 part compared to 10 to the power of 10 to the power of 123. Beware, it's not 1 followed by 123 zeros, but it's 1 followed by 10 to the power of 123 zeros. You simply cannot write down that number. It's beyond the length of the universe. So this is really remarkable. So what's going on? So it's probably Penrose says this is the biggest problem of cosmology. So this small number. Now the question is, okay. So there seems to be in the second law, so this tendency towards states of bigger entropy. So it seems that it has an influence. So entropy is something real, is something that is having some causal effect in the evolution of the universe. 5 minutes, okay. Now, for HLCE, is there any way out? Well, I think there is. HLC could strike back saying that, okay, we could invoke the past hypothesis. The past hypothesis is only saying that, okay, the universe starts at a tiny, tiny entropy, and that's the way it is. And then if you just let whatever evolution is possible, then for a matter of statistics, then you would obtain the second law. But the second law is sustained by this tiny, tiny entropy at the very beginning. And then all the external conditions, all the boundary conditions, all the reference to thermodynamic quantities, constraints, and whatever, are simplified statistical effects of this past hypothesis, of this initial state of the universe. And if that were true, of course we would have a problem with the causality of constraints, with the causality of thermodynamics. So we would be only having a different description, so mathematical description, statistical description, something that actually doesn't have a S1 process behind. So the problem is that S1 and S2 processes, the link between them is severed. So this is a philosophical position. What would be the physical theory behind this HLCE? Well, as far as I can imagine, the only possibility would be to invoke superdeterminism. Now, I don't think that I can explain superdeterminism in 3 minutes, but the question, if you know something about quantum mechanics and Bell inequalities, the only possible explanation of the violation of Bell inequalities that is compatible with determinism is superdeterminism. So you need to have no local hidden variables, and the value of these no local hidden variables at some space-like slice of space-time, plus the fundamental physical laws, would determine the universe towards the past and towards the future. So the question is, we would have a physical theory in which we could claim that these S2 procedures are only implemented because of practical reasons. Okay, so there is no S1 process behind, because it's just a matter of coarse graining or statistical effects because of our way of knowledge. Now, let me just show the problems that this position has. Okay, the problem is who or what selects the value of the non-local variables at some slice of space-time. Why is that value selected? Because we need it to solve the differential equation. Think about superstring theory. You need differential equations. You need to invoke some boundary condition for that. But remember, the S1, S2 link is severed. So what selects that? Why do I need to choose that? I think there's only a desperate movement, and the desperate movement is saying observations. So in ultimate term, is the observation of humanity that makes that the universe is collapsed into a universe that is compatible with us. That's the solution, by the way, that is presented in one of the last books of Stephen Hawking, grand theory. So the idea is that observation of the human mind collapses the universe into the only possible history that's compatible with the existence of human beings. But I think this is problematic, because since we cannot observe hidden variables by definition, we still need additional rules for this mapping of non-local hidden variables to our observations. So these additional rules, why do they come up? And just almost closing, I think that superdeterminism has also some other problems. We have this problem with epistemic selection, since we have severed the link with the ontological selection S1. We have some arbitrariness, because observation shouldn't be the last reason for the evolution of the whole universe. But I think there are also these 3 problems. I cannot dwell into them, but it's a problem of identity and difference. So since we are approaching a sort of neo-Humean position, so with non-local hidden variables, we would only have different configuration in space-time of things, but we do not have a real theory of identity and difference in nature. Of course, somehow this is unfalsifiable, because we could always say that the initial conditions of the Big Bang are those that permit to have the universe that we have. And even more dangerous, in my view, would be that time becomes something illusory. So we would be living in a sort of block universe, because past and future are at the same time determined by these non-local hidden variables and the fundamental physical laws. So let me conclude with this idea. So I think what I've tried to tell you is that if one takes seriously this higher level course of eliminativism, then you need to embrace as a physical theory superdeterminism. I think there is no way out. And the reason why this happens is because HLCE somehow is an unstable position. So they wish to build this idea of, well, causal eliminativism, but keep this fundamental causation at microphysical level. But, well, how could we say that constraints somehow are important or causal? Well, these 2 views somehow are competing with each other and make that this HLC is unstable. And a final recommendation would be, well, I think that it's much better grounded this two-dimensional view of causality, because this problem of selection, how we select things in differential equations, is somehow distributed along different scales in the space-time. So that seems a better alternative, and well, this could open up the discussion about the divine action. So divine action is more appropriate in a super-deterministic universe, or a universe of plural two-dimensional view of causality. So if, as I think you understand that I defend this pluralistic view of causality, if that's true, of course middle size matters, and maybe it could show us something about how God acts in the universe, this problem of divine action. So I stop here, thank you for your attention.
So, thank you so much, Dr. Harris and Father Javier for your talks. So I will briefly try to offer a couple of sort of thoughts or questions. These sorts of interdisciplinary things, this one in particular, it's always a great joy. So it's one, as many people thank the organizer for all the work here. But I think it's particularly great. I find it particularly useful because it reminds me of the academic silos I find myself in different modes, and sort of forcing myself out of that. And so it's good to be pushed on those edges, and in some sense, both as a theoretical particle physicist by training, and as a Thomist, I've been pushed in two different directions by Dr. Harris's talk. Although I'm a weird Thomist and a weird particle physicist, I'm actually extremely sympathetic to what he's trying to do, and there's a funny way in which I think there's almost as if the directionality that Peacock is, the effort that Peacock is aiming for, and perhaps something about what you're aiming for, doesn't go far enough for me. So first, what I want to say is that I do think it's hugely important to think about the aspect of condensed matter physics and higher levels. So just in the broad conversation on science and religion, it's not surprising that the kind of controversial or weird questions draw the most attention, perhaps. So issues around evolution, issues around the Big Bang and the notion of creation, issues around quantum mechanics. But there are so many just fundamental questions that in some sense are in the background, but if there's not a kind of compelling sense of how a theist should understand God's relationship to every aspect of the natural world, not just these weird situations, that can be problematic. So I'm very sympathetic to both the general desire of condensed matter physicists to be taken seriously as doing fundamental physics, but also the role that might have in broader conversations on science and religion. I guess the question I have, and I think it was helpful, like the way you presented Peacock's presentation, is I realized in one sense my initial reading of him, and perhaps kind of too quick reading of it, was that he was too constrained in his vision of God, in the sense of, there's a quick version of thinking about, if you have the mind-body connection, well, like I don't know what my quirks are doing. So in what sense is, if God is like the mind to a body, in what sense is God actually engaging with every single layer? But insofar as you lean more heavily into the idea of God's activity at all of these equally important and fundamental layers, there's something more going on there. But I think I bristle a little bit at the notion of God as the boundary condition, because I feel like that still leaves him outside. And I think this is where the kind of, perhaps showing the more Thomistic cards on this, that I want to think much more about a more immediate sense of omnipresence. That God is so that not that everything is, not panentheism, that the world is in God, but that God is immediately present to every aspect of the world, in a sense that is really causal, and yet not a different mode of causality than nature. So that there's a kind of proper causality to the natural things, and yet God is holding them in being, allowing them to act, and making them able to act. Now, that leads into all sorts of questions about and much debates about God's omniscience and free will and issues around the fundamental aspects of nature. but I do think there's, I wonder if the effort to get away from a kind of bottom-up picture of God's causality, where all that God is doing is working at the like monkeying around with quantum mechanics, and it works out in the end. I find that dissatisfying as well. So the desire of Peacock to say that no, God has more direct engagement at other layers, that God is not just working in me through my quirks, but working at every layer of my being. But I think insofar as we sort of focus as God as the boundary condition, we kind of run into the question, the difficulty with Javier, of like, so is God just another physical cause? If God is just a boundary condition on the way in which the physical world works, what is the difference between God's causality and the kind of causality in nature? I think this is a general Thomistic approach and certain kind of classical theistic argument that we need to avoid ideas of there being a kind of competition between God's activity and nature and nature's own proper activity. Setting aside questions of special divine action, that God is present and is acting in the world through the very natural things that we see. So there are, in some sense, sort of small-scale resonances with some of the things that Peacock was saying, and then the kind of further questions that you were putting forward. So I do think finding God's activity in the very working of nature, whether it's evolution or condensed matter physics or the particular details, I think that there is something very important and real in that. But I worry about the issue of that the image of God just as a boundary condition rather than the kind of more classical notion of omnipresence, of God being present in everything, rather than the other way around, I guess, perhaps. So rather than God as constraint, but God as present. And you didn't get into the question of synchronic and diachronic, but I'm curious about, insofar as you tried to sort of incorporate that into an issue about God's activity, and then again, like, what does that mean for God's temporal relationship to the world? So, how does that sense? Can have a sense of a kind of is God dependent upon the changing of the world? Insofar as I understand diachronic is a sort of the idea of new processes merging out. What new things are happening in God that in this emergent diachronic emergent level. So I stop with that. And Father Javier, thanks so much for your talk as well. And I guess in one sense I'm very sympathetic to the idea. I too tend more and more to the idea of the pluralistic sense of causality. And so it seems like in one sense you set up a kind of, if the argument you're making works, it seems to be that you're arguing that, it's an all or nothing game with causality. So either there's no causality in the world, or if you introduce any causality anywhere, it's going to be everywhere. Or it has to be at all levels. And I'm intrigued by that argument, and I would like it to work, and I think in certain cases it might, but I guess the question I want to focus on is what kind of causality would force you into that? So exactly what are, in a certain sense, the boundary conditions on this HLCE you're talking about? That if you accept this, it ends up being unstable. So in particular, I just some of the quotes coming out of it, you have issues around fully explaining and accounting. And I have a question of, is there already baked into the particular kinds of HLCE, the high-level causal limitations, a sense of a necessary determinism in the natural order? Is there a version of a kind of higher-level causal limitativist that could have a probabilistic notion of causality that was made robust? And again, the question of whether probabilistic notions of causality can be fully robust is an open question. But would that escape some of the issues you're worrying on here? And I'm also wondering about, in one sense, I see the connection from the overall picture of thermodynamics as a whole and the second law of thermodynamics, in the way that is very closely connected to the question of superdeterminism. But they're also, they come out of different areas. From what I understand the issue of superdeterminism, there are versions of a kind of deterministic picture of the world in quantum mechanics that wouldn't actually qualify as superdeterminism. If I remember correctly, Bell argues for a kind of possibility of if I remember correctly, there are at least, you know, problematic but but open questions about Bohmian mechanics as a non-local activity. Again, that requires this non-local causality and is deterministic under the hood, even if not epistemically, and even that the specific thing about superdeterminism are the actions of the individual experimenters caused by things outside of their past light cone or not. And it's been a while since I've looked at the details of that, but I'm curious if the issue of the past hypothesis in thermodynamics and the issue of superdeterminism actually overlap exactly, or whether those end up being two slightly, if they're aiming at two slightly different issues. So I think I'll stop there and allow for response, and then we'll go on to questions.
Would you like us to respond to you?
If you would like to. If you have anything to say, that's fine.
Well, I have a platform, so why not? No, thanks so much. In fact, many of the points you made are exactly the kind of points I would want to make myself, because I'm certainly not a Thomist, but I do have a lot of sympathy with the whole kind of double causation view of divine action. Automatically leads you to questions about the way that Peacock, Oldfield, and others tend to view divine action inevitably leads to questions about, is God's work cause just a cause amongst others? So I fully sympathise with that, and I think this is one of the questions that I would want to ask of Peacock as well. What I particularly value about his view of divine action, and I suppose one thing I've noticed is that most, or particularly in the kind of divine action project school of thought, all of the views of divine action that came out of that presuppose a view of the unity of science. And the quantum mechanical ones tended to assume reductionism, where everything comes down to fundamental physics at the end of the day, and all the rest is special sciences. Peacock is the only one who really stands out for taking a more pluralist view of the unity of science. And I particularly value that, perhaps because I'm a condensed matter person, perhaps because I love all the science. I don't know. But I particularly value Peacock's way of doing it. So I think what I'd like to do is to understand Peacock further in view of this question about unity of science, because I'm really interested in the whole theology of nature. And the whole question you raised about synchronic versus diachronic divine action, I must admit that I'm only starting to think this through, which is why I didn't really include it in the paper, but this is a very valuable issue. And I guess the question here with Peacock is, because he doesn't clarify it, is does he imagine that God is a constraint, but clearly Peacock is thinking in terms of a divine cause. Does the divine cause trickle down through the layers in a kind of reductionist sort of way, or does God change the whole universe by exercising constraint in order to move a single atom? This is something I'm never entirely clear on. Of course, and I'm sure he would admit this, that all of these models are theological thought experiments anyway, and therefore severely limited. That's just a few thoughts in response, but thank you.
As a very quick follow-up, because I'm also interested in this question of divine action. So I think that we are always trying to avoid the God of the gaps, so the question of God acting in nature as a natural cause. So that would be the Sheila, and Caritis for me would be the transcendent God, and it's the fundamental, the primary cause, but we don't know how to articulate with the creatures, with the natural causes. And so we need to articulate better, so that's the problem. So how God acts through, or in, or with other causation. Very quickly, your questions. I don't know whether there is escape for the HLC, so they could argue that with a more relaxed view of causality, this wouldn't be a problem. The question for me is that causality has to do with determination. So we need to explain that things are determined. We see things determined. So what does determine those things? So that's a theory of causality, and we need sufficient causality. So we have many different causes that are necessary, and the set of these necessary causes is a sufficient cause for this event to happen. In other words, the notion of a probabilistic notion of causality for me, it's misleading. So in that sense, I think that we run into the problem of regression that you mentioned yesterday. Rob said about the probability of what. So probability is always related to our lack of knowledge. And you are right that past hypothesis is different from superdeterminism. I try to relate both of them because so the past hypothesis shows the degree of singularity of the initial condition for the universe, and I don't think whether superdeterminists have given a thought on this. And this is problematic because, if we want that this have some meaning in science, we need some notion of typicality. So our universe should be typical, should be more probable than others, but if we need to explain that, well, it was just like that, so that number, so the universe started with this degree of singularity. Oh wow, I don't think that's a good explanation. You also mentioned Bowman mechanics. Bowman mechanics is an example of non-local hidden variables. And incidentally, I would like to comment on this beautiful experiments by Zeilinger in these EPR correlations. So instead of deciding so that the experimenter decides on the orientation of the axis, so he takes the light that's coming from quasars that are like 600 million light years far away. So this decides the orientation for the axis, and then what happens with Bell inequalities? Well, they continue to be violated. So it seems that the degree of non-locality goes beyond this 600 million light years. So possibly to the beginning of the universe. Well, I don't know. So it's a metaphysical question. If you wish to believe that, okay, good luck.
Thank you. So, I open the floor to questions. I think we maybe 10, 12 minutes. Yeah, we'll see.
Thank you very much for the talk about Arthur. I think two things. A thing is relevant is people don't mention very much Arthur's previous book about microbiology, and I think that is where he basically got his ideas about downward causation, was by that initial book, which seems to, people don't seem to remember it, but I think that was the framework of this thing, that book, which is a great book. And particularly he talks about open systems. It's very strong about open systems. The second thing is, I don't think you're strong enough in defense of solid state physics condensed matter physics. It is definitely a fundamentally different kind of thing, no question about that. And Philip Anderson understood the idea of broken symmetries and the way that it could underlie particle physics, and the particle physics people owed their understanding of that to Philip Anderson. He should have got another Nobel Prize for the standard model of particle physics, and it's a scandal that he didn't get it. And that is a proof that it's just as fundamental as what goes on under the name of particle physics.
Thanks, George. Really helpful suggestions there. So yes, Arthur's got the new biology book. Is that the one you mean, from 1983 or something like that?
I can't remember its name.
Yeah. No, absolutely. He says a lot more there about complexity of systems and so on. You're right, of course. The Theology for Scientific Age, I suppose, is just the most comprehensive of all his books, so that's what I tend to base. But yes, thank you.
But I'm saying purely from the scientific side. That book was purely a science book.
Yeah.
Microbiology.
Oh, do you mean his textbook?
Yes.
I'm sorry. I thought you meant his book on God and biology.
No.
I see.
No,
I'm sorry.
Textbook.
Yeah. Okay. Textbook. Right. I haven't looked at that.
It's a really, really good book, and it emphasises the importance of biological systems being open systems.
Great, thank you very much. And could be stronger on condensed matter physics. I certainly agree with you that Phil Anderson should have had a second Nobel Prize. It's broken symmetries everywhere now in physics.
He wrote a rather plaintive little comment on it at some point about how his interaction with the particle physicists.
Okay, well I will feel justified in being more staunch about condensed matter physics then. Okay, great, thank you.
Thank you. I have another question to Mark. So you seem to be very keen on the idea of plurality of scientific disciplines, and I found it very interesting. So I've been wondering, I have two questions about how you think about this. First is,
Go ahead. Nothing to see here, just some broken symmetries. Mostly not broken computers.
A tea towel or something. Sorry, Marta, carry on.
That's fine.
we can double task here.
So, I mean, basically, about plurality of scientific disciplines. First thing, do you think that the boundaries between them are very clear? So, do you think that when you look at that process that you observe in the work, you can say, oh, this is biology, or oh, this is chemistry? That's the first question. And second question is, what is the motivation for this distinction? Is this instrumental? Like, do you think that it's just useful to have distinction between biology and chemistry because then we can have funding for different areas and so on? Or do you think that it's, I don't know, God-given?
Yeah, that's a really great question. I'm going to give you some slightly vague answers to that. So I suppose in my thinking here, I have been very influenced by a fantastic book by Joe Martin, the historian of science. He wrote the only history that I know of condensed matter physics. It's called Solid State Insurrection, about the kind of solid state people kind of ganging up and revolting against the particle physicists and forming their own disciplines. And he asks the question of, he begins by asking the question of what is physics? And he goes through quite a number of different possibilities here. And at one point, he says here, the only safe answer here is the one provided by, and I've forgotten his name, sociologist of science, who says physics is what physicists do. It's the only answer that really works, incidentally. Which is why Anderson had such a hard problem trying to define his own discipline in a way, because he had to grapple for some fundamental principles, and even he wasn't quite clear whether these are ontology or methodology, and I'm not quite clear myself either. So there's a sense in which scientific disciplines and sciences are sociological phenomena for sure, and historical phenomena, but they also do make some, some reachings towards some ontology, we hope, I suppose, and that's where the philosophers come in. But yeah, physics is what physicists do, certainly works. Sorry, that probably doesn't help though, does it?
I mean, that's like what I've called instrumentalist, I suppose.
Yeah, so that's another issue. Many physicists in condensed matter physics are very instrumental about what we do. So if you ask us, are you all Everettians? Certainly not. Which is your favourite quantum interpretation? We don't care. So we are very much in the kind of shut up and calculate school of thought. Although I would say that we're probably aspirationally realist in some way, but don't tend to put too many nuts and bolts into what that really means.
Anyway, we got a few more minutes, so two more questions here and then here.
Okay, question for Mark. So it sounds like to me what the Peacock was saying is essentially kind of like referring to the idea of the two books, right? The book of the scripture and book of nature. And then it's trying to read both. But we know that when reading the book of scripture, there's some limitations. From as broad as, for example, if you read the Bible in English, you have to read it according to English grammar, rather than a grammar of, English that you just invented. And to something as specific as certain exegetical principles that one ought to follow. But it seems to me that there isn't such a, if you will, analogically speaking, exegetical principle in place for reading the book of nature when doing theology of nature. Or is there?
What an interesting question. Okay, I haven't got a straight answer for you. I probably never have straight answers. So, first of all, Peacock, as far as I know, did not use the analogy, a very widespread analogy of the two books, as you say. In fact, he tended not to say very much about scripture at all. That said, he does have a recognisable Christian orthodoxy in sight, although he's prepared to move it around as he wishes. So, for instance, if you read what he thinks on the resurrection, he's pretty loose on that. Like he thinks the tomb is still Jesus in the tomb, the body of Jesus.
So we're still in our
Body of
sins.
Jesus. Sorry.
Yeah. So we're still in our sins, and it's all been. It's nice to know.
So all these questions arise. I'm thinking around your question about scripture and exegesis. I think so. In my thoughts about building a theology of nature, I have become aware that there's a kind of hermeneutical question here, rather like reading a text. Namely, which scientific disciplines do you prioritise, if any? How do you appropriate them, and how do you interpret them? And these are all exegetical questions, really. So it's not very difficult, I suppose, to talk about reading the book of nature as very analogous to reading a text. It's not something I've thought through in detail yet, and you're pushing me in a way, I suppose, that is making me think I have to. Did that help? I'm not quite clear if I got to what you were asking.
Yeah, I mean, that's basically what I'm asking.
Okay.
It doesn't seem to be a consensus on this issue.
I think that's right, yeah. So if you'll find that many people in the science and religion world have written aspirationally about a theology of nature as being something we really want to determine, but hardly anyone has really been successful. I don't think anyone's been successful yet, actually. It's something we talk about as an eschatological goal, in a way. And I'm not joking there.
All right, I've been told we need to cut it off. I apologize here, but leaves time for conversation over coffee. I was also told briefly that there is a stack of books here that are available by several written by various speakers and organizers, and they are free for the taking, with the strong encouragement that if you take one to, if it find it useful, please cite it. And so, if you'd like, please feel free to push that. I believe coffee is across the way.
Hopefully there's someone waiting to open the door for us.
Yeah.
I don't have the key.
All right, let's thank our speakers one last time.
you want me to close that door for you?
Okay, so welcome to the second part of the afternoon session. We have one long talk today and one, for the session and one response. So our speaker right now will be the Reverend Dr. Robert Verrill, a Dominican, if you haven't noticed. He is the Prior of Blackfriars, Cambridge. Well, that's okay. And a lecturer at Blackfriars, Oxford. He holds a PhD in mathematics from Trinity College, Cambridge, and a PhD in philosophy from Baylor University. And his research spans the philosophy of physics and the philosophy of religion, as we'll witness right now.
Okay, thank you very much. So, atomistic reductionism is often perceived as a threat to a Christian worldview. However, a growing number of physicists are rejecting it in favour of quantum monism, which posits the existence of only one fundamental object described by a universal quantum state. In my presentation, I will briefly explain some of the attractions of quantum monism, whilst highlighting the threat which it likewise poses to a Christian worldview. I'll then explain how a theory of hylomorphism can counter this threat by facilitating an interpretation of the quantum state as a description of the real potencies of the universe rather than as a complete description of the actual universe. This allows for the possibility of there being formal principles that complement the quantum state and actualize some of these potencies. I will distinguish this interpretation of quantum theory from other interpretations, and I will distinguish my adaptations of hylomorphism from extant adaptations such as Koons and Simpson's, explaining how it both overcomes the threat of quantum monism whilst preserving some of its attractive features. So two of the great triumphs of 20th century physics are Einstein's theory of relativity and quantum mechanics. According to the theory of relativity, nothing can travel faster than the speed of light, and light always appears to travel at the same speed no matter what speed the observer is travelling at. Einstein showed that in order for light to behave in this way, we must abandon the notion that there is an absolute measure of time across all space that gives us a universal now. Rather, events that may seem to be simultaneous in one frame of reference typically appear to be non-simultaneous in another frame of reference. As for quantum mechanics, according to what has traditionally been its most popular interpretation, the Copenhagen interpretation, we can model the behaviour of particles by supposing they each possess a quantum state that can be thought of as a wave function specifying the possible positions where the particle might be found. So if a particle is aimed at a double slit, the two wave functions corresponding to the particle going through one of the two slits will interfere with one another, with the result that when many particles are shone through the double slit, they will create an interference pattern of light and dark fringes on a screen, detection screen, corresponding to the peaks and troughs of the interfering wave function. However, somehow the particle decides not to go to the wave function trough region on the detection screen when both slits are open, but may go to the wave function trough region if one of the slits was closed. The Copenhagen interpretation explains this behaviour by positing that at the moment the particle is detected on the screen, the wave function of the particle instantaneously collapses to the region where the particle is detected. But the problem with this interpretation is that the notion of instantaneity across space is meaningless in relativity theory. One initially plausible response to this problem is to suppose that the wave function doesn't collapse instantaneously, but rather does so as a process that is compatible with relativity theory. But more problems arise, however, when one considers so-called entangled particles. It is possible to produce a pair of particles in an entangled state called a spin singlet, with the property that if the two particles are directed respectively between two spatially separated but parallel magnetic fields, one of the particles will be deflected in one direction and the other particle will be deflected in the opposite direction. In other words, the two particles of a spin singlet always end up in opposite spin states when their spin is measured along the same axis. This will happen even if there is a great distance separating the two magnetic fields through which the two particles are directed. Mathematically, this is described by a superposition of the two different possibilities. It is only once the deflection of either of the particles has been observed that the superposition ceases and that we can say that the two particles are no longer entangled. Now, John Bell showed that if the direction of the deflection for every possible axis of measurement was encoded in the state of each particle, then a statistical inequality, known as Bell's inequality, would have to be satisfied. However, it turns out that in experiments conducted on spin singlets, Bell's inequality is sometimes violated. On the other hand, if one models the pair of particles as a superposition of two spin states corresponding to the two possible deflection outcomes, then this model is entirely consistent with the violation of Bell's inequality. But if a spin measurement causes the spin singlet to collapse to one of the two summands of the superposition, then it seems to violate relativity theory. Or suppose Alice and Bob are two experimenters who measure the spin states of the two particles A and B of the spin singlet respectively. Then if Alice, observing particle A to be spin down, causes the superposition state to collapse so that Bob's particle B is spin up, then it is as though Alice has somehow influenced the deflection of particle B. Furthermore, if the separation between particles A and B was sufficiently large, this influence would need to propagate faster than the speed of light to ensure that Alice and Bob always got opposite results, and so this would seem to violate the theory of relativity. Now, an increasingly popular way to resolve this problem is to suppose that there are never any state wave function collapses. The most radical version of this approach is the many worlds interpretation of quantum physics. So, according to the many worlds interpretation, when Alice observes particle B and Bob observes when Alice observes particle A and Bob observes particle B, they also enter into a superposition state in which the two summands of the superposition are the possible states Alice and Bob would be in after observing the measurement outcomes of their respective particles. The composite state can thus be described in terms of two worlds in which the two different possibilities are realized. And as more and more observations are made, the two worlds will also split into more worlds. Now, a common objection to the many worlds interpretation is its excessive ontology, which posits the existence of many worlds which are almost entirely inaccessible to us. However, I think this objection is rather unfair, for Schaeffer argues that the many worlds interpretation proponent can endorse a kind of monism, which he refers to as priority monism. Priority monism doesn't deny a multiplicity of concrete entities, rather priority monism claims that in the physical universe there is an order of ontological priority among the concrete entities, but there is only one concrete entity in the universe that has nothing prior to it and which is prior to everything else. So as an example of ontological priority, and if you're an Aristotelian, one could consider a human person. So the hands of a person are concrete entities, but the human person is ontologically prior to them. In the context of the many worlds interpretation, Schaeffer views an entangled state of a physical entity as being ontologically prior to the components of the entangled state. And from what we know about the Big Bang origins of the universe, in which all physical matter expanded outwards from a very dense origin, then in the absence of any mechanism by which quantum states could be disentangled, Schaeffer believes that every physical part of the universe is entangled with every other physical part. What this means is that if we thought of the universe as consisting of our world, by which we mean the planet Earth, and an environment which could include, among other things, all the rays of light that were reflected or emitted from the world, then we could express the state of the universe as a superposition of world environment states. Thus, if there were world states W1, W2, W3, etc., and corresponding environment states E1, E2, E3, etc., then the state of the universe could be expressed as a superposition of world environment pairs, where this universal state was such that if we happened to know that the environment was in the state EI, then we would know that the world was in the state WI and not in any of the other world states. So this expression of the universal state is somewhat analogous to the state of spin singlets, where we can think of particle A as the world and particle B as the environment, because by measuring particle B, Bob could determine the state of particle A. Now, despite me strongly rejecting the hypothesis that a quantum state could provide a complete description of physical reality, I think we can make a strong case for quantum monism if we assume this hypothesis. However, I don't think Schaefer makes the best case for quantum monism as something that depends entirely on quantum physics being complete. For in his account of quantum monism, he describes these many worlds as being shards, concrete entities that are derivative of the one universal substance. But such a description comes into difficulty in situations where the summation of the world environment pairs in the universal quantum state is not unique. That we might doubt the uniqueness of such an expression is suggested by the example of a universe in which there are only two particles, with the world being considered as one particle and the environment being considered as the other particle. So when two particles form a spin singlet, it can be shown that the summation that makes up the spin singlet the state won't be unique. There will in fact be infinitely many ways this summation can be expressed. In this very simple two-particle universe, one then says that every summand of every possible summation expressing the universal state is a concrete entity, or a shard as Schaefer would put it, this hardly seems like a parsimonious ontology. But if one were to play devil's advocate, it seems that a better way of defending priority monism in the context of the many worlds interpretation would be to consider the particles of the universe as the concrete entities, rather than the vastly greater number of particle states as the concrete entities. One could then claim that when the states describing the particles were entangled, then the entity described by the entangled state would be ontologically prior to the particles that were entangled. For example, in the case of a spin singlet, if the superposition of the A spin up state, B spins down state with the A spin down state, B spin up state is a complete physical description of the spin singlet, as the many worlds advocates would have us believe, then there would be no fact of the matter regarding what spin state A is in or what spin state B is in. So when considering a spin singlet state, we cannot correctly conceive of the two particles as having their own independent spin states. And if we adopt the principle that whatever physical things that cannot in principle be described as individual entities do not exist as individual entities, then we could assign an ontological priority to whatever concrete entity the two particles do belong to. It would then follow that if all the particles were mutually entangled with every other particle, there would then be only one concrete physical entity that had nothing prior to it. Hence, the picture of reality would be an example of priority monism, and one that I think is much more parsimonious than what Schaefer is advocating. Also much more in keeping with the hypothesis that quantum physics provides a complete description of physical reality. There is, however, a rather significant cost to pay in adopting this form of priority monism. Or at least in Schaeffer's view, we might conceivably talk about the facts of the different shards, that is, the different worlds that are in superposition with one another. But as I've argued, I don't think this is what we should be thinking about physical reality if we believe that quantum physics provides a complete description of physical reality. In the more parsimonious form of priority monism that I've just described, there are no objective facts about the individual particles. There are only hypothetical statements. So in the two-particle universe, for example, such hypothetical statements would include if A was found to be in spin-up state, then B would be found to be in the spin-down state. Now, the claim that we should abandon any belief in objective facts about the goings-on in particular regions of space and at particular times would strike many people as absurd. And this should especially be so for Christians whose faith depends on particular historical events in particular locations in the past. Also, on many occasions, the Catechism of the Catholic Church speaks of human individuals, but in the kind of monism that follows from the hypothesis that quantum physics is a complete theory of reality, there are no individual subsystems of physical reality, and hence no human individuals in physical reality. Now, one obviously doesn't have to be a Christian to believe in objective facts about reality, or that human individuals exist, but there are Christians who endorse the many worlds interpretation of quantum physics. And since the many worlds interpretation that follows from positing the completeness of quantum physics is a form of monism, and since monism, as I've described it, is alien to Christianity, then quantum monism is a threat to Christianity. Now, it seems that, to me, that one of the ways we can address the threat that quantum monism poses to Christianity, and anyone who believes in objective truth, is to articulate just how absurd quantum monism is. And we need to do this in such a way that quantum physicists can't fob us off by saying we don't understand mathematics. Now, I think we should appreciate the mathematical elegance of quantum monism and the many worlds interpretation, but no matter how elegant the mathematics might be, when one reaches absurd conclusions, the more reasonable approach would be to question one's premises rather than embrace the absurdity. It follows that in addressing the threat of quantum monism, we need to do more than articulate its absurdity. We also need to offer an alternative interpretation of quantum physics that has some of the features that physicists find attractive in the many worlds interpretation, such as its compatibility with relativity theory. But we want to have find something attractive, but it doesn't lead to this absurdity of the many worlds interpretation of quantum monism. Now, in recent years, the physicist Adrian Kent has suggested a way we might do this. Kent assumes that there is a universal quantum state that evolves over time in accord with standard quantum physics, but he denies that the quantum state gives a complete description of reality. Instead, Kent supposes that in addition to the universal quantum state, there is a specification of a mass energy density on a distant future three-dimensional hypersurface that is selected with a probability consistent with the probability predicted by the universal quantum state that has evolved into the distant future. So that is in accord with the Born rule. With the additional information contained in this mass energy density, Kent supposes that the energy and momentum of all earlier times in history is determined by the universal quantum state being appropriately conditioned on the distant mass energy density having the values given in the specification on this distant hypersurface. Kent refers to this as a notional measurement on the distant hypersurface. So as an example, which might make Kent's proposal maybe a little bit clearer, so consider So according to the many worlds interpretation, if we directed one particle of a spin singlet through a magnetic field and onto a detection screen, the state of the light reflecting off the detection screen, indicating where the detection was made, would enter into superposition of states corresponding to whether the particle was deflected upwards or downwards. This light would then go off into outer space, and in the absence of anything to absorb the light would carry on indefinitely until the time it intersected the distant future hypersurface on which the mass energy density is determined, is specified. At this distant future time, the light's energy corresponding to the upward deflection of the light of the particle would have to be specified at a slightly different location from the energies, the light's energies corresponding to the downward deflection of the particle. And because remember, there's lots and lots of light reflecting off this system. So the distant future specification of the energy densities thus determines which of these two possibilities are realized. And by reading off the information contained in the distant future mass energy density specification, one can determine which of the two possible outcomes actually occur. Now one can think of Kent's proposal in terms of the branching many world states, but with only one single branch being highlighted as actual. The other branches could then be seen as having a degree of reality insofar as they ground the truth of modal statements about what might have happened. But in contrast to the many worlds interpretation, there would be only one branch that had a full degree of actuality. Now, Kent doesn't allow himself to get drawn into the question of what sort of reality the non-actual branches have, while his main interest is in proposing a one-world picture of reality that doesn't suffer from the relativistic problems that plague the Copenhagen interpretation. Nevertheless, I think that Kent's proposal does raise questions about the ontological status of the different branches of the universal quantum state, and I also think it's worth speculating on how Kent's proposal might relate to a hylomorphic interpretation of quantum physics. So Alexander Pruss has already suggested one such hylomorphic interpretation which involves travelling forms. Pruss begins by considering the many worlds interpretation of what it would be like to live in one of these worlds. The kinds of scenarios that Pruss imagines suggest he is thinking of these worlds as concrete objects in a similar way to how Schaeffer thinks of them. In this context, some philosophers have endorsed a travelling minds view where all the minds travel together, taking the same branch whenever the world splits. Pruss, however, argues that it would be better to endorse a travelling forms version of this view. That is, Pruss posits the existence of forms and that these forms all take the same branch at every split. It is only in the world that has forms that there are facts about individual things, such as donkeys or human beings, for example. So my hylomorphic interpretation of quantum physics, which is inspired by Kent's proposal, could be seen as a sort of variant of Pruss's view. So Kent's privileging of a distant future energy density measurement will induce a preferred way of describing the universal state as a superposition of world environment states, and among these many worlds, the determination of the future energy density measurement will uniquely pick out one of these many worlds and deem it to be actual. So what measurement outcome is obtained for this future energy density measurement will be consistent with the rules of quantum theory, because it's chosen according to the Born rule, but there will also be many possible outcomes that would have been consistent with the Born rule. But rather than saying this outcome is completely random, apart from satisfying the Born rule, I suggest that there could be principles of actualization that determine which outcomes actually occur. Moreover, because there is so much information in this density specification that adds to the picture of quantum mechanics, that there can be many principles of actualization. So if we deem these principles of actualization to be the forms, then there will be only one branch that will be associated with associated with these forms, much like Press's travelling forms view. We can also think of these forms as disentangling the universal quantum state, so that rather than there being just one universal substance, there will be a whole range of substances, each with their own principles of actualization that will determine which branch is taken at every split. So this disentangling process is analogous to the disentangling that occurs between the measurement device and the thing being measured when the wave function collapses in the Copenhagen interpretation. So in my hylomorphic interpretation of quantum physics, I think it is plausible that if two systems are not entangled with one another, then they will belong to distinct substances, since we could then describe the systems independently of one another. However, I'd be somewhat wary of simply identifying entangled systems with substances, since since having a simple identification of entangled systems with substances, since there will be situations where systems will become entangled which we would not intuitively think of being different substances. So, for example, when two spatially separated objects A and B interact with each other, there will be a succession of entanglements and disentanglements between A and B, as the light from A is both absorbed by B, causing an entanglement, and also specified on the distant future hypersurface, which would cause disentanglement. In such a situation, there will be a remainder of light constituting a medium of entanglement, so that when the light state is specified, disentanglement would occur, and that would mean that we'd have this form of mediated entanglement by this light. And so in this case of mediated entanglement, the information specified on the future hypersurface, the energy density, will allow us to obtain a complete description of A and a complete description of B. But only when direct entanglement occurs without there being any medium of light, such as in the situation below, should we be inclined to say that the two objects A and B belong to the same substance, since in this case there is no means of giving a complete description of A separately from a complete description of B. Now, so note that the hylomorphic interpretation I've offered here is very different from Simpson's theory of cosmic hylomorphism, which relies on Bohmian mechanics. For in the original version of cosmic hylomorphism, there is only one substance, or there are many objects, whereas in my interpretation, there would be many substances. And my interpretation is also very different from the contextual wave function collapse, for which Simpson has been constructing a hylomorphic interpretation, since I don't deny that there is, I guess I'm kind of agnostic about whether it's a universal wave quantum state, but if for the sake of this sort of this model, I don't deny that there's a universal quantum state, and neither do I deny the explanatory power or the truth of decoherence theory. So my theory is also different from Koons' account of thermal substances, since in my account I don't need to take a thermodynamic limit where there are infinitely many particles. So my interpretation also satisfies Lorentz invariance, because it's based on Kent's interpretation, which is Lorentz invariant. So I don't think there's a good region to reject the interpretation that I've been offering in favour of the many worlds interpretation, because it has the features that many worlds adherents would find attractive. So in summary, I've given a brief overview of quantum monism in the context of the many worlds interpretation. I've tried to highlight the threat that quantum monism poses to Christianity, as well to anyone who wants to uphold the reality of objective truth. And in addressing this threat, I've tried to articulate the absurdity of quantum monism, but I've also tried to offer an alternative to quantum monism that is inspired by Adrian Kent's interpretation of quantum physics. And in doing so, I have suggested a way in which forms can be introduced into this picture in a way that would be consistent with both the theory of relativity and quantum physics. this interpretation of quantum physics might still seem rather strange. So there's still some work to do. There's still important issues that I haven't touched on here, such as the nature of time or epistemology. But my hope is that by thinking of the universal quantum state as describing real potencies and of the determination of the energy and light as being manifestations of real actualities, then we might be able to understand this Kent-based interpretation of quantum physics that I've been offering in this paper as essentially a doctrine of hydromorphism. So thank you very much.
Thank you. Perfect timing. Well, so Robert in his paper presented an interesting interpretation of quantum mechanics, which is based on the work of a physicist Adrian Kent, and he suggested an ontology that corresponds to this interpretation of quantum mechanics based on hylomorphism. The main advantage of Kent's interpretation over a Copenhagen interpretation is that it takes into account relativistic theories, and the main advantage over Everett is that under some interpretations it entails more personalist ontology. We've heard that in Kant's quantum theory there exists not only the universal quantum state, but also there is a specification of a mass energy density on a distant future three-dimensional hypersurface. Consider a quantum state in a superposition. In Robert's interpretation, it is similar to Everett in that there exist branches that correspond to each of the states in which this superposition, but it is different from Everett in that, quote-unquote, only one single branch is highlighted as actual. This is possible because which branch, using Robert's vocabulary, actualizes, is specified by that mass energy density on a distant future three-dimensional hypersurface. Before I move on to discussing Robert's work on hylomorphic ontology and its relation with Christianity, I cannot not comment on Kent's project itself. Admittedly, it is a very interesting alternative to more familiar interpretations of quantum mechanics. For example, because it, at least prima facie, deals with what some can consider to be an excessive ontology of the many words interpretation, namely that there exists a vast number of words. I do think, however, that it comes at its own price. Kent's picture requires an existence of a distinguished, distant three-dimensional hypersurface that, using Robert's language, determines which branch actualizes. But one of the most fundamental intuitions that stand behind relativity theory, just to remind, the main motivation presented by Robert to reject Copenhagen, is that there are no distinguished hypersurfaces. For this reason, Kent's theory seems to be arbitrary in that it picks up, with certain probability and by the mass energy density, one specific hypersurface, which then determines evolution of the universe. Thus, everyone needs to decide for themselves what price they want to pay. Excessive ontology of Everett, arbitrariness of Kent, or some potential implausible elements of other interpretations of quantum mechanics. Now, I have so many questions about what you said about actuality, potentiality, counterfactuals, and entanglement, and let me just acknowledge how sophisticated and advanced your project is. But I'm mindful that we have been put in the Science and Religion panel, so let me say that. Well, solving the measurement problem in a way that is compatible with relativity, however, was not the main reason why Robert advocated Kent's quantum theory of quantum mechanics. For he argued that, in his view, the natural ontology for Kent's quantum theory, based on hylomorphism, can also address problems posed by quantum monism, motivated, for example, by Everett, to Christianity. His two main points were the following. First, Christian faith depends on particular historical events happening in particular locations in the past. I gather that an example of such an event can be crucifixion. Second, on many occasions, the Catechism of Catholic Church speaks of human individuals, which obviously we can extend beyond Catholic tradition. I want to focus on the latter point. It seems to me that what Robert is indirectly trying to point at is that, for Christians, there exist macroscopic entities that are, using non-philosophical language, absolutely fundamental to their faith. And yet rival interpretations of quantum mechanics are spectacularly unsuccessful in providing an account of such macroscopic objects. I can hardly disagree with this point. After all, Christianity seems to be all about macroscopic objects. But isn't it the case in our all everyday experience? When I think about my day so far, it was full of macroscopic objects. I've made myself some macroscopic coffee, I had in a macroscopic mug, I've brushed my macroscopic teeth using a macroscopic toothbrush, and so on. I can hardly ever consider myself interacting with some microscopic quantum entities. And you may say, this is because of your epistemic limitations. Your coffee mug, toothbrush, etc. are in fact fully reducible to microscopic quantum entities, and Robert presented a neat way of accounting for macroscopic objects based on Kant's interpretation. Imagine that this is the case, namely that Robert's interpretation of quantum mechanics, which combines Kane framework with hylomorphism, is successful in accounting for such macroscopic objects as a coffee mug. In Robert's interpretation, macroscopic objects can exist because there is a distinguished actual history picked up by the three-dimensional hypersurface, which has forms. But how does it exactly work? As much as, with some dose of imagination, I am keen to accept that some mass energy density picks up its favorite path of evolution of the universe, I can hardly see how it assigns particular forms to particular regions of space-time, parts of the wave function, bundles of particles. I don't want to caricature this view, but I just don't understand how it happens that starting with many words, with one actualized branch, objects within this branch get their particular form. How does one particular part of the actual word gets assigned an Aristotelian form of a coffee mug? Perhaps it is explained in more detail elsewhere in your work, so I would appreciate some clarification on this. Well, I do, however, think that both Rob's paper and my considerations so far miss the key point that should be made at this panel, which is devoted to middle-sized objects in quantum theory and Christianity. Just to remind, one of two arguments for the claim that quantum monism poses a threat to Christianity is that, in quantum monism, there is no account of human persons. Now, for a moment, we assume that Robert's interpretation of quantum mechanics can actually account for such macroscopic objects as coffee mugs. But aren't human persons in Christianity very different from coffee mugs? I think they are. Moreover, I think that the difference between them is not merely in that they have different forms. Let's look at the Catechism as Robert referred to it in his paper. We read that the human person, created in the image of God, is a being at once corporal and spiritual. Obviously, I believe that humans are also spiritual is not unique to Catholic tradition, and not even just to Christian tradition, or to any other religious traditions. Let's push it even further, because neither Christianity nor most of non-Christian anti-naturalistic views are just about humans. Some of us want to be able to speak about grace, angels, souls, thoughts, feelings, universals, Platonic ideas, or God himself. I don't think that Robert's interpretation of quantum mechanics based on hylomorphism, or at least the version that was presented just now, is successful in accounting for such entities. What is more, I would be deeply concerned if it was. If we start from a purely natural picture, here Kant's interpretation of quantum mechanics, which is naturalistic in that it speaks only about such entities as the universal quantum state, three-dimensional hypersurfaces, mass energy density, then it comes as no surprise that it doesn't come with human persons or God, who are irreducible to elements of the natural world. To my best understanding, Robert was indirectly arguing for a similar but stronger point on the example of quantum monism, namely that it is impossible to recover such entities as human persons from quantum monism, and this is why it poses threat to Christianity. But is it really unique to quantum monism? Consider any interpretation of quantum mechanics, or a space-time theory, or an interpretation of your favorite theory in physics that do not postulate the existence of only one fundamental entity. In fact, a good example would be Robert's hylomorphism based on Kant's interpretation of quantum mechanics. It seems to me that, in such a framework, even though we have forms and multiple substances, we still miss such key elements of Christian ontology as souls, persons, or God. And this is because quantum monism is allegedly a threat to Christianity, not because it is a monism, but because it belongs to the domain of naturalism. In this sense, it seems to me that the only way for Robert to recover the complete Christian ontology from his hylomorphic picture is to simply postulate the existence of its elements. It would be interesting to see whether he would like to pursue this strategy. Though in fact, if you believe that your forms and substances are not fully reducible to some physical matters of fact, you already went down this route of postulating non-naturalistic entities, I think. So perhaps Robert doesn't want to recover Christian ontology from the quantum picture, but rather show that these two are not incompatible. Well, personally, I think that instead we should ask ourselves why, at the first place, we should work on formulating interpretations of quantum mechanics that are explicitly compatible with Christianity. I'm not saying that this is what Robert is trying to do, but I keep seeing this temptation among lots of us. This may not be the best idea for a number of reasons. For example, quantum mechanics is likely to be false. This is the so-called argument from the pessimistic meta-induction, namely, given that lots of our previous theories turned out to be false, we have no grounds to believe that our current physical theories are definitely true. And at the same time, theology aspires to convey timeless truths. I could keep going with similar arguments, but I just want to finish with a more general question, for which I have no answer. Aren't we overly buying into the 21st century scientism? And isn't our aspiration to reconcile quantum mechanics and Christianity a way of looking for validation of our theology or philosophy by science? And if so, is this the direction in which we should be going? Thank you. Okay, well, let's start with response.
Thank you very much for your response. Yeah, so, I mean, in this account of quantum physics, what I'm trying to do is maybe try to sort of create sort of ontological space for principles which we know really that is completely beyond quantum physics to study. So when I'm talking about these principles of actualization, so quantum, like in quantum physics, it tells you that there's a whole myriad of possibilities of, say, ways that things could move, and so I could behave in a rational way, or I could behave in an irrational way. But whether I behave rationally or irrationally, it's not going to sort of the truth of quantum physics isn't going to hang on my rationality. So there seems to be that there is space in quantum physics to have these complementary principles of actualization that transcend the materiality of the physical realm. So immaterial principles of rationality that could govern my physical behaviour. So I'm very, very brief on my account of how this how forms fit into it, but maybe something about. I guess part of my kind of Christian inspiration to this picture is the role that light plays in giving an intelligible one world account of reality in a way so where Kent's interpretation depends on there being fundamentally a determination of light, and it seems like, well, whether you describe it as a hypersurface or just say that there's some kind of determination of light, it seems attractive to me in the sense that the light is actually a part of us, in the way that we interact with people, the way that our interact with each other is kind of how we connect with each other, but also light is something that differentiates us, and I think this kind of there's something that I can sort of see in Kent's interpretation, where it sort of appeals to my kind of Christian sort of sensibilities, where the role that light plays in bringing intelligibility to the world and actuality, and that's the side of my sort of inspiration to Kent's theory. But also I think Kent would also want to defend himself against this kind of this arbitrarily chosen random, as though there's some kind of physical hypersurface at some time distant point where the mass energy density has been determined. Because I mean, he talks about this sort of notional measurement. So what he's saying that, well, you could choose one hypersurface and in the distant future and specify a mass energy density, and that would give you some sort of quasi-classical one world history. But you could also choose another hypersurface much further away, and also give that a kind of a mass energy density determination, which would give you the same quasi-classical history up until some point. So he's saying that you can sort of, he's giving you a way of like selecting a like a branch of the many worlds interpretation, which is consistent with the Lorentz invariance. But whether you want to, he's kind of like giving you kind of like a recipe for saying this is how a history could look that is consistent with relativity theory, rather than saying that has to be literally an arbitrary hypersurface in some distant future that has a definite value. So, So I want to say that Kent is entirely agnostic on how this hypersurface, what these kind of determination would be, but and he just talks about the Born rule, but it seems like you could. There's lots of things that could be that could come from sort of same distribution as the Born rule, but have lots of kind of teleological accounts and even immaterial principles that could account, but which could tell you a story of why this alternative happened rather than that alternative as the world evolved through history. So well, that's just a few comments in defense of Kent and Hoffmann-Kolss.
Thank you. Well, I mean, just on arbitrariness, this is why I said that you decide what price you want to pay. I know lots of Everettians who are happy with the multiverse.
Well, I think
because they don't live in it.
So you have to. But also, I think some Everettians, the kind of impression I get is they try to have a kind of sanitized version of the many worlds interpretation, where it just turns out the universe is a lot bigger than we thought it was. Whereas I think I think they're kind of making additional assumptions to quantum physics by kind of reifying these branches. That is really it's just like you can express a state as lots of different kinds of sums. I mean, they talk about bases and pointer states and all that kind of stuff, but it all seems a bit kind of, they're imposing an additional layer of assumptions. So it's kind of so if you're going to kind of oppose assumptions, then I think it's almost like if you just said that there's just some kind of fundamental determination, it seems like in a way we can actually do science and make and like when they're middle-sized objects, that seems more appealing than the kind of monism that I think flows if you rigidly believe that quantum physics is a complete picture of reality.
Yeah, so I really enjoyed this exchange. I hope they do as well, and I think we should give them a chance to grill us as well.
Yeah. Okay.
So, oh dear. So, I think Robert was fast.
I hope this will be a quick one. So I want to understand how the branches figure into this. So the Everettians tried to, Oxford Everettians tried to explain how the branches emerge in some kind of like way. Does Kent need that at all, or is that just a...
Well, I mean, I think it's Kent's theory is consistent with the story of how the branches. It's like in terms of decoherence theory, where the So I think what I kind of like about the many worlds. I mean, I like decoherence theory. I think it's great. I mean, I think it's got a lot of explanatory power. I think the problem with decoherence theory is when people try to make it explain more than it can explain. So it can't solve the measurement problem. And but I think Kent's theory, I think it can accommodate sort of the where the branching occurs. You can give an account of so you have to understand branching in terms of making a distinction between the world and the environment. There has to be that distinction for the notion of branching to make sense. That's when the kind of the pros terms in your kind of state matrix, they kind of vanish in decoherence theory. And so Kent's theory is entirely compatible with that. But, yes.
So in your interpretation, what's the state of the other branches?
So these are things that could happen, but they haven't. So I want to sort of make it's not a case of something being perfectly actual or something being absolutely nothing at all. There's some kind of potentiality, some kind of ontology that is not actual, but is not nothing either. So they can sort of, the other branches can sort of ground counterfactualist claims about what would have happened if.
My worry is that the wave function just by virtue of its having a shape, as in the curvature denotes this in possession of kinetic energy. It does have seems to have ontological bearing.
I mean, it has some degree of actuality, but it's not as actual as real what the world that we see around us. I mean,
would you posit a degradation of actuality on top of the distinction between actuality and potentiality?
I think there's there's a degree of with the quantum state, if it was complete potency, then we wouldn't have any kind of way of grasping any intelligible. We wouldn't see anything intelligible about it at all. So there must be some enough degree of actuality to actually speak intelligibly about the wave function. But we're kind of very limited in how much intelligibility we can actually recognise in the wave function, because you end up getting all this quantum entanglement, which seems all very strange and we can't really get our heads around.
I have more questions.
So we actually run out of time. What do the organisers think?
I think we still have some time, don't we? It's fine.
Great. Well, sorry, to my list, Howard was the next one.
I think Martha raised a very interesting, different kind of question in a way. Namely, 2 points to it. One is the need for some kind of dualism, namely the spiritual, the mental, and the person just are not the same as being a physically, but in whatever science you have. And the other is, why should we take any notice of science at all? Now, we don't want to say that, because otherwise you'd look like a fundamentalist who would say 4006 BC is okay. And so, what to what extent should one want to say, well, if this science is more or less right, it oughtn't to go bang against what we think. It doesn't accommodate the whole of our system. But would you say that's what you were trying to do, or were you walking more or less in the view that this somehow does everything?
No, I'm very, I definitely don't want to say that what I'm presenting is a complete power. I'm really trying to sort of make ontological space for principles that complement quantum theory, and quantum theory has nothing to say about these complementary principles. But you need a different science to talk about macroscopic objects like rocks and cups of coffee and human beings. These belong to entirely different science. But I'm trying to sort of give a way in which you could make sort of this kind of this space for by thinking of quantum theory as really just describing sort of a myriad of possible things that could happen, but it's not going to. But you need to. So like if you try to write a quantum state for a cat, then that's not going to move as a cat moves. It's going to kind of all kind of go in all kind of weird, kind of entangled state with its environment. It's not so you can't understand macroscopic objects by trying to describe their quantum state and then seeing how that evolves by applying this sort of a Hamiltonian. I'm trying to sort of give space for saying that this picture of quantum is never going to be sufficient to give you account of the reality that we all deal with.
I wouldn't mind if it did for the cops.
Oh.
I think those are phenomenal constructions. I mean, they're just part of our experiential world, so you might be phenomenal about those, but not about us, and not about the experience.
So the next on my list was Mark, I think.
Thank you. This is probably a question for both of you, actually, because I think you both raised the same issue about the incorporation of the human being into quantum interpretation. There is one that does this, cubism. Is this a conference to discuss cubism? I would suspect not, but I don't see why not, because we're talking about middle-sized things. So I'd love to know what you both think about cubism and why it might or might not be appropriate.
So you talk about quantum Bayesian, I guess. I mean, I'm not entirely happy with quantum Bayesianism, because it seems like in order to come up with come up with a sort of epistemological account of what's going on, somehow there has to be something that's actual to kind of make to draw those sort of conclusions. I mean,
the observer.
So I'm not I don't particularly like quantum cubism. So but I haven't. I mean, the thing is, I haven't kind of invested a lot of time thinking about it. But it seems like just like with tossing coins, it seems like you kind of have this you form a sort of prior on how it's going to behave because it has this kind of actual symmetry to it, and somehow quantum Bayesianism it seems to just sort of doesn't actually touch about these kind of real symmetries in the world. I mean that's kind of my kind of prejudice against Bayesianism, but I don't know. But
cubists actually dispute this themselves. But yeah, sure, okay.
Okay, but what you want to say?
I mean, not much. I mean, I don't think that as a physicist I've spent too much time thinking about this, but also I know that William really wanted to have someone who actually speaks about religion. So I'm trying to make a point here that, an agent in this kind of quantum mechanics is very one-dimensional, always, whereas here the point about human persons is that there is a soul to it, and a human person is said that it can receive sacraments, blah, blah, blah. So in this sense it's not helpful, but it's definitely an interesting way of at least progressing more towards having a conscious agent. And we are running out of time. Great. So that was, I gathered, the last question, and now we have the next discussion. Thank you.
All right, so we're going to close with a short panel discussion. So I believe anyone who is involved in speaking this today is invited to become part of the panel. And I've been asked to let's try to come up with a nice question. Oh, I'm sorry. No, you're first. Yes, I'm sorry. No. Yes, please. You can start moving around, but no, right, Rob is going to do, he's going to make some synoptic remarks about the last couple of days.
Just have a special session on it. What? No, we'll just have a special little thing at Blackfriars in a month on it.
This is also
Yeah, I just wanted to say beyond those. So sorry. Yeah, because way beyond
I presume Jonathan is not going to expose you
Whose clicker is this?
I'm going to get started just to keep us on time. Good. So William asked me to do a synopsis and reflection. So synopsis is impossible because there's so many talks of it, it's so rich that there's no way I can do that. So I'm going to give a very opinionated reflection instead. And I will mention a few of you in the process because I'll follow like a string of narrative through it. But if I don't mention you, don't think that it means I'm dissing your talk at all. But there's no way that I could do it without being highly selective, I guess. So I'm going to try to do this really, really quickly too. So I think there's a sort of one consensus I think that we've all reached, which is there should be some kind of causation at these higher levels, right? I don't think anyone's attracted to a view that's completely causal eliminationist. This is why Javier's talk is important, right? Because if he's right, then those who don't think they're going to end up in a very bad place. We all agree. Right? We don't want that. We don't want to be causal eliminationists about the outside world. But then, as we've seen, there's a number of different options, right? So I'll call them A, B, C, D. So we could have this is largely based on Tim's work, right? So A, like the classical Nagel reduction translation of the middle-sized stuff down into the quantum or some other fundamental level. B, some kind of weak emergence, possibly also involving grounding or realization or constitution or something like that. But the real oomph is all at the microscopic level in some way. C, strong emergence, but with joint difference making. So the entities are all the many little things, but now they're acting weirdly in certain cases, right? When they're combining in living organisms or whatnot. And then D, strong emergence with unified difference making. So unified substances that are composite, that are actually making a difference in the world. So those are the four options. And then there's another cross-cutting distinction, at least among C and D here, depending on how widely we want to take the strong emergence, right? So do we want to limit it to conscious beings? Do we want to extend it to all living things? Or, as I would like to do we extend it to the inorganic world as well? So there's lots of inorganic substances that involve this kind of strong emergence from the microscopic level. So those are some of the big options. Another issue that came up, I just want to mention, is a very interesting issue about teleology and agency. So obviously Philip's work is interesting there. Aristotelians, like myself, are very happy to extend teleology down to the inorganic level. I haven't really thought about consciousness so much, but Philip's actually making me think about this. Maybe I always have sort of defended ourselves. There's nothing conscious here. I don't think it's a film urge or anything like that. That'd be crazy, right? And now Phil's saying, well, it's not so crazy. Maybe I should think of these small inorganic things as having a kind of yearning at a very primitive level for their end. I'm going to rethink that. But there's certainly that issue. And then there are others, like George, who would limit the teleology to the living things. And then there's finally very attractive, again, to think maybe it's just rational agents. Maybe it's sort of Howard's view that real teleology involves conscious, deliberate choice of some kind. So those are some of the options there as well. We've also talked quite a bit about causal laws, and I would like to extend that in a way to the quantum wave function itself. What's the status of the quantum wave function, right? Is it a kind of absolute and universal entity of some sort, of a mathematical kind, that which is, I think, Alyssa's view and the view of most physicalists these days, right? That there's some kind of universal, context-free, universal law that governs things, and that represents the bottom line, that physically speaking, right, in terms of explanation. Then there's George's position, in which he still very much wants to talk about laws, but it's much more contextual laws. No claim that there's a single universal thing. It's much more a question of what kind of explanations we want in particular contexts. And then finally would be the causal powers sort of camp, right? That thinks that ultimately it's causal powers of individual substances that are the real driving force here. Laws are just summations of those kinds of influences. So I just want to conclude real briefly with some reasons why everybody should be hylomorphous. Why should dualists be hylomorphous? Why should panpsychists be hylomorphous too? And then finally, why even materialists and naturalists should be hylomorphous. Obviously, I won't be able to cover all of that in the 6 minutes remaining. But I said something about why dualists should, right? Because dualists should take the human body seriously, I think, as an entity. And I don't understand how it could be weakly generated, weakly emergent and generated by our consciousness if it's through the body that we were actually perceiving things in the first place, right? So it looks like I think you have to have the body in place as the vehicle by which we perceive and interact with the world, and that means it has to have some kind of a unity to it, persisting through time. I think that requires something more than weak emergence, in my view. Panpsychists, that's a similar kind of issue, right? I think panpsychists should think seriously about, how to, one of the central problems, of course, is how to get unified consciousness at the level of a composite entity like you and me. Even if the little bits are conscious, how does that unite into a consciousness at a composite level? And hylomorphism is all about that, right? Sort of explaining how composite things can be fundamental, how they can have fundamental powers. So I think panpsychists should really take a look at it. And then finally, in terms of naturalists more generally, the materialists, right? I think that they need the middle-sized world. I mean, if you look at David Lewis's explanation of how mind works, he takes for granted the middle-sized world, right? And then gives a functional explanation of how mind fits into that, right? That's because we have a folk theory about how the middle-sized world and the mind relate to each other, and that enables us to constrain our functional definitions and so on. So I want to just conclude with an idea that's will help here, I hope. So we might think of 3 worlds, basically. So world 1, 2, and 3 now. So there's the quantum world, 1, there's the middle-sized physical world, 2, and there's the mental world, 3. And so I'm going to propose Koons' law of metaphysics, first law of metaphysics, which is that you can reduce one of these to the other 2, perhaps, but you can't reduce all of them to one. That to try to go from one of those worlds and reduce everything else to it is just a bridge too far. So roughly, here's some options, right? So you could be an Aristotelian and think all three worlds are fundamental. I think that I think is the right view. It's less parsimonious, perhaps, but it's certainly a possible view. You could be a view like Lewis and take both the physical and the middle-sized world as fundamental and then explain the mental in terms of it. You could be a kind of Copenhagen, just calculate person and take the middle-sized and the mental world to be fundamental and think the quantum world is just some kind of instrumental thing and sort of reduce it to the probably it's like quantum Bayesians do in a sense, right? As an option, right? You could have an interesting kind of view, which I think is the view that Tim and maybe Howard prefer, where you have the mental and the physical as fundamental, and you kind of meet the middle-sized world in between those two in various ways, right? So that's a viable view. But the other views, I think, are implausible. So there's the old-fashioned phenomenalist view, just the mental world is fundamental, everything else got to be reduced to that. It didn't work out very well. There's very strong arguments against that. The physicalist is doing something equally extreme and even harder, I think, right? Which is take the quantum world as fundamental and everything else is reduces to that. Because there's no folk theory about the quantum world. That's the problem, right? There's no way to constrain the reduction, I think. That results in, at least I've argued, in the kind of explosion of middle-sized worlds. Because there's so many different ways. Ultimately, I argue almost any consistent theory about the middle-sized world is something that you can treat as grounded in the quantum world if there's no constraints. And basically, I think for the physicalist, there isn't any, so that's a serious problem. Yeah, let me just stop there. You sort of way too much.
All right, so our goal for this final panel discussion is to invite the speakers of the day to reflect on some of the themes that were broached. I'll start us off with a very general question, and then I want to allow for people on the panel to potentially ask one another questions if you were provoked by something that was said, but also we'll have opportunity for people from the floor as the discussion emerges to ask questions. So very general, it's hard because there were a lot of moving parts going on today, but something that covered many of you was, again, this issue that and Rob spoke about it in a certain way. So we have middle-sized composition and causality, both generally and then of animals, acting animals and human persons in particular. And so the challenge philosophically is how do we situate our understanding of these middle-sized categories and ourselves among them in relation to our best ever evolving theories of the sciences. And so I guess I'll ask you to kind of give a very big picture statement of how do you approach this? Do you prioritize one? Do you say, look, I take our well-confirmed theories in the sciences as starting constraints, and I try to situate best I can my understanding of human persons and of other middle-sized categories in relation to it, or do you methodologically, do you tend to approach it at a different angle? If you also have theological constraints that you add to the mix, how do those get situated? So, broad methodological question. What's your starting point? What's your instinct in terms of starting to think about this? Anyone want to volunteer to go first?
I always take kind of all-in approach, right? So science is important, experience is important, common sense is a good starting place.
So the instinct is there's got to be a way where these all mesh. And so it's not that I feel like I'm having to kind of put a thumb on, lean hard in one category. There's an optimism in what I'm hearing from Rob. The assumption, so I can approach this from whichever angle because it's got to work.
Well, if you're a bit pessimistic, metaphysics is really, really hard. So you want to take all the data you can, right? And arbitrarily say I'm not going to pay attention to that.
Okay, good. All right, I'll resist the temptation to go back and forth with people.
So maybe I'm resisting the question, but I think this is possibly the hardest question that has been raised so far in the conference, because it requires me as a human being to somehow well, yeah, in my colours to some mast, be consistent every moment of the day. I know shortly, and I'm very much looking forward to this. In fact, I'm hoping it comes a bit more quickly now. I'm looking forward to the G&T, when I will approach that as a middle-sized being and not really care about any other reality. So it's when Rob was posing the different worlds, I thought, well, I could go with that. Oh, no, I should go with that one. Oh, and sometimes I know. So I don't really want to answer the question with one answer, because I know that at different stages of my life and day, I deal with these things differently. Now, I realise that probably speaking to philosophers, that's an extremely unsatisfactory answer, but I would say, so what? I guess. Because these aren't the problems that I'm worried about. Is that might be cheeky in British English?
Perhaps, am I right in hearing sort of underlying what you did say is the thought that, well, we have provisional partial models that work. When I'm thinking hard about this one domain, I'll think using these categories. You're suspicious of the idea that we can have one illuminating, comprehensive framework that sort of fits everything, and we see how it all hangs together in a kind of detailed way, no theoretical questions. But that's
pretty good, actually. Yeah, I'll go with that one. Yeah.
All right, and so you've got that task you're not confronted with. It's just improving different models, somehow aware of what's going on in these other domains, and it's shaping, but it's not trying to fit everything into one model. It's just improving individual models in dialogue with the other.
I think that's right, and I mean, certainly in condensed matter physics, we don't have a central body of theory that explains everything. We tend to do a little bit of picking and choosing, depending on what problem we're trying to solve, in a sense, so problem solving.
Somebody over here had their hand up. Yeah.
One thing that worries me for a long time is whether we have a basic limit to our knowledge. So I was wondering if with quantum mechanics we are hitting that limit. And if that's true, then it's, well, yeah, we are struggling to get some coherent view, but we need to assume that there will be this incommensurability between these worlds. I like very much this idea of different worlds, in Penrose, in Popper. So, but on the other hand, it seems that our vocation, as being called by God to participate in His sanctity and communion, it seems that we are called to understand everything. So I don't know how to put together these two things: our vocation, our infinite dignity. There's a document recently about infinite dignity, and so this limitation in our knowledge. So maybe that's the place where grace, or so Martha was talking about this. So what is grace, or what is? So you think there's a
that recognition, I was going to say that instinct, but no, that plain recognition, we are limited cognitively, and so we're asking really difficult questions. Does that lead you not to worry then when you have a provisional model and you say this is obviously not adequate, it can't be the final answer, it somehow fudges the data on one side or the other, it doesn't seem to do full justice, but perhaps that leads you not to worry because it's not clear that we'll ever have the fully complete.
Yeah, well, I would say that so there is some gain. So science is provisional, but it's also irreversible in the sense that we gain in knowledge. So and there are truths that we reach, and so of course they can be improved, but they are there. So I think classical mechanics is not true. Quantum mechanics is telling something, maybe not the whole story, but I think there are fundamental ideas that will be permanent and will stay forever. So what else can we do? It's like if we asymptotically try to understand what's going on, well, who knows?
Robert, did you also have
guess I like common sense.
Okay.
but I guess I also we realise that when faced with the facts, I sometimes have to reevaluate what I mean by common sense. And also, I guess there's sort of maybe a strong sort of theological impulse. I mean, maybe this is kind of this kind of search for sort of explanation, something simple that can account for all the diversity in the world. I mean, there's a kind of I guess what physicists sort of search for beauty, some kind of simple principle. But there was a kind of a danger. I recognise the danger in that, because when something doesn't kind of fit into your kind of your explanation, you want to just sort of throw it out and just say, well, just try and explain it away. And so I think that this kind of search for simplicity is almost like there's a kind of danger that comes a kind of idolatry, where you sort of let this be your kind of fundamental explanatory principle. So I can sort of like with things like the many worlds, I can sort of I can see it's sort of a seductive attraction, but I bet that no matter how seductive it is, I can't reconcile it with my sort of theological commitments and my common sense commitments. So but I want to sort of see, well, is there anything in that picture that I can salvage better?
So we've heard from either scientists, philosopher-scientists, who tend to. Are you also a scientist?
No.
Among your many skills. Oh, I'm sorry. Okay, well, I was just to tee up. In one way or another, all of you have interest in fundamental science. So then we have 3 other people on the panel who are less focused on fundamental science as your particular way in. I'm wondering whether we'll see a contrast in what you might say about this. So please, Vera.
Yeah, so I think this is very interesting, because I don't have a science background, and I have a tendency towards the science first position.
Okay.
And so, and obviously, then the crucial challenge is how to account for causation and our understanding of middle-sized things in the middle-sized world. And so methodologically, so since we're talking about methodology as well, I'm inclined towards what philosophers call a conceptual engineering approach about those things. So the idea is that we should adapt our understanding of notions such as middle-sized objects or causation also to our goals and purposes. And goals and purposes could be things like normative considerations. So for instance, the relation between causation and responsibility very briefly came up in the discussion, and there could be other goals and purposes as well. And so those goals and purposes might not be derivable from fundamental science. And so I think, so according to my understanding, so that's how the higher level comes in at that point.
You would have a question about that, or feel like you didn't? Did you feel like any kind of elaboration? So this idea. So maybe I'll just.
Yeah.
Okay, you do. Yeah, if you
well,
want.
This is just a sort of priority perspective question. Does it worry you where goals and purposes come from if they're not rooted in truth claims?
Yes, it does worry me, but I don't think I have a good answer to that.
Yeah. So just I mean, if you're not familiar with this term, conceptual engineering, the idea is don't take as forever fixed our pre-reflective concepts that we bring to bear on the world, even about the way we think about human personhood, perhaps. Maybe in the light of science should lead us to science should very much be the animal pulling the cart here and causing us to update our categories where we that's a very rough kind of understanding of the approach. So you don't dig in and say, look, there are these fundamental commitments that have to somehow be respected. Okay, that's a very different sort of perspective. Now, someone has their hand up. I'm still mindful we have Christopher and Aaron, but go ahead.
Well, this kind of may plug into some of these big methodological questions. I'm interested, given that the role Aristotelianism played in a number of presentations. We also had the Wigner problem come up a few times yesterday, the kind of unexpected power of mathematics in science. I'm wondering, for Aristotelians, whether there's an analogous problem, the kind of unexpected explanatory power of an ancient metaphysic developed in a very different physical picture for the modern weird strange picture.
Not so ancient.
The word's not ancient.
I'm joking.
Sorry, all eyes are on Rob
I
here.
would give a kind of theological explanation of both cases, I guess, right? That, as Kepler said, right, God thinks in geometry or something. That seems to be the case, and we're doing these mathematical things to mirror his thought. And then similarly, my friend Robin Collins from psychology has done a lot on this, on sort of the fine-tuning the universe for science itself, not just for life, but for our scientific inquiry. So the world is soon to be organized in such a way that there's layers of the onion. As you peel back one, you discover, oh, Newton, and you peel back another, oh, Einstein, peel back another one, oh, quantum mechanics. So it's almost as if these middle-level sciences have been designed to give us little stepping stones to get deeper and deeper into the science. And so Aristotle's like the first stepping stone, right? So he was exploiting all of those clues, so to speak, that got it into the very naive science of his day. And he saw really deeply into them. And so I'm not surprised as a Christian, actually, that following in his footsteps is continuing to bear fruit.
Anyone else want to address the unreasonable effectiveness of Aristotle?
Yeah.
Ancient philosophy.
My next article, actually, right there.
Philip.
What I keep coming back to is kind of connects this is like, how does hylomorphism help us beyond strong emergence? That's been one thing, like taking middle-sized objects ontologically serious, maybe some kind of strong emergence. What does Aristotle or hylomorphism help beyond that commitment? Do we need that specific way of thinking about it, or I don't know. That's what I keep getting stuck on.
Yeah, I'm working on a paper on this. So I'm trying to show that Aristotle's middle way between nominalism and Platonism enables him to generate the Porphyrian tree of categories of taxonomy in nature. So if that's true, I think, and if you take it that kind of tree-like taxonomy is quite pervasive in science, then this is more another possible benefit for taking Aristotle's position seriously.
Yet another thing Aristotle.
Okay, I can pile on some more too.
All right, how about we'll go with you and then behind. Sorry.
Yeah, this is about the relationship between quantum theory and other sciences. It puzzled me when you say, because apart from listening to David Ellis for 3 semesters, I've got no science background at all. And I assume that, say, there are sufficient conditions, at the level of normal physics for why chemistry works, so to speak. So you can say, given that the atoms are doing this, it's not surprising that the molecules. When you said it, you can't get cups and tables out of quantum theory, does that mean that you couldn't see sufficient conditions in what's happening at the quantum level for why the next layer of things should be happening? And that's a peculiar and unique discontinuity, I would have thought, in the normal physical sciences. Now, is that what you're saying? And if so, why would anybody think that this thing was going on there to explain what they were? Is it just peculiar observations it explains, like the slit thing, rather than explaining any phenomena generally in the way that science normally operates? That's a question from ignorance.
Let's say about whether I think like quantum theory by itself, I guess you need to before you can explain anything, you need to suppose that there's kind of measuring instruments as well.
Complementary.
Yeah. So there has to be some complementary principles for quantum physics to have an explanatory power. I mean, because I guess even with it seems like in statistical mechanics, you have to kind of assume that reality is partitioned into systems, and that's not an assumption of quantum mechanics. It's something that but you need to make that assumption if you're going to draw any conclusions about go from sort of quantum physics to chemistry. That reality is partitioned into systems, I'd say. But I don't know whether that makes.
Well, I mean, I would say it depends which quantum theory you're talking about, because if it's the kind of basic quantum formalism, then sure, it's really pretty pared back. But I mean, we work with quantum theories of solids, which have tricks and tools which are able to build up the macroscopic, and I talked about one myself, superconductivity. So you can retrieve the macroscopic.
And you only need the measuring instruments to collapse the wave packet, don't you? So in each of the many worlds that's created mathematically, and they'd all have, until they went funny, ordinary macroscopic objects of some sorting. So as the wave packet develops its different forms, it's all giving rise to tables on the equivalent.
No, but you don't. The branches aren't there in the quantum mechanics themselves. You need something to give you that middle-sized world of branches.
I guess that you need some approximations in every level. So if I'm not wrong, to get the shape of proteins, you need Oppenheimer approximation. That means that the nucleus of atoms have to be treated classically. Otherwise, you don't get anything.
So we can't build up the macroscopic world from first principles. You always have to introduce approximations or effective field theories, or what they're generally called.
Those are informed from the middle level itself.
Yeah.
So that's why it's not introduced from first principles.
They're methodological tricks, effectively. I mean, they work extraordinarily well, but they are tricks. Dirty physics.
So do they just help us, or is it that without those, the thing itself wouldn't work?
That's the question, isn't it? I make the stronger claim. Yeah. Think I will.
All right. Do you still have a comment or question?
Yeah, I do have a question. Okay. Perhaps less Rob, who's proved himself to be a clear optimist. But the question really is a sort of theological one, or perhaps a sort of proto-theological one, Praeparatio Evangelica type one, which is how much, if at all, should the arguability of what we've talked about here, given that what we're talking about is quite fundamental ontologies, be of religious worry or concern? I mean, Father, you referred to threat, and I think Emily yesterday gave us reasons to think of Brechtian interpretation of quantum mechanics as, in some sense, religiously threatening. Is Rob's confidence about this too blithe, or too staunch, or is what we'll be talking about sufficiently murky that that it's just sort of epistemically good practice to start from theological bases which are clearer and better? So that's the question I'm asking. How much, if at all, should the particular sort of debatability that the thing we're debating here have for seeing the world in light, or seeing God in light of the world, really, actually, is the question. So there are obviously lots of theological presuppositions there as well. My part of that question.
Aaron, I could see you jumping in on this.
No, I like that question. My view is that disagreements don't really matter. These kinds of disagreements don't really matter on one way of thinking about that, because if you think of Christianity as a sort of, I kind of think of it as sort of it's compatible with many metaphysical pictures, and mere compatibility is really the sort of incompatibility is what drives it drives conflict, and And now, when you're looking at a bunch of different metaphysical pictures, there's obviously a question of better fit, and there will always be questions about which metaphysical pictures are of a better fit with Christianity. But I feel like those questions are always changing when science changes and when we take on more and more truths. And so part of the task of religiously committed theorists is to sort of remake their metaphysics in what they view to be the best fit with their kind of religious commitments. Certainly, at the minimum, to remake a metaphysics where there's direct incompatibilities, I think. And so, this is sort of connected with my background view about some part of the interest of philosophy is displaying the sort of complexity and flexibility of conceptual tools for building the foundations of theory. So I'm not so concerned that disagreements among us would have a worrying theological connotation, but that's because I think that the philosophy is pretty flexible.
This is a great question by something I'm really interested in, the way that various religious thinkers have seen quantum mechanics and this world not as a threat at all, but as an opportunity. So, just to give an example, you only have to go onto Amazon and type things like quantum healing, for instance, or quantum mysticism, to find, wow, amazing stuff there. So, particularly idealist versions of, some forms of good and Taoism and so on, actually, really, you exploit this stuff. But there's also Christian theology that really likes to play around with quantum theory. So you're probably aware of the whole kind of, the issue about Christology, the two natures of Christ. Quite a number of people have said, oh, well, wave-particle duality, isn't that a great way of looking at this? And there are many more examples like this. So it's been both a threat and an opportunity, I suppose, to Christian thought.
Can I put a little word on that, which is... I'm increasingly conscious of the origins of a lot of this stuff in the context of Nazi Germany. And a lot of this, the new physics was dismissed as Jewish physics, right? And it didn't conform to the kind of metaphysics of Heidegger. Heidegger thought that naturwissenschaftliche philosophy, which was being worked out, didn't conform to the proper geometrical proof construction. That wasn't the essentially German way, or what a proper neo-Kantian should do. And I really have learned a lot from Michael Friedman and Thomas Ubel of realizing the reason these folks were in Vienna was because they couldn't get jobs in Berlin, right? In the German Workers' Party, right? And sometimes I've sort of seen the critique that the radical empiricists were making at Carnap on behalf of these folks as a Protestant in Berlin in the 30s was very much, he was speaking up in defense of these people, saying, no, it's not what they've done away with, but the way they've done away with absolute space. They've gone deeper into the mystery of the world, and that's a profoundly kind of Jewish movement to kind of not conform to the kind of patterns of the current way of thinking. And I think what I've learned through that is a certain kind of piety and a certain kind of reverence for the things we don't understand, and not to sort of assume that because it doesn't conform to the way of current thinking that we just rule it out. And I think I really appreciate, Rob, what you said about expanding possibility space, helping people to see, no, you can think about this in this way. And I think the way in which these Jewish physicists showed a new way to do what you might call metaphysics, but by kind of rethinking the very substructure of the way we were talking, I find honestly quite moving. Almost in the spirit that St. Paul would say, I would rather speak one word of intelligible speech than 10,000 words about, the spirit of the age, right? So I've seen in my life an increasing sense of what I think Cardinal Newman wrote when he talked about physico-theology being religiously almost a temptation, there's something kind of religiously strange about the kind of physico-theological project, and a sense of the temptation to try and find where God is in the theory that we've constructed, or in the ontology of a theory that we've constructed. I think that's a temptation for Christian faith. We believe in one God. We don't believe in one worldview. And I think that's the kind of way I think about some of these things, which is maybe a little different, but that's how I think of it. I'm a constructive empiricist about the scientific image. I'm a direct realist about the manifest image. I'm trying to work out the metaphysics that makes that possible, and I think the metaphysics that makes that possible has to have a place for an organism. That's what I'm trying to work out.
Wow, is that time? That's something that I got final words.
Yeah.
I was expecting the more sermonic note to maybe come from Father Javier. Here it comes. Well, sometimes you can't predict these things. All right, let's thank our speakers.
I'm going to take much more time, or destroy many more things. We couldn't see you. No one can see you. All our tens of audience members out there. Very many thanks, and very much gratitude to William Simpson for coming to us. He's one of our researchers here at Pusey House, amongst a number of other places, but coming to us with this project and entrusting us to bring it to Oxford. And I think with his hard work and cooperation of the rest of us, it's gone pretty well. Although I have noted we've lost a lot of the scientists along the way, right? It's become a much more pious group as we've, not the scientists can't be pious, but we've lost the scientists who are, as of yet, perhaps outside of the fold, but by their own admission, by their own free will, they as some of them told me last night. But very many thanks, very much gratitude, very many thanks to you, William, for trusting us with this. And Robert Koons and UT Austin and the Civitas Institute have been a great partner and had a stoic voice of reason when we've tried to go down rabbit holes or William's wild thoughts was taking them a little bit too seriously, and Rob said, slow down, William. It's been a pleasure to work with you, and even at a distance. Professor Serks, who can't be with us right now, but quite enjoyed the day at All Souls College for allowing us into that place, the rarefied chambers of All Souls College, and then upgrading us to high table for dinner, which was a nice move on their part to under-promise and over-deliver. I've been told asked by Timothy if there's like a middle-sized pub crawl or something like that tonight.
I can't quite put it that way.
I think it was dancing you were asking about actually, but I'd say pubs are one thing here. So I know many of you have your own plans, but if you want to converge at some point for like a half-10, half-shandy, or a little earlier, for something like that, we could choose a pub. Maybe actually the Lamb and Flag at 9:30-ish would be reasonable. People could have dinner, and then if they want to go over there, I'm going to try to make it, but I had to absent myself earlier for a back issue, and it's mostly in order now. But I'll try to make it over, and anyone who wants to, we could have a drink, and I think, as you hoped, we could think of very little else. Yes. Now at 6 o'clock there is evensong here, and then benediction, and then G and T and T upstairs, which you're welcome to come to. That will be attended by our student scriptorium and the normal community of Pusey House, and any of you are welcome to one or the other of them. The second T is, tea like a cup of tea. The first one is tonic, and the G we all know about. Now, I will say nothing more except there is enough time just to take a trip up the Pusey Tower quickly for anyone who wants to. It's going to be slippery up there, and it's a health and safety nightmare. But You can see, if you don't mind heights and you don't mind health and safety nightmare, so you're taking your own risks, as our insurers make us tell everyone, you could follow me up the stairs. It's about 100 steps up, and we can still make it to evening prayer. So anyone who wants to do that, just stay here for a moment and we'll go up. Otherwise, evening prayer is in the small chapel at the front on the left, and we hope.
Let's give a thanks to Jonathan and Willie.
Yeah.